honorable speakers onto the dais. May I request our session chairman, Shri Sanjay Kumar Nirmalji, Additional Director General, MORTH, you know him very well, Secretary General, IRC. Please come on the dais, sir. So now may I request rapporteur of the session, Prasad, NIT Warangal. Thank you. Now, I'll call upon the expert of the day, Dr. Ambika Bahel, Principal Scientist, CRRI. Welcome, ma'am. Dr. Anjan Kumar, IIT Guwahati. Welcome. Welcome, sir. Then Shri K. Sridhar Reddy, Shreyas Institute of Engineering and Technology, Hyderabad. Yes, sir. Then we have with us through VC, Dr. Brexio Gomez. So you will be listening to him on VC session. Then I'll invite Dr. Nikhil Sabu from IIT Roorkee. Then another speaker will be joining us from USA, Shri Gordon R. Keller, Forest Services USA. Then I'll invite Dr. Sunita from NIT Tiruchirappalli. Dr. Sunita is here. Sorry? Okay, so we'll wait for her. She may join after some time. Okay. So, welcome, sir. Welcome on board. Welcome onto the dais. Before I start the proceedings, let me take some time to introduce you to our esteemed speakers, chairman, and the rapporteur. So, as you know, Shri S.K. Nirmal, chairman of the session, he joined MORTH in 1986 through engineering services, and he graduated in 1983 from MNIT Jaipur, and he's an MBA also from Podar Institute Jaipur, MSc in Road Engineering from Delft University and Technology, Netherlands. Shri Nirmal has participated in many training programs, and he was member of Indian delegation in 75th session of WPI meeting of UNICEF on road safety in September 22 at Geneva. And he is a recipient, we should be very proud of that. He is recipient of prestigious Pandit Jawaharlal Nehru Birth Century Award for his outstanding contribution to highway profession by IRC in 2003. Lifetime Achievement Award from Indian Geotechnical Society, Eminent Engineering Personality Award from Institution of Engineers. So he is well awarded and well recognized personality among us. So we are very happy, sir, to have you here with us. And then I'll just introduce our session rapporteur. Professor Prasad is a professor at NIT Warangal. He has obtained all his engineering degree from NIT Warangal. So that's really nice, sir. You studied and now you are teaching over there. It's really a great honor. Professor Prasad has executed several major consultancy projects as a study team member as well as coordinator. He is also the PTA, Principal Coordinator of the State Technical Agency, STA, and Principal Technical Agency, PTA of the PMJSOI program of the MORD. So now I'll take little liberty of introducing you to our technical session speakers. One by one, I'll just introduce in a very short. Dr. Ambika Bahel, she is Principal Scientist and she is heading Flexible Pavement Division at CRRI. She has a work experience of more than 15 years and has done PhD from IIT Roorkee in the area of warm mix asphalt. She has a rich experience in R&D activities in the highway sector in the area of flexible pavement materials, polymer modified asphalt, warm mix asphalt technology, recycling of pavements, use of waste materials. So, madam, with your vast experience and the knowledge, this session is going to be benefited a lot, I am very sure. Then we have Dr. Anjan Kumar from IIT Guwahati. He is currently working as Associate Professor in the Department of Civil Engineering at IIT Guwahati. He is specialized in transportation engineering. After obtaining his doctoral degree from IIT Madras, he worked as a postdoctoral research fellow at the University of Texas in USA. His research interest includes hot and cold bituminous mixes, sustainability, pavement technologies, pavement management system, and road safety. Welcome, sir, and we'll get benefited a lot, I am very sure, with your expertise. Then Shri K. Sridhar Reddy, Shri K. Sridhar Reddy is currently working as Associate Professor and HOD of Civil Engineering Department at Shreyas Institute of Technology, Hyderabad. He is also a research scholar at IIT Kharagpur. His research interests are performance evolution of pavements, response modeling pavements, and multi-scale behavior of concrete and asphalt material. Thank you, Sir Reddy, sir. We are going to get benefited, I am sure, with your expertise a lot. Then Dr. Brexio, who will be joining us through VC. He's a technical director at European Asphalt Pavement Association and is the focal point of EAPA for technical issues. He is also in charge of representing the asphalt industry in the CN committees related to asphalt and active contribution in European standardization processes. So we'll get a lot of experience, a lot of his expertise, what he has been doing outside India, out of India. So we'll learn a lot through his lecture. Then Dr. Nikhil Sabu, IIT Roorkee. Nikhil Sabu is an assistant professor in the Department of Civil Engineering. He has completed his MTech from IIT Kharagpur and PhD from IIT Roorkee. He has more than 8 years of experience in the pavement engineering. Some of his areas of interest includes pavement materials, rheology of asphalt binders, use of reclaimed asphalt pavement material in hot mix asphalt, pavement analysis and design, and pavement evolution. Thank you, Dr. Nikhil Sabu, for joining us today. And then we have Shri Gordon through VC. Mr. Gordon is a licensed civil and geotechnical engineer in California. He received his BS in civil engineering from UCLA and MS in geotechnical engineering from University of California, Berkeley. He worked with US Forest Service for over 40 years and is currently retired but continuously working and helping the consultants. So we are going to get benefited through his lots of experience. Then Dr. Sunita, NIT Trichurapalli. She has not come, but I'll just introduce her, and if she joins over. Dr. Sunita is an assistant professor at NIT Trichurapalli. She completed her PhD from IIT Madras. She is a member of STO of PMJSY program for Tamil Nadu and Pondicherry. Her area of research interest is on pavement materials and pavement management systems. So thank you so much, sir, and may I request now hand over the proceedings to the session chair and the rapporteur. My request to the rapporteur is to just have a small brief, because for each session, rapporteur's small brief we will be sending for the press release. So I'll request that if I can get that, I'll be sending it for the press release. Yes, thank you so much. Yes, sorry. Yes. I could see. My fault. I was a little quick and in hurry. So now, can we, we want to honor to our session chair and rapporteur and the speakers. So may I request, yes, NRIDA team to please come forward and please honor the session chair, rapporteur and all the speakers by offering a bouquet. Thank you so much. Yeah, round of applause to honor our esteemed speakers and the guests. Thank you so much. Thank you, team NRIDA. Thank you so much, sir. Session chair, may kindly please. Thank you so much.
Thank you for introduction and asking the chair to start the session. So first of all, good morning, everybody. And today, this is the session 4, and this is in the core heart of this 3-day conference, where we will be discussing new technologies in rural roads. There are 7 presentations in this particular session. Some of the topics which we will be discussing in this session may not be genuinely, you cannot say that they are new, because they are new maybe to the rural roads, but they are not actually exactly new, because they have been used for decades in many parts of the world. But still we are calling them new because they are not conventional. So, but still we want to promote that those technologies where we can have, which are eco-friendly, where we can have the cost saving, time saving, fast construction, and most economic use of our existing resources, because all these things which we have to see when we implement our rural roads. So that is why we want to promote such technology. So without wasting much time, because already 20 minutes are over in this session, so I will not waste much time. Time allocated to each speaker is 20 minutes, so I think 15 minutes we can have presentation and maybe 2-3 questions we can take. Because if I defer everything at the end, then maybe you may tend to forget, and only the last presentation may be in your memory. So we will allow maybe 1 or 2 or important questions after each speaker presentation. So first I invite Dr. Ambika Bahel. She will be speaking on application of cold recycling for rural roads. Dr. Ambika.
Thank you, sir. Yeah, good morning, everyone. So you started the address with the statement which I always give when I have to speak on new technologies, that I started my career 16 years back with working on the same technologies. Unfortunately, we are growing old, but the technologies are still new. I hope very soon they also become old. So today I would be speaking on coal recycling of pavements. I always mention this, that challenge is not to construct fast, which currently it is happening in our country. Every day there is a new record being made. So many kilometers have been constructed. It's good to be fast, but the challenge is also how sustainably we are constructing. Are we saving on natural aggregates? Are we developing infrastructure not at odds with the environment? So we need to look at those practices also, that how we can build but still save our environment. So a lot has been talked on this, that why we need these technologies. Yesterday also Mukesh ji emphasized that they adopted FDR because the cost was so high for conventional road construction. So this was a forced adoption, whereas I am saying since so many years, ever since I read that report, which is of 2016 on material consumption patterns of India, that we are depleting our aggregates. As per that report, which was released in 2016, we had aggregates only for next 20 years. So what are we going to do after that? So we should have adopted these technologies much earlier than now when we are forced to do it. But still, if we adopt in each and every state, I think we can save to some amount. This slide says all about it, that yes, there is scarcity of aggregates. In the lockdown, I had attended one of the management course, so I thought need to have some respite from being a researcher as well.
Slideshow mode कीजिए, because your content is cutting.
Thank you. Yeah. So there I was taught about when we need to economize a problem, we always have 3 options to dealing with any problem. So here the problem is about scarcity of the aggregates. So we have only 3 options. We either increase our resources, which is unfortunately not possible because natural materials have a limitation. We cannot keep on generating. Or we need to reduce our wants. That's again not possible because India is a developing country, and especially if you talk about the rural sector, the development is huge. There has been n number of reports, and even since yesterday the presenters are talking that the rural roads are the new highways. So it is a well established fact, because in the past 5 years the rural sector has shown growth 10% each year in the economy. So if I go as per the reports of the JP Morgan, so I think the 46%, which is nearly 50% of the national income, is coming from rural sector. So you can see the kind of development which is happening in rural roads. So I think it's high time we need to get away with this concept of ये तो रूरल रोड है, 30 मिलीमीटर BC या PMC भी चल जाएगा. अब वो नहीं चलेगा because the full force of development of the country is going to be the rural sector, especially the tier 3 cities. So we need to make our infrastructure accordingly. So Swadan, I am saying though PMC is a good layer, but definitely we need to build our roads stronger. As I said, we cannot increase our resources, we cannot reduce our wants. More and more roads are to be built. Even our Prime Minister has said he wants to connect each and every village of the country with the asphalt roads. So only we are left with is reduce, recycle or alternate materials. And at CRRI we are working on all these aspects. We are working on artificial aggregates, be it the slag aggregate, be it the waste plastic aggregate. We are even making plastic paving blocks, or be it recycling your existing road beds. So meanwhile they are doing these settings, I do not want to lose the time. So pavement recycling is basically a rehabilitation technology, and I always emphasize on we need to adopt the rehabilitation technologies, which is actually a rehabilitation. It should not be a bandage treatment of what I call is that very often it is a pocha treatment on the roads which is being done. So we need to properly rehabilitate where we are actually making the life of the pavement as good as a new one. So whether you're doing it with the reconstruction or by giving fresh layers, which consumes lot of materials. So there are three practices which are being adopted, out of which the first one is very, you can say is used very extensively, that is complete reconstruction. So when a conventional pavement fails, there are cracks, they tend to excavate the whole pavement layer and then reconstruct. So this is very, very energy exhaustive. This saves a lot of wastes a lot of material. It's not happening. Yeah. So the second one is thick overlays, which is also very oftenly done in our road construction areas, that we provide. We do not treat the cracks, but we are simply giving the thick overlays, which are again going to reflect back. What we are emphasizing on now is, and also just like Rural Roads has adopted, that is full depth recycling, that whatever is the damaged pavement or whatever is the lacking in your pavement, you recycle it with the same materials and maybe by adding some binders or some additives. I'm not touching the extreme corner, which is otherwise also not visible. So that is in hot recycling, we actually make the binder active, which we are not doing in rural roads, especially in low volume roads, though that's my main point. We should be doing, because bitumen is a very, very scarce material. We are already importing 46% of the bitumen which is being used in road construction, that is coming from imports. So even if it is a 30 millimeter bituminous layer, we should use that asphalt in an asphalt layer itself. And as this picture shows, this is just for an example that what we did in recycling. Till date I have done almost 15 to 20 projects. So what typically we do in this is that we recycle the top damaged portion of the pavement. So if you see, there was 10 millimeter of DBM and 50 millimeter of BC, which was completely damaged. So we recycled that damaged portion, and the requirement of new DBM was reduced by 50 millimeters, which led to a lot of significant structural improvements, and also it led to surface and base distortion problems were corrected. There was a lot of material saving. I will come on to this, how much materials were saved, and a lot of time saving as well. So recycling typically is, if we are applying heat, it is a hot recycling. If we are doing it at ambient temperature, it is cold. For my today's presentation, I will concentrate only on cold, and that too in place, because that is all we are talking about, in place, in situ, full depth recycling or cold recycling. So the cold recycling is known by CIPR, which is a partial depth, whereas full depth is FDR. Before adopting, as I emphasized yesterday also when I had 2 minutes talk, that we need to select our materials, we need to design our pavement very carefully. So before, even for an FDR for rural roads, when I see that there are so many projects going on and people are coming up like any material, you bring out any chemical, any additive or any stabilizing material, whatever is the base, you just mix karo, dalo, lagado, and it's done. It is not done because each additive, as I'm again emphasizing, does not work with all kind of granular layers. So before deciding on the depth, before deciding on the design, you need to understand the problem in the road itself, to which you are going to stabilize, whether it is a cement stabilization or it is a full depth reclamation and then stabilizing it, or whether it is a cold recycling. So when I say that you need to understand the problem, you need to know the pavement history, the pavement condition distress survey needs to be done. What is the existing strength in your base? What is the surface base or subgrade analysis? These are the parameters on which we decide that how we want to rehabilitate our pavement. Traffic level, expected life and cost, and there are many other factors. So by many other factors I mean, because in so many years when I've been doing these projects, there are n number of factors which decide how much would be the depth of the new layers, thickness. So sometimes I have worked more with the national highway contractors, so we give them the design that this is good to go for the next 10 years, but then they would say, मेरा contract 1 साल का, madam 1 साल का design दो, उसके बाद road गई. वो अगली एजेंसी देखेगी उन्हें क्या करना है. So we need to, there are many other unsaid factors on which we design, then our design changes from design life is reduced because now the agency doesn't want it to last for next 10 years. So there are many factors. So right treatment on the right pavement at the right time has to be done. So this is a picture of NH5 which I am sharing. So initially the whole project was like we are recycling the top 80 millimeter, but during the diagnosis of the pavement that to what depth we should be going, so there was 1 kilometer stretch where the whole pavement was cracked up till the complete depth. So there we did full depth reclamation. So when I say that you need to understand your pavement first, so pre-project evaluations are very, very important. Even when you are doing it for rural roads, see most of my projects, cold recycling is like 80 millimeter asphalt you need minimum. So, but in the same concept applies for a full depth reclamation project in a rural road as well. That when you are going to stabilize your existing road bed, please check the materials. Have one analysis in your lab. What is the existing strength? What is the existing moisture? What is the existing CBR? All these parameters kindly check in lab and then design your mix. So what we typically do is we do the core sampling in which we take material from each and every layer, asphalt layer, base, subgrade, and then also the pavement condition survey. I'm making all these points here because I am very much confident on this that very soon our rural roads would be having thicker bituminous layers, more than that 30 millimeter or 20 millimeters. So these all concepts will apply to them as well. So we need to check what is the settlement, heaving, potholes, all these things need to be studied well. Now coming to cold recycling, that where when do we define it is a CIPR or it is an FDR. So it is basically, after yesterday's session, so many people came and talked to me and they said, Madam, we are confused. What is stabilization? What is this FDR? And now this cold recycling. Now there is a bitumen stabilization as well. So I thought, let me bring out a little clarity on this, that what is which technology, whether they are all same or whether there is any difference. So partial depth is cold recycling. You can have top 50 millimeter, you can have top 80 millimeter, or even in some sections we have recycled top 40 with some of the base layer material. So when you are dealing only to the certain thickness of the pavement, the top, then it is a partial depth recycling and it is known as CIPR. But the moment you touch till the base course, which is now we are doing in FDR, so that is a full depth recycling. Now once you have done the recycling, whether it is a full depth or a partial depth recycling, so all these are different names given to the same technology depending upon which layer you are treating. Basic concept ek hi hai, there is no much difference in that. But very important to understand whether you are doing full depth recycling or you are doing partial depth recycling. This is very critical. If you are not checking your subgrade, you are landing in a problem. If your subgrade is weak, you may do any kind of stabilization, it is going to fail. So the critical point is subgrade. Do check your subgrade. Typical difference between cold recycling and full depth recycling, I've tried to show with this picture that cold recycling removes a top portion of the asphalt layer, and it processes the suitable, this process is suitable when base is in good condition. We recently did a low volume road project where there was only 40 millimeter BC, and under that it was all the granular layer. So we recycled it. So the 4 packages of Andaman is done with this technology, and I have been involved in all those packages. So you do recycle even if there is a 40 millimeter. So that can be done with bitumen stabilization. This process is suitable when cracks do not extend to the full depth. I'm again coming on to the same concept that whereas in FDR, the moment your cracks are till the bottommost layer, then you go for full depth reclamation. Both the technologies gives you cost saving by reusing the existing pavement materials and done in place. So what cold recycling exactly is? It is defined as a rehabilitation technique in which the existing pavement materials are reused, irrespective whether it is a thicker asphalt, it is a thin asphalt, or it is a granular layer. You must be hearing all these names: foam bitumen, emulsion, BSM, FBM, CIPR, additives, FDR. These all are under the same umbrella. This is the same technology. The difference is only coming when which layer you are treating, what additive you are treating. All these foam bitumen, emulsion, chemical stabilizer, cement, fly ash, they all are nothing but just a binding material. So you need to decide your binding material and then design accordingly. If the existing pavement structure is adequate to take loads, then simple pulverization is done and regrading is done. No requirement of additional additives is there. But if a structural enhancement is required, then comes the role of stabilizing additives, and the type of agent which needs to be used should be selected. Again, I'm again and again bringing this point that it needs to be selected on the properties of the existing pavement material. Do not decide on the properties of the additive. You need to decide on what properties we want, because which material you are going to treat. Few glimpses of various projects. These are just few, but we have now done almost 18 to 20 projects of recycling, where we have treated from 40 till 100 millimeter of pavement with recycling technology. Low volume projects also we have done with cold recycling. Few pictures of that. And then a PMGSY project, which yesterday also few of the presenters showed these slides. So this was done in Nagaland, so one of my favorite project site. It's a memorable trip I had there. So this is again a very good project. The pavement, as I was told yesterday by Elmer, that they constructed it last year, so even without an asphalt layer, till today it is working very fine. Though I'm not very happy with that, because a stabilized layer should be soon covered with an asphalt layer. You should not test the resilience of this layer to that extent that ek saal ho gaya and still there is no asphalt. But yes, that is the testimony that the stabilized base is still taking traffic without any asphalt layer being provided there. So these are the various steps. So you can see that here again a lot of debate is going on whether we need to add aggregate or not. So again the same concept, whether you are looking for strength enhancement, in which layer you are building, CTSB or CTB, which layer we are building, accordingly we need to see. So here some aggregates were used because the inbuilt inherent property of the material was not that good, and this is then the spreading of the additive, and this is stabilization taking place, and this is the pavement. So I could click this picture with the kids. They were very happy that a road is coming. This is 2019, so they were very happy that they would be going to the school and there would be a pakka road to them. So again, a PMGSY tagline that yes, they are connecting people. So what do we do in a typical cold recycling project? The project design involves 2 stages. That is the mixture design and the pavement design. The asphalt mixture design is carried out in 4 stages. We first do the field sampling. Please do the field sampling. Check your material, what the base material is. Then only select on the cement dosage or the additive dosage, and then the material testing has to be done. Then you select on the additive, which additive needs to be used, and then the laboratory mix design, and you check your parameters. In a typical design procedure, first we obtain the reclaimed material. I would not say wrap because that is, we don't have thick asphalt layers here in rural roads. So obtain your reclaimed material from the field. Do the gradation. If you are getting some aggregates in that, select the amount and type of additional aggregate if required, and then select the type and grade of additive. So here I have mentioned emulsion foam, or maybe your Zydex, Stable Road, or Geocrete, Basil, whatever are the additives. You need to decide after checking your material properties, and then estimate the recycling additive demand. Pre-moisture content is very important. Then you do run some trial mixtures in your laboratory, and then establish your job mix formula, and some adjustments needs to be done in the field. As I was given the topic to talk on cold in place recycling, so most of the projects we have done in India is done with foam bitumen, though emulsion can also be used. So in foam bitumen, typically 2 to 3% of water, 2 to 3% water is added when the bitumen is very hot, and the bitumen expands to 20 times of its volume, which gives a very good surface for the wrap material to be coated. And as in emulsion, you have IS 8887, so many test parameters. For bitumen, you have BIS 733, so many test parameters you need to check that whether your bitumen or emulsion is of the good quality. In foam bitumen, there are only 2 parameters which needs to be checked and maintained.
Madam, please wind up.
Yes, sir. So expansion ratio and the half-life time. As I said, this can be done with both emulsion and foam. Again, what strength you are looking at. Emulsions give you a little lesser strength, whereas foam bitumen gives very good modulus, a high modulus. So depending upon your requirement, strength requirement, you can choose the additive, and then make samples. A typical mixed design has 2.25% of foam bitumen. The same things can be then done with bitumen emulsion. 1% cement is added. And then you check the dry ITS values. Those are the design parameter, resonant modulus for a CIPR mix. Typical project pictures from a site execution. Again, the same aggregates as per the gradation requirement are spread. These are the steps. Steps are same. What we are doing in FDR, it's just the layer is changing. And then very important, checks needs to be done on site. Your foaming parameter needs to be checked, and yes, the compaction achieved needs to be checked. The green effect, what we actually achieved, as I was saying yesterday, that we need to measure it and bring it on paper, how much savings we could do. So for in this one particular project where we did a recycling on a national highway, so approximately 80% of recycled aggregates were used and 60% less bitumen was used for construction, so which landed me that I could save almost 13,600 tons of carbon dioxide emissions, and almost 3 lakh tons of aggregate was saved, and 10,540 tons of bitumen saving was there. Similarly, the green effect of a low volume road project, so we did full depth reclamation in Andaman, so when we measured, so we could save this 2 lakh tons of aggregates in just 45 kilometers, and emission reduction was almost 6,000 tons of carbon dioxide emissions. Now the big confusion, I would take a minute on this. We also need to make our, now with the increasing demand and the application of this technology, we need to, I would say, streamline our codes as well. It is, you know, many times when we are designing the projects, the contractor comes that, or the implementing agency or the authority engineers, that this is the material, okay, itna UCS aa raha. Then I say that as per the code, you need to have at least 4. Okay, madam, आप 72 के हिसाब से डिज़ाइन कर दो. It's like, okay, then you need to have a upper layer. अच्छा नहीं है, फिर 89 की तरफ से डिज़ाइन कर दो. We need to solve this confusion, you know. All the codes, guidelines, they need to be streamlined. And since I am on board with IRC as well, so we are working on this very soon. FDR document would be there, which will streamline, because when we are talking about FDR, you are using the marginal material. You know, there is a saying that if you are having a Maruti, don't expect the luxury of a Maserati. So that is what we are currently doing. We are doing FDR, but we are thinking to achieve the parameters of a cement stabilization of a conventional layer. So we need not to do that. With an FDR, there are different gradations required. There an FDR with different UCS values would be required. So we are coming with that soon to end this confusion. Failure and concerns are very important on what aspects you need to take care when these technologies fail. So bitumen road, whether it is a rural or a conventional, they are very, very material exhaustive. Even the best of technologies fails if they are not implemented properly. So you have 4 layers. Each and every layer is very critical. Concerns in a cold recycling project, your wrap temperature
Madam,
is very
please,
important.
please,
Last
come on.
minute, sir. So okay, I will skip this one because this is more important. Concerns for FDR stabilization. So temperature cracking, traffic related cracks, you need to be very, very cautious on the dosage of the cement. This picture is showing 3 pictures where we could have full depth core with very good strength, but then also at one side there was a full depth cracked core, because the cement dosage was not proper. Maybe the additive dosage was not proper. So this also happens. I would again emphasize that we should not go for manual spreading of the additives or the cements. We should go for the automatic spreaders, because then you can control. And even when you are working with machines with automatic spreaders, kindly do have a check. Even machines sometimes they do show errors. To avoid that, do have a, in civil engineering we say jugaad check. So oftenly you need to do that jugaad check so that you can check that your machine is spreading to the same extent which is required for your pavement. And anything and everything concept is very, very troublesome. This is what I see which is happening. Any additive will work with any base layer material. It doesn't happen. So choose your additive very carefully. Not all additives work. The last one, Dr. Nikhil would be talking about waste plastic a lot. Just one concern, since we are also working a lot on this. I have seen this technology, waste plastic technology, from asphalt going to a trash fault, because the size of the plastic, the type of the plastic, and the dosing type,
Madam,
the
please,
addition.
please wind up.
Last, sir.
Yeah,
Sorry.
please wind up.
Yes, so we can discuss if anybody wants to know about this, the concerns on waste plastic. So there are many roads which have failed, and this is the major issue, that the quality of the waste plastic was not as per the recommendations. Thank you, sir.
Okay, thank you. I understand that it is very difficult to combine all these, everything what you want to speak in 20 minutes. But we have, structured this particular session in such a way that let each and every speaker get enough time. Otherwise, at the end, it will be just rushing through. So please see your time management. So the next speaker is Dr. Anjan Kumar. He is talking on intelligent compaction for improved performance of rural roads.
Very good morning, everyone. So today I'll be talking about utilization of the conventional technique in a new format, that is intelligent compaction for improved performance of rural roads. So since last day, we have been discussing about various new technologies, additives, including waste plastics, and including a lot of recycling techniques. But this is one line very much clear: we target for improved performance. So I would like to take 2 minutes and ask ourselves, what was the lacuna in our conventional practice? What made us to use these new additives? Whether our conventional roads didn't perform for the decades or centuries worldwide or in India? So what is that we miss to understand, that how do we escalate our quality, escalate our process, get in with the technology and make the conventional practice works? Yes, whenever there is a challenges, we need additives. But Let us take a look of 2 minutes, and remaining time we all will go through the technology advancement. And I believe, I'm sure you all agree with me at the end of this 19 minutes which have been given to me, that yes, this is the technology forward for the largest infrastructure growth in the world which the country is witnessing right today. So my overview would be just to see the conventional technology associated with cost, associated with performance, what is our choice, what is our composition, and mainly, are we doing control or are we just checking? So there is a clear-cut demarcation between control and checking. So we would try to emphasize and relook ourselves where we stand. So why rural roads such a new fancy technology? No, this is not a fancy technology. Such technologies are used to build cricket pitches, tennis courts. Why not our rural roads? So yesterday, the ministry and also bureaucrats were just mentioning, yes, we have around 96% of the roads, and the rest 4% carries the entire traffic. So I would like to just make a cost comparison in the practice, that is where we transform design to reality. So approximately, when I reviewed the last night NRIDA database, so far we have constructed around 788 kilometers, 88,185 kilometers. This number may be approximate. Let us see the statistics with that. And yesterday we had a lot of presentations from the technology providers. More or less, most of our rural roads would have 4+ lifts or layers. These lifts could be contributing from embankment, subgrade, granular subbase, base, and your bituminous surface treatments. My cost of compaction, yesterday Sakai mentioned, okay, conventional roller consumes around 14 liters per hour. Even MRTH, SORs, conventional practices, always they mention somewhere the cost of road conventional rollers is around 500 to 600 rupees per hour. So on an average, considering the escalation in the fuel prices, if we consider around 1,000 rupees per hour, and consider as an 8 hours of working day, we construct around 1 lane kilometers or 1 kilometer length of a single lane road with the materials, either it could be soil or granular materials or bounded materials. The cost turns out to be so far what NRIDA or the Ministry of Rural Road has spent on compaction is close to 2,500 crores, that is 2,500 crores only on compaction. This cost excludes the cost of material and other associated costs. And this cost is also close to, as we have spent in national highways, constructing around 1,35,000 kilometers. National highways have spent around 2,500 crores, but rural roads have spent 2,522 crores. Again, my numbers may not be correct. This is a typical calculation showing the importance of compaction. Yes, we all believe the only highway construction activity which translates our design to reality is compaction. So the highest importance has to be paid to this activity which translates our design from paper to practice. How do we check the control? Are we really calling this as a control? So what do we do in control? We go check moisture, we go check density, and we go check the lift thickness or the layer thickness, whatever we are placing. Whether this is sufficient actually to define and call it as a quality compaction? No, not at all. What we are doing is a typically checking, either it is a quality control or assurance. Once the layer is constructed, we go check whether the moisture is as per the laboratory or density is as per laboratory, which cannot be met in roads because these are developed by a single parabolic curves, which is very, very important to understand how do we design our targets. So the consequences are this. Always there is a variability which is inherent or inevitable. So always there is a variability in our performance. Always there is a variability in our target. This is inevitable. But what we have done to address this? Not always selecting a new material, looking for a new material can solve this problem. This can aggravate this problem because we are bringing in the complexity by varying the material properties or just incorporation of new materials which we don't have any knowledge about its mechanical behaviors. So this variability, yes, we could have done something wrong during material testing, roller parameters are not properly identified, site engineer may not be well trained to assess the properties, there could be operator error, roller operator, quality control itself may go wrong. So what we are typically seeing, we are constructing thousands, lakhs of kilometers of road, and for a 300 square meter, 500 square meter, we go just do a point test, which doesn't even account for the layer property or the material property. It is just only checking to ensure the process was right and the material would have got its, reached its density or the layer thickness which was targeted. But unfortunately, we are not mapping the entire area. As a consequences, what we see here is, even though we meet compaction requirements, sometimes roads performs. And sometimes even meeting compaction requirements, what we measure conventionally, what we call it as quality control, our roads may not perform. Study Minister was targeting and asking us and giving us the responsibility why a rural road user should feel the discomfort whenever he or she enters a rural road. Yes, the differences should be there in road environment, but the differences should not be there in a substantial variation in riding comfort or the comfort desired or demanded by the road user. So what do we do for that? So if we go with the conventional practice, we will end up with a lot of variability. Our design principles, we take a discrete value and design. Yes, with the updated mechanistic payment design principles, we do account for the variability, considering the material variability, construction quality variability, testing variability. But from where that variability accounting parameter came from, whether the database is completely mapping the area? No, not at all. Again, they are based on some few number of tests. So how do I go about this? What is our need? Yes, we need to have a real-time monitoring of compaction. I need to get a feedback when my roller is on my material, not once the roller has completed my compacting my material. I need to act before the layer has been completed. I need to document. I need to understand how much uniformity I have accomplished. I need to understand how much quality I can assure. I need to accomplish what I give back for what I paid. So we need to have a quality control definition. We need to first monitor the process, understand where the variability is going, where the quality is going out of control, act upon it, and then check tests which are very well accepted. So the answer for that, which started in 1950s, which evolved in 1970s, which became specification in early 2000s, which has been practiced worldwide, and as well as now in India, we have intelligent compaction system. So what does this intelligent compaction system does? It documents complete compaction process starting from the point when the roller hit your material. So it gives 100% mapping, it gives database development, it makes us to help where the layers have gone wrong, why the payments are failing, why the payments are performing, and how do I make my payments perform better. So intelligent compaction, technically if I define, it is a continuous assessment of mechanistic properties of payment materials. Either it could be stiffness, modulus, or density through roller integrated vibration monitoring system. Yes, we need a vibratory roller. Static rollers may not give us any feedback. Yes, we need a vibratory roller. And this system should give a flyback, that is real-time display to the roller operator, site engineer, quality control units, site officers, that how the compaction process is going on. An integrated global position system should be simultaneously synchronized to see whether the complete rolling has been done, complete compaction characteristics has been achieved, and uniformity is maintained. So I'll just play this video, 1-2 minutes video, so that we can understand what is intelligent compaction is about.
Positioning system technology to give the operator a real-time view of roller pass coverage and ground compaction or stiffness. The IC systems also can transmit the data to a remote location where it can also be monitored, saved, and studied. Data is also saved on the roller's onboard systems and can be downloaded for analysis. There are 3 approaches to determining IC measurements and are based on analysis of machine-ground interactions. One version is based on frequency domain analysis of accelerometer data and calculating the ratios of the amplitudes of the fundamental frequency and other harmonics. Another approach is to use the accelerometer output to determine force displacement responses using dynamic models. A third method is to monitor the machine power which is a function of drum sinkage and works for vibratory and non-vibratory roller operations. The IC values measured from these methods is an integrated response of the material stiffness under the roller to depths of approximately 1 to 3 feet.
So this gives a very good overview of visual illustration of what an intelligent compaction roller can do. So the typical components includes a conventional vibratory roller, an accelerometer, an integrated GPS system which records the spatial coordinates of the roller during compaction. So technically how the intelligent roller works is it uses 5 levels of analysis. Either it can be based on a spectral analysis, force displacement analysis or energy to profile. So the basic mechanism is to understand how the material responds to the compaction force exerted by a vibratory roller. So if we can able to understand this relation, then we can accomplish quality compaction for 100% of the area. So there are various proprietary developed this roller measurement values. Either it can be conventionally compaction, continuous compaction values, or it can be force displacement based modulus or stiffness modulus, or machine drive powers which are based on energy required to propel your roller drum. These are all very conventional. So ultimately, whenever we are using this intelligent compaction roller, first we need to establish a relationship between these roller measurement values and our conventional test. Such test either it could be your density based or modulus based, and develop a target value for your roller measurement values. So these roller measurement values, when you color code it and assign to the roller system, it will give a feedback to the roller operator, site engineer sitting in their office or anywhere in the world to see the compaction is done to the required quality. So one can map the entire compaction process of each and every layer and identify the weak areas, identify the areas where the compaction has to be reworked or a material has to be changed. QA/QC, it can be various processes has been developed and specifications has developed. I will just bring 3 simple QA/QC process how we can use this intelligent compaction. So first of all, from our association between the roller measurements and spot test, we have to identify, okay, which is my low area, weak area, high and poor areas. So what is your target roller measurement values? From that, whenever we complete a test section, wherever the color coded roller shows that as a weak area, that is where the density might be low or the stiffness or the modulus may be low, you go just do a quality control test on that. There, if your section passes your density or modulus, rest assured the entire section of interest meets your density or compaction requirements. This is a very, very simple process of QC or QA. The advances include various variation in this roller measurements values. Second option is you can specify between pass 1 to pass 2 or pass X to pass Y. The differences in the responses of the material cannot be greater than some X percentage. That will assure you, yes, the entire area is compacted to a required quality. One more option again, you can always make sure that yes, I am constructing 1 lane kilometer of road. I want 99% of area to meet this density, modulus or a roller measurement value property. I can exclude only 1% or 2%. I don't want to take risk and compromise my performance. Such options are also available for QA and QC. So technically, if I illustrate this, this is what the real-time feedback we all get. We can map the initial ground conditions, we can map the layer conditions, and we can see what compaction has done after the process has been complete. We can see the variation in data, we can account for variability, we can account for improved performance, we can account for fine-tuning our design philosophies. Yes, there are associated cost benefits and technology benefits, which I am just highlighting here. What are all the specific properties? I am summarizing. As you see, yes, there could be a little cost investment made, close to 5% higher than what we make for a conventional roller, but the benefits what we get in terms of compaction, whatever the literature says, is minimum 25% reduction in per lane kilometer. So we would have spent around 2,500 crores on compaction. in the future we will be spending this same money. So if we introduce this technology, minimum 10 to 20% can be saved on compaction. Not only on compaction, see the associated time, the associated emissions, associated over compaction problems, associated lower compaction problems, associated data unavailability. So most of this can be answered when we have data mapped, when we have a continuous monitoring system. So with this, I would just like to summarize, yes, we need to map the entire area of our compaction. We cannot rely constructing the world-class infrastructure on spot test measurements where he or she go do a random number testing or random sample collection and justify or certify my quality of work with 5 test points or 3 test points. I believe all our SQMs, NQMs, and all academicians, experts, industry practitioners will agree with me the uncertainty we face whenever we go do a sand replacement method, especially for rural roads, which has waterborne macadam, different additives. But still, yes, we are trying up our best and we are trying to maintain the quality. But the one way ahead is to go with the technology, use the technology, evaluate and modify to meet our requirements, and make sure we all achieve sustainability by constructing better performing roads. Either it could be rural roads or our national highways. All roads deserve the same user benefits. So yes, we need to monitor the quality by constant feedback process and control whenever the process goes out of the control. Either it could be variation in moisture content if we are dealing with granular geomaterials. Yes, if we are dealing with asphalt, the variation could be temperature. You can check with the temperature variations or the profile variations. Quality compaction results in a lot of savings in time and cost. Also, studies have highlighted there is minimum 18% reduction in the overall roller operation cost when we go with intelligent compaction. Yes, undoubtedly the road performance would improve because we are giving it what it desires, that is the compaction, right compaction. Reduce pollution with all associated reworks, with all associated poor performance, with all associated over compactions. So with that, the greenhouse gas emissions would also reduce and we can also contribute for a sustainable development of infrastructure. So I stop here and I thank for giving me the opportunity to express my experience on intelligent compaction. Thank you very much.
Thank you, Dr. Anjan, for maintaining the time discipline also and bringing out important compaction technique, I think, which is the future technique which can be adopted for a sustainable construction. The next speaker is Dr. K. Sridhar Reddy. He will be talking on design of short paneled concrete pavement. But anybody can, I think they should come automatically or no time already. Anyway.
Speaking about, yeah, well, I'll be speaking about panel concrete pavement, design, construction, performance. This is the presentation outline which covers the concept of short panel concrete pavement, where we also discuss about the literature review and then design, construction and its performance. Well, we all know that there are different types of rigid pavements we have in our practice, namely JRCP, CRCP, JPCP, and nowadays we have seen coming up the technology called precast technology into the pavements. Well, jointed plain concrete pavement is very common on our Indian highways, in fact in rural roads as well, but the regular size of the panel is about 3.5 meter by 4.5 meter. And our guidelines, IRC 58 or IRC SP 62, ascertain to certain specific sizes of the panels. One has to make sure that the guidelines are applicable for specific sizes of the slabs. Well, these existing guidelines are performance-based design, and they are mechanistic empirical pavement design guides, and they'll only provide the guidelines for the specific sizes and for the specific performance criteria, not for the different types of cracking modes. Well, the moment we talk about the new technologies like short panel concrete pavement, with the due advantage from the white topping concept, it is a proven technology. So we have been slowly adopting the same white topping concept onto the lean concrete base layers. So putting the panel concrete slabs over the lean concrete bases has become new technology in our country. And the key principle of this technology is to select the slab size in such a way that single set of wheels can be laid on single slab at any point of time, not the entire axle. So we are delimiting the loads and we are scattering the loads over the large number of panels. And then this short panel concrete pavement is purely dependent on underneath layers. Its strength is dependent on underneath layers. How strong the base is, how strong the sub base is, how strong the subgrade is. Because as soon as you reduce the size of the slab, it tries to, the load that you apply on the slabs, they'll penetrate, they'll give a vertical kind of distribution into the foundation. So therefore, the strength of the underneath layers are so important when we go for the short panel concrete pavements. And as you all know, as the length of the slab decreases, the curling stresses, the thermal stresses that are going to be reduced. Concomitantly, the thickness of the concrete pavement that we design for is going to be lesser thickness. So since there is a lesser thickness, there is a lot of savings in the materials. The moment we say lot of savings in the material, there will be obviously cost benefits, right? And moving on. So the concept of short panel concrete pavement is all about the providing number of closely spaced contraction joints. They are not the construction joints. They are contraction joints. They are intendedly provided to relieve the flexural stresses that we typically see in early hours of the pavement construction, and where we can adopt the number of slab sizes ranging from 1 meter to 2 meter, 2.5 meter. So we can go up to 2.5 meter. But at present, our IRC SP62 can suggest only 2.5 meter to 4.5 meter slab sizes. So this short panel concrete pavement will give the opportunity to designer and the practitioner to choose whatever the slab size that they wanted to. And then the load transfer mechanism in the short panel concrete pavement is dependent on aggregate interlocks. As we reduce the panel size, the joint opening has become lesser and lesser at every joint. Even all the joints subsequently cracks over a period of time. The joint opening that comes with the temperature changes would also be very lower. So therefore, we can rely on aggregate interlock a lot in short panel concrete pavement, but not on any other external load transfer devices. So therefore, no double bars are required or no tie bars are required in short panel concrete pavements. We are purely relying on aggregate interlock load transfer mechanism. And this is one of the pictorial representation of one of the test site in West Bengal. This was the very first test site in our country for the short panel concrete pavement, which was initiated by Professor Pandey from IIT Kharagpur, and this was constructed in 2011. Well, when we look at the physical representation of the short panel concrete pavement, the top view will provide more insight about how loads are going to be scattered over the large number of slabs. And then you can also look at the profile view of the short panel concrete pavement. Some of the joints may be cracked, some of the joints may not be cracked. So it is all dependent on how the stress is going to be relieved and at what point of time the stress is going to be relieved. And the literature review says the moment we introduce a new technology, everyone has got a fear about what could be the problem if we introduce this technology into our rural roads. The problems typically, what the perception of the people is, it is all about the riding quality. It is all about how the load sharing mechanism going to happen between two panels. And first of all, riding quality. The second one is the load transfer mechanism. But what literature says, have a look at that. The literature says that the first ever construction report and our guidelines are so limited to specific panel sizes in accordance with axial spacing, axial dimensions or the vehicular dimensions. But when we look at the literature review, the literature review says thinner slabs, short slabs does not require any load transfer mechanisms. And the first ever construction report from Michigan State of USA, they have well documented about the construction of short panel concrete pavement, and they have observed the riding quality of the short panel concrete pavement. They have laid these short slabs on different types of base layers, ranging from granular base layer, asphalt treated permeable material, and then bituminous blanket. So the roughness index was so high in the case of granular base layer when compared to the asphalt base layers. And then riding quality is better in the case of short slabs compared to the longer slabs. One of the case study indicates about it. And the load transfer efficiency, as I told you earlier, as we discussed in the last slides, as the joint opening at every contraction joint is so small, so the aggregate interlocking is ensuring about the load transfer efficiency. So short slabs would have the load transfer efficiency as high as the jointed plain concrete pavements. And here there are certain guidelines across the globe, especially when it comes to the short slabs. Chile has got practice of introducing these short slabs on highways and their on their national interstate highways or national highways, right? Their guidelines simply assume that when the slabs curls up, the slab curling portion, the lift off portion is 1/4 of the slab length. But we never know, they did not know how this lift off portion is going to be, and one has to quantify it. We have been trying to understand how much amount of lift off portion is going to be there in the short slab and as well as the longer slabs, right? Well, there is a research gap. There is no specific design methodology. There is no performance data available for short slabs. One has to construct the test sections and then one has to monitor the performance, and the design has to go in accordance with the performance data only, right? Moving on, so we shall discuss about the design. The design has to come from the theory. Initially it has to come from theory, and how we model the foundation is again a question. It is a challenge for every practitioner and designer. Well, for our guidelines for JPCP or IRC SP62, we have been assuming that there is a Winkler foundation. But with the adoption of new technologies into the base layer, sub-base layer, as we have seen in the previous speaker's slides, there are many technologies that has come up. When we use different technologies to improvise the base layer, sub-base layer and subgrade, and with the different compaction methods, right, they have become very strong layers. They have become cementitious layers. So therefore, their elastic modulus is going to be increased. When there is no shear modulus in the material, adoption of Winkler foundation is well. But when the shear modulus of the material comes into the picture, when all elastic constants of the material comes into the picture, it is bound to adopt elastic layer foundation. So therefore, for all the base layers, sub-base layers, subgrade, we must consider them as realistic layers when we model it and when we look for the stress evaluation, right? Well, we have been in the process of designing the short panel concrete pavement. We have been considering the different panel sizes ranging from 1 meter to 2 meter, and there are different load levels, whereas in IRC SP62 they will only impose the single load, and whereas the thickness of the PQC that we have been considering is in the range of 100 to 180 mm for low volume roads, and then the temperature gradients are as similar to the IRC 58. There is a large database that has been created by CRRI, IIT Roorkee, IIT Kharagpur for temperature gradient. The same temperature gradients have been adopted here, right? And the base layers, well, cement treated base layer, WMM or WBM can be adopted with the different sizes, different thicknesses as per IRC SP62. Only change is the top layer. So this is the physical representation of the finite element model, where we have been considering it as a single slab model, although it has to be considered as multi-slab analysis. But for our national highways, we have been completed with multi-slab analysis, but for low volume roads at the initial stage, since we do not have any data to calibrate our finite element model, we have been considering single slab model. Right, moving on. So, well, we all know that there are critical load positions the moment we say concrete slabs, right? What we all know is edge loading, corner loading, interior loading. But for our IRC guidelines, JPCP, IRC 58 and IRC SP 62, we consider the edge loading is the only critical load and rest of the loads are not critical. But with the adoption of this new technology, short panel concrete pavement, our load positions are going to be changed because different wheel sets are going to be placed on different slabs at different locations. So corner has become critical now, edge has become critical now. There will be a edge loading for the longitudinal cracking, and in addition to these three common critical load positions, we have got another critical load position for top-down transverse cracking. So here we are considering our short slabs for corner cracking, transverse cracking and longitudinal cracking. And these are some of the stress charts. We have been trying to understand how the stress is going to be varied with the foundation stiffness. Well, we all know that the foundation stiffness more than 280 megapascal per meter would not change anything in the stresses, but anything lower than 280 megapascal per meter would change the stress values in the top layer. So these are some of the stress charts for 80 kilonewton load with a positive temperature gradient with a change of CBR values ranging from 4% to 12%. And these are the stress charts for 1.5 meter. These are the stress charts for 1 meter panel, 1 meter square panel. All these are square panels, right? And we have been developing the stress charts for different magnitudes of load levels because all our low volume roads are sooner or now they are going to experience quarry loads from the villages. There will be small quarries, small trucks would play on it. So the truck traffic needs to be considered in this low volume road design. But what we have in the current guidelines, it talks about only single magnitude, load magnitude. And we don't bother about the different load magnitudes and different load positions. Right? When we compare the stresses between 1.75 meter panel and 4.5 meter slab of transverse joint spacing, well, there is a huge difference in the stress values, stress magnitudes, right? The second decimal would also important in this fatigue damage analysis, right? So here, what we have been trying to develop is one, either you can do it yourself, DIY, or otherwise we will give the axial load spectrum, we will consider the axial load spectrum for the design of short panel concrete pavement, right? So one can utilize the stress charts or one can utilize our design procedure. And the comparison of stresses between different panel sizes is in the range of 1.685 to 2.341 for a specific load condition. Anyhow, these stress values would change from load position to position. Right? When it comes to the construction of short panel concrete pavement, this is a very crucial practice that needs to be adopted. Right? Preparation of subgrade is important, and construction of subbase of 100 mm GSB for low volume roads. For construction of base, we can adopt either CTB or WBM or WMM depending upon the traffic level. We can choose the thickness of those layers. And when it comes to the PQC can have different thicknesses. It all has to come from the load magnitudes, right? And the depth of groove is important. Depth of groove cut that we make for every contraction joint is important. It has to be 1/3 depth of the slab thickness. And the right time of joint cutting is also important, where we have also adopted 2 levels of cutting. We will see in the subsequent slides, right? And the thickness has to come from the design. Well, we see some of the pictures from the test sites. The very first test section in India was constructed in 2011 in the state of West Bengal. Prior to short slabs, there was a block pavement. And that block pavement was very undulated. The road user was not happy. The villagers was not happy. And as soon as the monsoon comes, and it has become waterlogged area, and it becomes a water pool. So therefore, we have suggested from IIT Kharagpur short slabs on the same block pavement, and this is some of the photographs from the construction of test site. And these joints were made initially with the plyboards of thickness of 3 mm. And thereafter, we have seen that the insertion of these plyboards will not work out, because when we try to remove them, again it is very hard to remove them, right? And then with the advantage of the technology, with the advantage of diamond cutters, in the latest technology, we have been adopting 2 levels of saw cutting. The first level of saw cutting is to introduce saw cut at every 3 meter interval, and then thereby after give 1 day or 2 day time interval, and then you can go for second level of saw cutting, so that the number of transverse contraction joints are going to be formed. And these joints are stress relievers. People think that the joints are the joints that we provide in short panels are the pools for the stress concentrations, but not so. They are the stress relievers. We are intending to provide these joints. And this is another test site from the same West Bengal state. We have adopted a number of PMGSY roads, this short panel concrete pavement. This was constructed in 2016, but beneath that we have self-filled concrete pavement that was badly damaged with local quarries, and then we have suggested this short panel concrete pavement over self-filled concrete pavement. Well, this is another test section on National Highway NH19. This was the first test section on National Highway in India, where we have constructed around 384 meters with 3 interface conditions, but the panel size is same and panel thickness is same, 180 mm. And there is a interface condition as non-woven geotextile, fully bonded, and there will be a spray of rapid setting emulsion, right? And this was another test section that was constructed as a part of my research study. It is about 1.5 kilometer on NH18. It is towards Tatanagar. So the construction process was evolved from the compaction of the subgrade, and then there is a CT GSB, cement treated GSB, and then dry-lean concrete base layer for the short panel concrete pavement, and then we have used full width paver trains for the construction of short slabs. And the finished test section was something like this. Well, when we visit the test site, here we can clearly witness that the multi-axle truck traffic has got scattered wheel sets over different slabs. And the performance evaluation was what we have done is for different seasons. It covers the summer, it covers winter, post-monsoon as well. And then we have tried to evaluate the load transfer efficiency and the same data that we have used for the calibration of multi-slab model. And then we have been suggesting the guidelines for the design of short slabs for the highways. A similar concept can be adopted for the low volume roads. And conclusions from the study is, well, we can save the material, we can reduce the thermal stresses as you reduce the slab length. So there will be a large saving in the cost, construction cost. It may be equivalent to the construction of asphalt pavements, right? Well, when we talk about the critical stresses would change from location to location. At one location they would increase, at one location they would decrease, right? These are all common conclusions from the study, right? Thank you.
Thank you, Sridhar Reddy. I think we have covered 3 presentations, so I can take a couple of questions on these 3 presentations before we move forward. So, a couple of quick questions, if anybody has any question. Yes, please.
Mic, please. Microphone, please.
So, you already given question?
So, my question is that you are talking about spectral analysis, right? We are doing spectral analysis of surface waves, or you are leaving it open?
Please keep your microphone closer to your mouth. Yeah.
Actually, so far the intelligent compaction measurement values are proprietary based. So each roller manufacturer comes up with their own measurement values and the back calculation systems. So some of them use this spectral analysis. Either it is like what they have done is black box. So they may use surface waves, but I am sure that surface wave may not be able to capture this. So what we have done is force displacement using the Fourier transforms.
Okay, thank you so much.
Yeah, any other question?
The second question is for Dr. Reddy.
In that portion, I don't think this panel will serve purpose when the subsurface drainage is poor. In the village portion, there is terrain is like that, we are unable to drain off the water.
Well, sir, I do agree. Well, there is a subsurface drainage problem, but when we have suggested these short slabs on block pavement, we have corrected the profile and we have made sufficient arrangements for the subsurface drainage as well. Yeah.
Yes, please. That one.
Morning, sir. I am Mohit Mahajan from Jammu, Superintending Engineer PMGSY, sir. I have a question for Dr. Reddy. That while laying concrete pavement, what is the solution for treating the side shoulders? Because we construct roads in villages, and how we treat the berms, side berms.
Pardon, sir? Shoulder compaction issue?
No. How we treat the side shoulders while we are laying the concrete pavements? How we treat the side shoulders, side berms? You can say.
Yes, sir. When it comes to
with what material?
When it comes to the short slabs, sir, we have to provide some kind of confinement for the short slabs. With we construct the side drains, so we will project it to the top, and the same side drain production or side wall of the side drain would protect the short slabs on the shoulder side.
So normally, in villages we keep the shoulders kacha. We don't treat them. It is just with good earth we fill the shoulders. So do you suggest that we should also do some treatment of the shoulders after laying the concrete?
Not essentially required, sir. We can go for open gradation kind of thing. A granular subbase can be used for the shoulder material, and then subsequently we can reroute the drain water to the side drains. Yeah.
Thank you.
Any point?
Regarding construction of rigid pavements, the main problem is maintenance of this degree of compaction. That is the optimum compaction we have to maintain. That is OMC compaction. That is main problem is the control, the water cement ratio, the aggregates, the proportionate, the right compaction is not able to doing it. We are getting cracks in many places. And the short panel also, that is 3.52 or 3 meters that we are providing joints, contraction joints. But this type of small panels, it is not possible during execution. Maybe not easy, but the huge workload is there. There is about 2,000 kilometers. Each road consists of 3 kilometers to even some roads are 5 kilometers also there. So this degree of compaction, that intelligent compaction you told now, that we are not able to maintain because of the engineers and the contractors. There is the two parameters not coordinating properly. That also we have to get what the suggestion is. We have updated machinery how to use, compactors, other this machinery how to use, latest machinery is how to use. Okay.
You have any comment?
I hope this compaction problem is for the top layer or underneath layers.
Underneath layers also, top layer also, even for side berms also. Everybody is neglecting, contracting neglecting side berms, engineers also neglecting side berms, that is shoulders, even slopes also we are neglecting. This is the field problem, the execution problem, the coordination between contractors and engineers.
Yes, sir. This is what we have observed in some of the test sections also. Well, when it comes to the top layer, sir, nowadays we have got full width paver trains, but keeping these paver trains aside, but one should one should look at the concrete material as a material. It has to have certain air void content, right? We'll typically maintain the air voids about 3%. So as soon as the air void in concrete increases, the strength of the concrete would also, it will become inferior quality. So the air void in concrete is very important. It all has to come from the compaction and the gradation as well.
Please speak to Mike. What will happen in field now? The workability, the water cement ratio, what you are tested in lab, what cement used in the field is somewhat some difference is there. Otherwise, work will not be go at some normal speed. There are all field problems. That how to tackle these field problems with using the latest machinery and the GPS tackling and how that number of hours this machine, this vibrator is working. So and so we have to take care. All precautions, latest precautions, we have to check that control and checking. Regulation, we have to do regulation also.
Yeah, this is very right that you have to take all the precautions and all whatever is procedures are specified that has to be strictly done, and quality is also very important. So all these issues has to be seen by the field engineers at site. I think one last question I can take, yes, because we are continuing because still there are 4 presentations left.
My question is very simple. So far we are talking FDR, CIPR. This basically we are talking on the top layers. Whereas my flexible payment basically depends on the subgrade strength. So if my subgrade strength is very weak, whether I can know what is the method to improve the subgrade conditions. Any method has been devised by the RRI or CRRI to improve subgrade which is existing, which is poor in the initial stage.
Sir, as I emphasized in my whole presentation that subgrade needs to be at least to the minimum desired CBR on which you are building. So if you typically ask me from FDR point of view, I would again emphasize do not construct anything on top if your subgrade is not sufficient. You need to first improve subgrade, for which there are n number of methods already given in our guidelines. Maybe what you can do is, this was what we did in Andaman in one of these section, that the whole project was where we already was having CBR 8, but there was one section where it was CBR 3. So we excavated, we milled the material, kept it on site, first improved the subgrade and then used it. There is no other method. You need to first treat your subgrade. Otherwise you cannot build on that.
That is a basic question. See, when initially my subgrade cell is weak, it means I have to go up to subgrade level and improve that, then only I should go for the FDR and all.
Yes, yes. Yeah.
Okay, now I move to the next presentation, that is for Dr. Brexco Gomez Mazide from EAPA. That is, he is talking about overview of low volume roads in Europe. So European experience.
Hello everyone, my name is Brexco Gomez. I'm the Technical Director of the European Asphalt Pavement Association, and first of all I would like to thank the organizers for inviting me to participate in this very, very interesting conference. I am really sorry that I couldn't meet you in this occasion, but I hope that we will have more opportunities in the future. So today I would like to give you an overview of how we design low volume roads in Europe. And the first thing I would like to say about this is that, well, there is not one way of designing roads in Europe. Each country has their own national regulations, and although low volume roads are normally included in these national regulations, normally these type of roads are competence of the local or regional authorities, which at the same time are free to set their own design criteria. So it's difficult to show you how we design roads in Europe because it depends on the country, and then even inside the country depends on the local or regional authority. But in any case, what I wanted to show you is 3 cases of national regulations or national specifications that somehow will cover the range of possibilities we have in Europe. One thing is the Spanish, from Spain, the Spanish specification. I chose this because the climate that we have in Spain is probably the most similar to the hot weather that you have in the warm regions of India. Also because the specification in Spain is very pragmatic. It's actually like a catalog of sections, so not very flexible. And this is why I also, the second example that I also wanted to show you, the case of UK, because the specification in UK is much more, let's say, analytical, empirical, and even more flexible. So it's different in this regard. And also because the specification is in English, so if you want to consult anything about that, it's easier for especially for the people watching this from India and also around the world. And finally, I will want to give just a couple of details about Norway. Norway is a country with very cold weather, especially sometimes in the year. So I know that in India also some regions can get very cold. So this is why I would like to give a couple of particularities about how they design roads in Norway as well. So starting with the case of Spain, in Spain what we will have is a catalog of sections that are allowed depending on mainly two things. One is the traffic class, which is the amount of heavy vehicles that we have per day. As you can see in the first table, the lowest we have is the class T41 and T42, which is for less than 25 and 50 heavy vehicles per day. And the other input is the subgrade class, which is, we have E1, E2, E3, depending on the bearing capacity of the subgrade. So with this, we come to the catalog. As I explained before, you see in columns the traffic classes and in rows the subgrade classes. So for example, for the minimum traffic intensity that we have is the last column, we will have these options depending on the type of subgrade that we have. As you can see, in general, for this type of, for you to compare how you do things in India, the kind of cross sections you have in India, the kind of solutions that we have here, in general, there are the options are composed by a granular base with an asphalt layer on top, or a granular base stabilized with cement with an asphalt layer on top, or a concrete pavement. In the numbers that you see next to it is the thickness in millimeters. Regarding the type of bitumen that we use, very briefly, I'm going to show you that we use penetrations around 50-70, 70-100, but something that is quite important here is that the Spanish specification allows the use of bitumen modified with cramp rubber, which has certain environmental benefits, especially in terms of circular economy and the use of and recycling. I give you in this slide because I understand that the organizers will share the presentation with the participants. I give you some other design criteria, criteria for design that I won't get into detail. I don't think it's necessary, but it's for your information. Something important is that the Spanish specification allows up to 60% of reclaimed asphalt into the new mixes. So the content is up to 60%. In general, it's going to be only for the binder and base courses, but for low traffic intensities, like low volume roads, it is even possible to use it in the top layers. So this is important. This 60% content, which can even higher if it's, let's say, allowed or authorized by the administration, is actually one of the greatest maximum numbers or maximum limits that we can see compared to other specifications across Europe. So that's why I wanted to highlight this about the Spanish specification. And another thing that is important is the use of cold mix asphalt. Cold mix asphalt, as you know, is instead of aggregate and bitumen, hot bitumen, is a mix of aggregate and a bituminous emulsion, so with water. So these kind of mixes are used in Spain very much, also in other countries, for example, France, and they have environmental benefits, of course, because the manufacturer does not need to heat all the components before the manufacturing, so we are going to avoid energy consumption, emission of gases and fumes into the atmosphere, and so they are also very important. They are also storable mixtures which can help to increase the transport distance and reach secondary roads placed far from asphalt manufacturing plants. So especially for these low volume roads that somehow are in rural areas or far from manufacturing plants, this can be a very interesting solution as well. It is true that they present some disadvantages, but especially for high traffic applications. For example, they have higher airboats content, which consequently tend to produce lower stiffness, and so these mixes tend to be more prone to have or to show permanent deformations. And the other thing is that they need a curing time to evaporate the water before we open the road for the traffic. So this normally is quite limiting for high traffic applications, but for low volume roads, actually they might be good, because this greater flexibility that I just mentioned allows these mixes or these layers to adapt without breaking to the permanent deformations of the lower layers, and especially when the subgrades are of poor quality, which is quite common sometimes in rural applications and so on. Also, the traffic disruptions for low volume roads, of course, are not as critical than for motorway or high volume roads. So this is why also low cold mix asphalt can be a good solution for this kind of roads. In Spain, we have different type of mixes. These are probably the most important. An open cold asphalt mixture, which is a mix with discontinuous gradation for the aggregates. We have grave emulsion, which is a continuous gradation. Normally, we are going to use this in base layers. We have slurries, which is fine gradations with of course, as all of them, with emulsion, water, and additives. And also we have microsurfacings that are basically, normally in Spain, we can find like 2 layers of slurry. The first one is finer and the second one is thicker, where the binder used for the second layer is a modified emulsion. So by having combinations of these materials, we have the common cross sections that I show you here. So these are common sections that we have when we use cold mix asphalt in low volume roads in Spain. Also grouped into, depending on the subgrade class E1 or E2 or E3. For the case of the UK, the specification, as I said before, is more empirical, more analytical, and what it's giving us, first of all, is a range of materials that we can use, but for 2 options. One is that if we make the pavement only with asphalt materials, and the other option is that we make the pavement as a combination of a base layer made of hydraulically bound granular material, and on top we put an asphalt layer. So again, for both the asphalt mixes and for the hydraulically bound granular material, we have different options. You can see in these tables. And with this, we will come to this chart, which is the traditional way of designing roads in the UK. So the first thing we have to do is to come from the top, depending on the traffic intensity that we have, or the traffic that the million of standard axle loads that we expect to happen in the 40 years of service life that this specification is giving us. So depending on that, we come down to the type of foundation that we will have, and then if we go right, we will have the option of whole pavement made of asphalt. In this case, if, for example, if we want to design it with an asphalt concrete, the chart will give us that we need a thickness of around 250 millimeters. If we go on the other side, we will have the other option, where the chart is giving us how much is the thickness of the hydraulically bound granular material base and the thickness of the asphalt layer that we will put on top. So by seeing a range of possible traffics, and in this case I put the range like below 3 million standard axle loads, we can see that basically anything around there in asphalt must be at least 200 millimeters thick for flexible pavements with only asphalt. So in the worst case scenario, foundation, which is the foundation class 1, the asphalt thickness will be a minimum of 200 millimeters for high modulus mixes and 240 millimeters for asphalt concrete. If we go for the other option, for pavements with bases of hydraulically bound granular materials, up to 3 million standard axle loads. The asphalt thickness is 100 millimeters, and for the base layer it will depend on the material and the class A, B, C, or D, but it's something between 150 and 180. I give you in this slide and the next one some other parameters or design criteria for the surface courses. For example, here you see the polished stone value, and in the next one you see the aggregate abrasion value. Again, I won't get into a lot of detail, but it's for your information. And as I mentioned before, in the UK, I just presented, let's say, the traditional way of designing roads because it's a good way for you to compare the kind of pavements you have and more or less where the numbers in terms of thickness and so in the UK, according to the specification. But I just wanted to mention that nowadays, actually the specification allows to use alternative pavement designs that normally are based on analytical methods or models where we model the stress and the strain, and we assume some material properties and with this we determine on a computer the thickness that we will need for each layer to extend the service life up to these 40 years. So this is how things are done nowadays. So as I said, it's more flexible. It allows us to optimize more the thickness of each layer. But I wanted to explain the previous case because it gives you more some general figures for comparison with the case of India. And finally, for the case of Norway, I would like to comment that the critical aspect that I want to comment about this is the frost protection. As I said before, I know that some regions of India can be also cold, so I think this is something interesting that I want to just comment. Of course, damage on roads caused by frost action is a critical problem in all the north of Europe, not only Norway, and the damage are caused by frost heave during the winter and reduced bearing capacity in the spring thaw period. So different solutions to prevent the frost from penetrating down into the frost-susceptible soil or subsoil have been used during the last decades. The easiest and most common solution may be to replace the in-situ soil with sufficient amount of non-frost susceptible soil, but however this solution, it is true that sometimes might not be, let's say, technically or economically optimal. So different products that have thermal insulating effects have been also used with varying degree of success. The Norwegian Public Road Administration have long experience with different solutions, with different products. For example, in the 70s, bark was used because it was a material basically very available and almost for free, so that's why it was used. Another material that got very popular from the 60s, 70s was the XPS, the extruded polystyrene boards. And however, nowadays I would say that probably it's more common to find lightweight clay or foam glass aggregates among other these kind of solutions, as you can see in these pictures. If you are curious about this and you need more information, all the requirements are in this publication and this specification that I show that I give the link on top. And there you have more other specifications about low volume roads. I won't get into details because I already mentioned Spain and the UK. I think for the case of Norway, what I want to comment is the frost protection. But just to give you a big number, normally this kind of low volume roads in Norway have a service life of between 13-20 years and are paved with 100 kilos of per square meter of soft asphalt or asphalt concrete. And I would like to mention that in Norway we use soft asphalt, which is an asphalt mix with a very low viscosity binder, which allow us to resist cracking even at low or at very low temperatures. So it's very common in the north of Europe. I would like also to mention about Norway that they are leading the way in Europe in terms of the use of warm mix asphalt technologies. So the same mixes, but manufactured at lower temperature compared to hot mix asphalt. As you can see, they increase a lot the percentage of total production that is done with warm mix asphalt technologies, as I mentioned before, leading the way in Europe. And this has a lot of different benefits. For example, from the point of view of environmental impact, these technologies reduce energy consumption and emissions. They also allow us to improve health and safety for asphalt workers. So we're going to reduce exposure to fumes, odors, and provide a cooler working environment. For pavement operations, we also have benefits. For example, we will have better workability for the mix. We can extend the construction season. We can extend the delivery distance, which is also interesting for these low volume roads. We can open the road earlier, and we can also reduce the aging of the binder during the construction. Also in Europe is becoming very common across Europe, the green public procurement system. So these kind of solutions also allow companies to offer more competitive proposals. With this, I reach the end of my presentation. I would like to invite you all to keep discussing about these topics and many other in the E&E event that we are organizing together with Eurobitume. It will happen in Vienna, in Austria, on 14-15 November this year, as I said. I would like to see you all there, face-to-face, but if it's not possible, maybe you can also join online, because that will be an option that will be available for everybody. And with this, I reach the end of my presentation. I would like to thank you all for your attention. Again, thank the organizers for inviting me. And here I give you my contact details in case you need more updates or in case you just have any question. Please don't hesitate to contact me. Thank you very much.
Thank you, Dr. Brexo Gomez, for your experience of European roads, some of the countries, France and Spain, UK and Norway's rural roads. I think we can ask question by mail, because he has given his mail ID, and that we can circulate also. So the next presentation is Dr. Nikhil Sabu on waste plastic in bituminous mixes for low volume roads, Indian experience.
Good afternoon to all of you. At the outset, I would like first thank NRIDA for giving me this opportunity to speak on this topic today. So this will be a short presentation. I will try to wind up everything in 10 to 15 minutes. I'm going to talk about waste plastic in bituminous mixes in low volume roads, Indian experience, and in this presentation, I'll be first covering a little about the review on waste plastics, what we have understood from literature review around the globe. Then I will talk about the present Indian specifications, some of the challenges in this area, the one which we are using today, that is the dry process of modification. Then I'll talk about a recent study which was undertaken by NRIDA, and there were various institutes involved in evaluating various test sections of waste plastics roads constructed in PMGSY roads. I'll briefly tell you about the key findings, and these key findings have been taken from the draft report which have already been submitted to NRIDA. And then finally I will conclude by a few of the key points related to the modification of bituminous mixtures or modification of asphalt binders or bitumen using waste plastics. So if we see, the first part is a little more on the review, but I think this is very critical, because from the presentation yesterday, it was told that almost 70% of the roads which will be constructed in future will comprise of waste plastic, and I personally find this statement to be very strong because there is a lot to understand, there is a lot to learn in the area of waste plastics before we can actually go for an engineered use of waste plastic in roads. So if we look at the literature, more than 200 million tons of plastic is consumed globally, and the annual increase is approximately 5%. A report from Central Pollution Control Board, it states that in India approximately 40 to 115 kg of plastic is generated per metric ton of solid waste, which accounts for almost 10% of the total municipal solid waste which is generated in the country. Of course, it depends on the city we are talking about. So different cities have different levels of waste plastic generation. For example, if you talk about a city like Lucknow, it produces almost 1200 metric tons per day of municipal solid waste, while Delhi produces 6,800 metric tons per day, and almost 10% of this amount comprises of plastics of different forms. So overall, almost 5 million tons per annum of plastic waste is generated in our country, which accounts to almost more than 15,000 tons per day. Now, if you talk about the different types of plastic, because here we are talking a generic word as plastic, but plastic can be of different forms, and usually it is mostly used for packaging material, and all of us must have experienced it in different forms. So this is just a basic definition that there are almost 5-7 categories, and I hope we all understand about these categories. For example, we have polyethylene terephthalate, the one we use for drinking bottles. We have high density polyethylene, we have low density polyethylene, we have polyvinyl chloride, PVC, we have polypropylene, we have polystyrene, and there are also other forms, for example, thermosetting plastics like we have melamine, or we have bakelite. Now, if you talk about the generation of these plastics in India, so if we see the statistics, it says that almost 65% of the total plastics which are generated, it comprises of HDPE or LDPE. And I think this is one of the reasons why even our specification tells that we have to strictly use HDPE and LDPE in the construction of, in the dry process of using waste plastic in bituminous mixtures. Though the waste plastic has revolutionized the entire world with its use, daily use, but of course the problem related to its degradability has also caused a menace to the society, and this is where the society and the engineers and different fields have been looking for dimensions where they can utilize waste plastic and they can recycle waste plastic. Now, these are two different statistics. One is from the report by National Asphalt Pavement Association, and the other one is from the report by Central Pollution Control Board. Now, very interesting to note here that depending on the type of country, also the percentage of waste plastic in different categories which are generated can actually change. So if you are reading a report from US, if you are reading a report from Europe, we cannot generalize the same for our country because the numbers can actually change drastically. So if you can see the production of LDP or the production of LDP and HDP, it accounts for less than 30% in case of in US. But in India, it accounts for more than 60%. So these numbers are of course location specific, and we have to be very careful when we are actually presenting the statistics about the use of or the generation of waste plastics. Now coming to bituminous mixtures, this is again very simple things which I have presented here, but very important according to me. So we have to first understand the behavior of the bituminous mixture. We have to first understand how bituminous mixture responds when it is subjected to any kind of loading. So here a general understanding is that the bituminous mixture behave as a viscoelastic material, but we have to also understand that this property of viscoelasticity is due to the presence of asphalt binder, which acts as a cohesive material keeping our graded mineral aggregates together, and this asphalt binder it induces this viscoelastic response, which means the response of the mix to any given loading condition is time dependent as well as temperature dependent. Now there is a reason why I am presenting these theories in front of you, because we are going to talk about waste plastic modification. And here it becomes important to understand that once we incorporate waste plastic in the bituminous mixture, either in the binder or in the aggregates, what type of response do we expect? and the amount of plastic which we are incorporating in the bituminous mixture, is it really going to give us an optimized performance the way we are talking today? The literature review which I have done, we have reviewed almost more than 150 literatures here from around the globe. It says a very different story than what we actually have a general thinking about. So I'm going to talk in brief about that. So most of the literatures, if you see, they have said that there are various ways in which we can improve the performance of the bituminous mixtures, and of course also for the entire pavement. Now, one of the process of increasing the rheological response or increasing the mechanistic response or improving the mechanistic response, I would say, of bituminous mixture is by modifying the asphalt binder. For example, polymer modification is very common. We are also using it in various national highway in India, and it's not a new thing that polymer modification really gives us enhanced properties. So one of the way of improving the performance of the bituminous mixture is to modify the asphalt binder and not specifically the aggregates. Modification can be done in various ways. We have virgin polymers, we have reclaimed polymers, and because recycling is one of the targets, so using waste polymers has been widely researched because it also reduces the environmental footprint. Among various processes of doing the waste modification, use of waste plastics for modifying either the asphalt binders or the asphalt mixture, has been long considered, and it is of course not a new technology, let me tell you. So has been long considered as a suitable candidate in the direction of recycling. So our ultimate goal is that we have to first collect the plastic, we have to process the plastic, we have to segregate the plastic, we have to dry the plastic. People have very commonly, very popularly used pellets in different forms for wet modification rather than dry modification. If you look at the literature review, so you see the percent of publications have increased drastically over the years. And this is not surprising because recycling is one of the major areas of research presently, and I think agencies around the world have understood, in fact the academicians, researchers and also the practitioners, they really understand the importance of recycling and reusing the materials for sustainability. Now if we try to see the category of waste plastic which have been used in various publications around the globe, the highest percentage of publications comes from the modification using either low density polyethylene or high density polyethylene, and very few number of publication comprises of modification using other forms of plastics like polyethylene terephthalate and polypropylene, for example. Now there is a reason behind this. The reason being these waste plastic, that is LDPE and HDPE, they have relatively lower melting point in comparison to other forms of plastic, and there is the range of melting point can depend on the type of plastic, can depend on the manufacturing process. So if you see the range for LDPE and HDPE, LDPE range is around 110 to 120 degrees Celsius, whereas the range of melting point for HDPE is around 130 to 170 degrees Celsius. But of course we cannot also rule out the use of other forms of plastic, and I will tell you how researchers and practitioners have used them in different countries. Now this is an interesting fact in front of you, that if you see that how people have been trying to use waste plastic in bituminous mixtures, almost I would say more than 50% or 55% of the researchers are on the side of wet process of modification and not on the dry process of modification, which we are typically using, especially in case of PMGSY road, and we already have a specification out for this. In the wet process, and there is a reason why we use wet process, as I said, because it enhances the rheological performance. And once you enhance the rheological performance of the bitumen, it ultimately enhances the performance of the mixture as well. But in case of dry process, it's still unknown that how the mechanical performance get improved by using the dry process. And I will tell you some of the facts related to this aspect. So if you talk about modification in wet process, typically 2 to 8% of waste plastic is used in the binder. Now here is a very important thing again, that it's not very simple to decide what percentage of waste plastic are you going to use. If you say use 4%, I have so many different questions for you. I will ask you what type of plastic it is. I will ask you what is the type of base binder. Depending on the property of the base binder also, the optimum dosage of plastic which you are going to use, depending on the type of plastic, it can be an HDPE or LDPE, the amount will change. So we have to be very critical here. We have to do appropriate laboratory investigation first to find out that the base binder which you are going to use, how much plastic actually it can take without segregation. Because in wet modification, this is the major challenge, that we do not have appropriate storage stability. We do not have appropriate dispersion characteristics. But there are techniques available, there are stabilizers available which can improve the dispersion of the polymers within the base binder. And I personally feel that this is the area where we have to focus more in comparison to using some empirical process of dumping the plastic within the bituminous mixtures. Typically in the dry process, the literature says the amount of plastic which we use is 0.2 to 1% by weight of the aggregates, but in India we use it by weight of the binder. Almost the percentage is same. We use typically 6 to 8%, but if you do the calculations, it amounts to the same weight of the waste plastics. The other forms of plastics, for example, PET, polystyrene and polycarbonate, they have also been used by various researchers, but because of their high melting point, they get semi-melted in the bituminous mixture. They do not get completely melted. And because of that, they are mostly used as replacement of aggregates, probably in pellet forms. Another problem with dry process is the unhomogeneous mixture. It has been observed that during the dry process, many of the plastic particles which we add, it does not get completely melted or coated with the aggregate particles which we are targeting for. It can remain in semi-solid state, and then finally the performance which we are desiring from the bituminous mixture, we won't be able to get it, and ultimately we will be not able to optimize the cost which we are spending for the modification. In contrast, though wet process has some challenges, but it can be easily applied in the batch mix plant because you have more control over the performance. But the only problem, as I said, is dispersion, and there are techniques. For example, you can use a malic anhydride, which is an acid anhydride form of malic acid. It has been, in the literature, various researchers and in fact industries have used this as a stabilizer for waste plastic modification. So the same can be used. So we cannot run out of it, that we have to use a simple process rather than understanding the complicated process and understanding the mechanics which is involved in this modification process. So as I mentioned, steric stabilizers and compatibilizers have been used to improve the storage stability. The same we can do very easily. And I tell you, this can be done using simple laboratory characterization techniques, and it's very much possible that we can build a very strong modified binder using waste plastics, either LDPE or HDPE. Of course, PVC we cannot use, and we all understand the reason, that the heating of PVC can lead to emission of chlorine-based dioxin gases, which are very harmful to people who will be working with it. But today, in fact, Professor UC Sahu, we are discussing, he asked me that do we have sufficient data on the gas emissions? But it's very surprising, even after a literature review of more than 150 papers, that the data on health and environmental hazard is not yet, very conclusive in nature. So again, this is one area, and again, you can use a gas analyzer in the laboratory to understand what form of emissions comes by, heating the waste plastic and using the waste plastic in bituminous mixtures. Talking about the Indian specification, I think most of the engineers here knows about this specification, that we use IRC SP98, and this specification talks about the dry process of modification. And there are various questions which I have when we talk about the dry process. Let me not talk about those questions. First, I will just tell about the basic outline of the specification, that it tells us that we can use LDPE or HDPE for modification of the bituminous mixtures. The specification recommends using 8% waste plastic in shredded form by weight of the bitumen, And then finally, the code says that you have to achieve some properties of Marshall in the Marshall mix design. Now here is again a big question mark. How do you ensure that a Marshall stability of 12 kilonewton tells that the mixture is of waste plastic? If I give you a sample of bituminous mixture, even with VG30 you can easily achieve around 15 kilonewton. It's not surprising. With VG40 you can achieve around 20-22 kilonewtons. It is not very surprising. So Marshall stability becomes a very empirical parameter to really understand whether your mixes are actually modified with waste plastic. And once I give you a mixture, in no way you can understand through some process that it's actually modified with waste plastic. So that is again a difficult characterization in the lab. So here is again something which is really questionable, and I think we need better specification or performance related specification so that the money we are investing for modification actually gives us some benefit, maybe in terms of reduction in maintenance cost, maybe in terms of reduction in thickness of bituminous layer. The code says that we have to use shredded plastic. The range of size is 2.36 mm to 600 microns with a maximum width of 2 mm to be used. So this is a standard process we use. And the code specifically also mentions that no reduction in OBC, and I agree to it. How do we actually find that there will be reduction in optimum binder content using waste plastic when we are not sure about the homogeneity, when we are not sure whether the waste plastic is actually coating the aggregate and it is a form of extended for the binder. So this is again a big question, that do the use of waste plastic in diaphragm will actually reduce the optimum binder content? And my personal answer to this is it's really doubtful, and I don't think that it will lead to reduction in optimum binder content. However, a good news is, yes, I'm just concluding one slide. So good news is that under the umbrella of PMGSY, we have constructed more than 13,000 kilometer road using waste plastic, and recently a field study was undertaken by NRIDA. It was a 2-year project, and IIT Madras was the monitoring institute here, and there were various other institutes which were involved, and our main aim was here to carry out performance assessment of rural roads and compare its performance with the conventional hot mix asphalt. So these were the institutes that were involved in the project, with IIT Madras being the monitoring institute, and all the institutes took almost 50 kilometers of the road. 40 kilometers were sections constructed using the technology, and almost 10% were sections to compare with the conventional technology. I will quickly go through some of the key findings from different institutes. That it was finally concluded that use of waste plastic can be favorable for rural road construction. The value of International Roughness Index was found to be lower in case of most of the waste plastic road. I will not say all the waste plastic road, because we also have variation in the results, but most of the waste plastic road in comparison to the conventional road, which also gives us an indication that waste plastic roads are you can say durable in comparison to the conventional road. So these were the values of IRI obtained by one of the institute at different span of time, and this is a comparison between the waste plastic and the conventional technology. Some of the calculations were done by IIT Patna regarding the emissions of CO2, and it was found that the total embodied energy and embodied carbon was lower for waste plastic roads in comparison to the conventional technology. Few of the institutes carried out Benkelman beam. All the institutes were not able to carry out because of various reasons, which I am not going to highlight now. But it was found that sections with waste plastic road had lower deflection in comparison to sections with conventional technology. Now, this data has been taken, as I said, from one of the report, and this graph which you see were from studies done by Rasta, and they found that in few of the roads, the remaining life, which was calculated using a terminal PCI of 55, was higher in comparison to the conventional road. However, in few of these sections, it was also seen that conventional road performed better in comparison to the waste plastic roads. So finally, I come to the conclusions that based on the literature review, present status of incorporating waste plastics in the road construction, following conclusions are drawn: that literature indicates that wet modification technique is successful for if we talk about the use of waste plastics. In India, we have though done laboratory investigations, but we do not have presently any specifications which talks about wet plastic modification, and recently IIT Roorkee has submitted a project to NRIDA in this direction. So I also feel that research is required to understand the wet process and then come. And it says that there is no silver bullet when we talk about use of waste plastic. So we have to be patient, we have to do a research, and then we have to come out with appropriate guidelines so that use of waste plastic can be a success story for the next generation. Thank you.
Dr. Nikhil, for bringing out clarity in the existing specifications and the need for further investigation and preparation of new codes on this area. The next presentation is New Technology and Innovation in Rural Roads by Sri Gordon Keller, Forest Services USA through VC. And I think we can, Dr. Sunita, you have a flight, so maybe we can take first your presentation, that is experience on use of coir in rural roads, Dr. Sunita. So after that we will take on VC from Gordon.
Yeah, good afternoon to all. And thank you, sir, for giving me this opportunity, and thank you to NRIDA also. So here I am going to talk on experience on use of coir in rural roads. Actually, this is a part of the coir board, that is projects what we have done. As 3 projects we have, 2 we have completed. So this is the result of that. And some of the officials from coir board is also there. So India contributes like 70% of the world production of coir, and overall production in southern region is more. So we thought it's a right act for NIT Tiruchirappalli also to take the coir board at his project. And the properties of coirs and all, I am not going in detail. So what we have done the experiment on coir at is geotextile. We have considered grade 1 and grade 2. Grade 1 means it's of 400 GSM, grade 2 700 GSM. We have done some little bit experiment on 900 GSM also. So the functions of coir geotextile, so generally you can tell this may be the function of the synthetics or geotextile. So first of all, what the functions like separation, filtration, drainage, sealing function, that will be there. So what I want to highlight here is the reinforcement function. So what we have used is to apply in that is reinforcement function. The application, many applications are there. The highlight what we are using is on this reinforcement. Other like separation, we can use this layer as a separation material, as for this filtration, then as a sealing function. So suppose you have any the cement treated base, you can just use this layer above this. This is a typical coir geotextile reinforced road. So what we have used is above the subgrade, between the subgrade and subbase. This is part of our first project. See, earlier as subbase course we were using the sand gravel mix. So we have tried using this geotextile above the subgrade and at various positions like 1/4 of the thickness of the subbase, then at 1/2, then 3/4 of the thickness. So in our experiment what we have done, we have tried with 3 geotextiles, H2M5, H2M6 and H2M8, where H2M5 and M6 comparatively it's cheaper if you are coming to H2M8. So we have done the experiment for each section at different height, like at just above the subgrade, then at 1/4, 1/2, and 3/4 of the thickness of the subbase have been done. And I do repeat, this was done carried where the subbase course it was sand gravel mix. But now we have the granular subbase, just we have tried only just above the subgrade. For sand gravel mix we have tried this. And another, as we mentioned now, we are using the sand gravel mix only for the subbase course. So a test track was constructed considering all the rest of the experiments we have conducted, considering or it is laying this coir geotextile above the subgrade course. And some some typical section, one section I'll tell you. So this is with T for traffic where the CBR value is poor. Okay, the section, if it is for the normal cross section, we have 100, 125, 75, 75, but it is different sections. We have tried in the test track reducing the sections also. If you are using coir geotextile, how much we can reduce it. So in the field itself we have tried it. Say example, as a typical example I am telling you, in the first one, in like normal section we have to use sand soiling. You know that is availability and the cost also for sand is questionable now. So the first section we have used at a square this sand soiling, and we have reduced the granular subbase. In the second section, the coir section 2, we have eliminated this sand itself and then use GSB layer. So above the subgrade, you can directly lay the coir geotextile and then the rest of the layers. And there are quite some of the artist tests also where we have tried reducing the base layers also and about the various thicknesses in granular subbase layer without compromising the stress or strain or the load carrying capacity. In the plan view, we can see different sections like S1, S2, S3. So those S1, everything we have to do or check with the control section, how it is performing better. So that is tried, and we have tried with 6 meter and 8 meter coir. It is coir, it will be available in 2 meter, 2 meter. So we have tried with extending it to it is beyond, even in the shoulder this also. So 6 meter and it is 8 meters we have tried, and with H2, M5 and M6, that's with 400 and 700 GSM. And before doing this also, it is along with this field study, we have conducted some laboratory studies also. Main thing, as these are, it's not a fiber, no, we are using this as a coir mat. So we thought like plate load test, the laboratory plate load test have been conducted. Along with that, many field tests also have been conducted. This is one of the typical it is a graph where the laboratory plate load test result is shown, and you can see we have tried with various type of soil with varied geotextiles and also varying the thickness of the granular subbase. I am not going in detail into detail, so some experiments have been conducted. So along with this, field test is very important. How it is this performing in the field is important. So these are some of the tests what we have done, like GeoGate, static plate load test, CBR test, DCP, dynamic cone penetration test. And while doing the experiment, so these tests were conducted after construction. So first the test was conducted in the different layers also. It is not only on the subgrade or where you have the coir geotextile above the layers, how it is different from the control section, whether its effect is there in other layers also, that also have been studied. So the experiments have been conducted in various stages, like first in W BM grade 3, then 2, then granular subbase, if sand soiling is there, geotextile. So this is the sequence we have done. From the elastic modulus value can be obtained from min-met. So what elastic modulus we have tried with varied CBR value and the various determination. The key point here is how to find the E value. Okay. But there are many inputs to be given in that. So we have consider here the modified or the this elastic modulus which have been incorporated in this. So as per GeoGauge plate load test and this that is DCP, the improvement at values is 1.41 to 1.48 if you are using GeoGauge. For CG T1 that's 400. So depending on that it varies. So what we have assumed is adopting the least modification. So we, with varied alignment we got different. So for the least modified one for 700 GSM what we is 1.41 and for this 400 GSM it's 1.22. So this has been incorporated in the design. And IIT PAVE, so what we tried is, this is the typical section. So for each section we have tried by reducing 25 mm whether the strain value is in par with the control section. Again it is this reducing by 50 mm. Like that the trials have done, and whichever is feasible or safe, that section has been adopted. So based on this, two templates have been developed for 700 GSM, and this has been developed for 400. So those are using, you need not do the IIT PAVE analysis and all again. So if you know what is the traffic and which type of geotextile to be used, what is the CBR value of the soil, the sections can be adopted from this template, okay, depending on if the section. So this has been tried for CBR with 5 to 6. And this is a pavement thickness reduction for square geotextile section. So if you are using this square, definitely we can reduce the thickness of the pavement, thereby cost also. So I haven't incorporated the cost, the percentage, the percentage reduction in square artist thickness or the sub-base course thickness. And there are like experiments or field experiments can be conducted even by reducing the base course and other layers, but we have restricted to by checking the reduction in sub-base only. And like percentage reduction, if the traffic is like T1 to T9, and if the CBR value is 2, if the for low traffic and all, we can see the thickness reduction is more. Okay, if the traffic is more, still the reduction is there, but comparatively it is lesser. And that is, these are some of the steps or the construction procedures for the preparation of the subgrade. Some field tests have been done. This is the laying of coir artist geotextile.
Okay, let me know when I'm audible and you can hear me. Okay.
Now we can hear you.
Okay, let me go back to sharing my screen now, okay? Okay, can you see my screen now?
Yeah, we can see.
Okay, let me put it into presentation mode.
Yeah.
Okay, there we are. Now, can you both hear me and see my presentation now?
Yes, please.
Okay, thank you. Well, good afternoon. Yeah, my name is Gordon Keller. I'm a retired geotechnical engineer from the U.S. Forest Service in the United States, in the western United States. Still working as a consultant, and thank you for the invitation and the opportunity to be in. I've had a chance to work with the PMGSY program a certain amount in past years, reviewing some of the roads, rural roads and hills programs here in Uttarakhand and Meghalaya in Himachal Pradesh. And so that's what I want to talk about briefly here. Some of the interesting challenges that I saw particularly looking at the hill roads, it's steep, unstable terrain. It's tough working conditions. You've got short construction season, just difficult construction, relatively high construction costs, and you're sometimes with contractors and engineers that have limited experience. And then if you go to some place like Bihar, you've got the kind of the other side of the program, or a problem where very flat problems, and you get into drainage problems. So some of the innovative technologies I wanted to talk about briefly are like MSC walls, mechanically stabilized earth walls, GRS bridge abutments, use of the dynamic cone penetrometer, bioengineering, which is not new, but I think is underutilized in many parts of the world. And, just a few photos of some of the hill road construction or hill road country. Like I say, it's very steep, very unstable, high rainfall in the monsoon season, so clearly some interesting challenges.
Dr. Sunita, on Coir technology, Indian Road
the PMGSY program. But they've done some amazing work given the difficult circumstances that you're working with. Then you do go to some place like Bihar or West Bengal, where really drainage is the key issue that are the main problems in these regions.
Coir technology very soon. Yeah.
Sir, I understand that
It's just very flat, hard to achieve good drainage, especially if one village is building up an embankment for a roadway, which can tend to flood the next village. And there's a lot of agriculture in the region, so the roads are heavily used not only for traffic, but seems like for a lot of agricultural purposes, which adds an interesting dynamic to the use of the roads.
effect over the performance of the payments.
And some other applications, and these are the plastic geosynthetics as opposed to Coir, what we just looked at as a geomaterial. Faster ways to build bridges that are available, mainly because bridges they're high cost items and pretty critical in a lot of construction. So just
It's even
for confining loose soils if you have gravel but not coarser rock. Also, they're used as for they can be infilled with concrete to make kind of a flexible concrete pavement for a low volume road. Another use of these geosynthetics is turf reinforcing mats, or TRMs. And when the two of them are combined with a turf reinforcing mat over these geocells, and like for ditch linings and some drainages.
and there are some experiments where you are doing the treated
Last, probably one of the areas that's growing the fastest these days in use of these plastic geosynthetics. Sometimes erosion control product. Now, this is not a new technology. I think it's been around for a few thousand years, but it's staked for brush layering. A lot of good publications out there. A lot of including or involving a structure mixed with vegetation. It's both more aesthetic today, information, bridge design, proper vegetation cover for erosion occasions. One agency would come along and do some work, and then finally what it takes to put all this together is people. And so I appreciate the fact that this is a well-attended conference, because it takes good people to be able to implement innovative ideas. They don't stand on their own. Somebody's got to come up with the ideas and implement them. And this was some training or some work I was doing with Aaron Sharma in money. With that, I'll say just thank you for your interest in this whole subject of low-volume roads and innovative techniques to make them better and cheaper and faster today. And there's a ton of references that come along and documentation of each of these areas that I've mentioned here. So I didn't make a specific list of them, but this is my email address, gordonrkeller@gmail.com, and please feel free to write me an email if you're interested in further information or documentation on any one of these areas that I've discussed. So with that, I'll say thank you for your participation and the opportunity to make this presentation. Thank you.
Thank you, Mr. Gordon, for sharing your experience on roads. With this, for last 3 hours, we are non-stop. We are having the presentations, so I think you deserve at least a cup of tea. So we break for the tea before we move to the last part of this pre-lunch session on
to national objectives and is contributing immensely towards the nation's sustainable development goals. The selection of target areas for building and restoring roads has been done using the most scientific method by mapping the strategic points on the Geographic Information System or GIS. This mapping has ensured that the most eligible roads are included in the program to provide a boost to India's rural economy. The routine maintenance of PMGSY roads across the country has become more streamlined since 2020 after the introduction of EMARG. It is a GIS-based enterprise and an e-governance solution to aid and assist the officials and contractors in maintaining performance-based maintenance contracts (PBMC) of roads, assessing performances and making automated payments. Earlier, these records were kept manually and were often subjected to errors. EMARG has enabled evidence-based, error-free digital record keeping. The last couple of years have seen a user-friendly app, Meri Sadak, is helping citizens provide their feedback directly to the ministry. So far, about 1.5 lakh complaints have been lodged through the app, almost 99% of which have already been resolved. So far, around 70,000 kilometers of PMGSY roads have been constructed with non-conventional and new materials. Technologies like FDR using cement and commercial chemical stabilizers like Zydex, Terrazyme, ANT, Stabled Road, RoadSem and many others have been used in the process. Other novel technologies like cell-filled concrete, paneled cement concrete, use of waste materials like slag, fly ash, waste plastic and cold mix technology have introduced locally available, low-cost and recycled materials to road construction. FDR, a full-depth reclamation, stands out among all of these as a new-age construction technology. It is primarily a road restoration technique. Full-depth reclamation of an existing pavement is a rehabilitation method that involves recycling of an existing distressed bituminous surface and its underlying layers into a new base layer. Apart from mending a damaged pavement structure, FDR can be adopted for upgradation and widening of existing roads without requiring any structural overlaying of base layers, while designing for the same or higher order of traffic category. The shortened construction schedules add to the cost effectiveness of the technology. Overall, FDR has great advantages in terms of saving time, energy, minimizing material consumption and cost reduction where pavement cost is high, transportation cost of aggregates is high and the quality of aggregate is not good. The cell-filled concrete technology developed by IIT Kharagpur in India itself has enabled PMGSY to build and restore roads at a minimum cost and a minimum effect on the environment. The use of cold mix technology has drastically reduced the emission of greenhouse gases, and the chances of workers meeting with accidents during construction too has been significantly minimized. The use of waste plastic results in less bitumen consumption and is beneficial to our environment as it recycles plastic waste. However, the introduction of these new and green technologies under PMGSY has led to a huge drop in carbon footprint and made the whole process of road construction faster and a lot more cost effective. With a view towards achieving an environmentally sustainable economy, PMGSY has envisaged a new technology vision. Now, a minimum 50% of the proposed roads will be constructed using these new and eco-friendly methods, and waste plastic will be used in constructing more than 70% of the total proposed road length. As for quality control, PMGSY envisages a 3-tier quality control mechanism in order to ensure the strength and durability of these new lifelines of India, while continuing on a journey of fulfilling everyone's dreams. Dreams that would no longer be deterred by difficult roads even in the remotest corners of the country. India today has also opened her arms towards the world for sharing these new and unique technologies that are being used for building rural roads and the invaluable experience gained in the process. Thanks to the Pradhan Mantri Gram Sadak Yojana. IIT Kharagpur, one of India's premium technology institutes, has come up with a novel technology that has rendered a new edge to the Pradhan Mantri Gram Sadak Yojana. Cell-filled concrete, as the technology is called, involves covering the compacted subgrade or subbase with a formwork of plastic cells made from waste plastic. The formwork ultimately gets filled with concrete or stone to act as the pavement. It is stretched and iron spikes are driven at the corners of the cells so that the frame remains stiff. Nylon ropes through the cell walls prevent the cells from collapsing while they are filled with concrete or stones. The cells are shredded out on the concrete base with the help of the frame. The coarse aggregate mixture obtained from the factory is carefully checked with sieves to confirm the right proportion of small and large stones. Then, with precise measurement of cement, coarse aggregate, fine aggregate, water and chemicals are mixed to make the concrete. Even with precise measurements, the concrete is tested thoroughly before being used for construction. Once the quality of concrete is confirmed by the tests, the cells are filled with the mixture. Each cell gets an equal feed. Further, the concrete is distributed from the bottom to the top of each cell equally with a road vibrator. A final layer of concrete is spread out and then the road is leveled manually, which adds precision and perfection to the construction. Finally comes the curing process. Agricultural waste straw along with water is poured on the road. Cell-filled concrete technology provides with the opportunity to recycle plastic, which is one of the biggest environmental hazards today. It reduces the construction cost to a considerable extent in comparison with cement concrete pavement. The consumption of aggregate is also reduced substantially compared to conventional cement concrete pavement. The high stiffness of the material reduces the overall crust, which makes road construction economical. Maintenance of these roads is easy, as in case individual cells fail, they can be easily replaced or repaired. As per the new Technology Vision 2022, it has been made mandatory to use cell-filled concrete in 100% of proposed road length in cement concrete road construction under PM-GSY. As the Pradhan Mantri Gram Sadak Yojana uses cell-filled concrete in connecting remote habitations with the network of all-weather roads, we salute our institutes and wait for them to come up with more such sustainable technologies that will brighten up the lives and livelihoods of rural India. A major part of the Pradhan Mantri Gram Sadak Yojana is restoring depleted and damaged roads, for which the project has adopted several new and innovative technologies, one of which is FDR, Full Depth Reclamation of Roads. This is a cost-effective and eco-friendly technology that ensures protection and conservation of the environment alongside reducing carbon footprint to a great extent. Full depth reclamation of the existing pavement layer offers a significantly cost-effective and sustainable rehabilitation method. Apart from rehabilitation of distressed pavement structure, FDR can be adopted for upgradation and widening of existing roads without requiring any structural overlaying of base layers while designing for the same or higher order of traffic category. The process starts with mixed design, which is carried out with a scientific and systematic approach through reputed institutes like CRRI or IITs that balances the existing and desired engineering properties, constructability, durability and economics. Once mixed design is finalized, the next step starts with gauging the level of rehabilitation required. The carriageway is marked with lime. Then comes spreading of cement and mixing of commercial chemical stabilizers like Zydex, Terrazyme, ANT, Stable Road, Roadsem and many others, which is followed by the application of the recycler or reclaimer, which is the main FDR machine for pulverization. Cube mold castings are then sampled from the pulverized road and kept aside for testing. The grader is then applied for leveling the surface. Pad foot is run for heavy compaction and the grader is run again for removing the pad foot marks. The pneumatic tire roller or PTR machine is applied for further leveling and corners of India to mainstream life through state-of-the-art roadways. The pages have been evolved. One of them, the whole process can be executed by semi-skilled local workers who have very low chances of meeting with accidents as there is no heating involved. A study has been conducted by IIT Madras along with 5 other institutes. The study shows that the life cycle assessment of cold mix asphalt results in 33% reduction of PM10 emissions
for 17 times. This work has also connected tens of millions of people living in over 160,000 habitations. The program has introduced many innovative approaches, for example, the use of alternative technology and material, sustainable and climate resilient method, asset management, cost effectiveness, community engagement, and it has achieved considerable success in realizing the 15% mandate to encourage the use of new technologies in road construction, including recent effort of full depth recycling of existing pavement. The World Bank has been proud to partner with the government of India in developing and implementing PMGSY. As I mentioned, we have been involved since its inception through a series of lending operations totaling over $2 billion, working in 9 states, and through technical assistance grants of over $7 million working in all states. Working together with MORD, we have incorporated a rural core network approach to prioritize investment needs, standardized procedure for preparing engineering design, procurement, and contract management, an environmental and social management framework, particularly for low-volume roads, and an independent quality monitoring mechanism. These investments and approaches have supported the overall investment of over $38 billion by the government of India. Looking forward, there are many issues on which we can engage together. We commend the effort of MORD in launching the new technology.
I welcome Session Chair, Shri Rajendra Prasad Indoria ji. He is a former Director General Roads, Ministry of Road Transport and Highways. Welcome, sir. And the session report here, Shri Gaurang Joshi, SBNIT Surat, welcome you. And in this session, this session is for the presentation by the technology providers. So I request all the technology providers, representative, those who are there, yes, please kindly come. I'll just recall. Bitcam Asphalt Technologies, Ms. Varsha Mothe and Shri Deepak Singh ji. Okay, please come onto the stage, take your seat. Aman India Private Limited, Shri Peter Maurer, Aman India. Yeah, please welcome. National Jute Board, Kolkata, Dr. Mahadev Datta, welcome. Tikri Tar and Shell India Private Limited, Shri Arun Ranjan. Yeah, you are welcome here, please come. And VV Auto Test Systems Private Limited, Shri Nitin Manawat, kindly come to the stage. So with this, we can start the session. Before this, I take this privilege of introducing you to the session chair, Shri R.P. Indoria ji is a man of humble beginnings, retired from the top position of Director General and the Special Secretary from the Ministry of Road Transport and Highway. While working in the ministry in various positions, he was involved in shaping the policies of the Government of India on public-private participation in the road construction, which we now see is a very common thing now being used with his guidance. And okay, so the sixth one is AVS Inno Infra ANT Technology, Shri Apurva Anand. I think we missed that. So kindly join us. So I was just talking about Mr. Indoria. So he helped the government in drafting the model concession agreements and negotiating road projects with foreign government. He was also one of the architects of the Central Board Fund Act, which ensured a steady flow of funds for the improvement of roads in the country, including rural roads under PMJSY. Thank you so much, sir, and welcome you to this session. And then about the rapporteur, Shri Gorang Joshi, SVNIT. Dr. Joshi is working as Professor of Transportation Engineering and he is the HOD of the Civil Engineering Department. He has more than 28 years of experience in teaching and consultancy and other assignments. He has led research projects in the field of traffic flow analysis for urban and rural areas with Indian Road Congress and CSIR India Road Research Institute. He is coordinator of the STA and PMJSY for the state of Gujarat. Now, without taking much of a time, I'll request session chair to start the session. And my request to the session rapporteur is that kindly prepare a small brief, because before 6 o'clock we need to submit it for the today's press release. So that's the only thing. Thank you so much. I hand over to the session chair, please. Thank you so much.
Thank you. I'm really pleased to be here amongst this august gathering of...
My apologies, sir. Sorry, because of the time constraint, I forgot. We just want to welcome our session chair and the speakers. I'll request NRIDA team to come forward and offer a bouquet. Thank you so much. Sorry for the fault. Thank you. Thank you so much. Yeah. Thank you so much. So with this is okay. So we can start the session, please. Thank you so much.
Thank you. A very good afternoon, ladies and gentlemen. And I'm really pleased to be amongst this august gathering of delegates and participants about road construction per se, but rural roads in specific. Now, I have always believed that while the more glamorous expressways and fast-speed corridors, they do help the industry, reducing the transportation cost, reducing the return time of fleets, passenger facilities and all. Yes, they are very good. They do contribute to enhance GDP, and the roads themselves become a hub of economic activities. But I would like to put on record my personal appreciation for NRIDA for the yeoman service they are doing for the last mile connectivity. Even today, we are an agrarian society. A major contribution to our GDP comes from the agriculture produce. And this last mile connectivity has really done wonders to the agriculture sector. And when we talk of economic development, yes, the industries do benefit by reduced transportation cost. But when you compare, give the weightage, there is a farmer, even a marginal increase in his income brings a lot of improvement, a qualitative improvement in the lifestyle, standards of living of the family in terms of nutrition, health, education. So NRIDA is doing extremely important job by developing the last mile connectivity. And for the construction of roads, yes, we do appreciate that we put scars on Mother Earth while constructing roads. We consume a lot of material. Now this is where the technology providers are required, are kind of expected to come up with new developments so that we can reduce the consumption of material, reduce the carbon footprints, bring down the cost of construction and speed of construction. Without wasting any further time, I will start with this and I will invite Mr. Rajiv Agrawal, CEO Bitcam, to make his presentation. And please be very brief and to the point. Mr. Agrawal.
Good morning, everybody. Thank you, Chair. Thank you, everyone. Everybody is asking me why I am wearing this safety jacket. It is a mark of respect to all the fellow road engineers and contractors who work day and night on the site, on the roads. May we have a round of applause for all the road engineers who are building the nation. So I am from Bitcam. So this video is not working. I'm doing it, sir. It's not happening. It's not happening. Can somebody help with the video? Can somebody help with the video?
Every 1.5 deaths worldwide take place due to fossil fuel pollution. About 2.5 million Indians die every year from air pollution caused by burning fossil fuels. Air pollution causes 18% of criminal.
These are live from the hot mix plants which are running.
3% of Indian roads are rural roads.
कॉन्शियस चॉइस करनी होगी। पूरी दुनिया में करोड़ों अरबों लोगों के हर रोज की ये चॉइसेस क्लाइमेट चेंज के खिलाफ लड़ाई को हर दिन बिलियन स्टेप्स आगे ले जाएगी। भारत अब से लेकर 2030 तक के कुल प्रोजेक्टेड कार्बन एमिशन में 1 बिलियन टन की कमी करेगा।
Green technologies for road construction activities can reduce up to 50% of such pollution. Bitcam coal mix saves up to 5,000 liters of precious fossil fuel for every kilometer paved. A proven patented product used to lay over 8,500 plus kilometers of roads across the nation. Meets and exceeds IRC SP 100 2014 specifications. 50% higher life. Up to 100% pollution free. 200% faster progress per day. Lower NPV than hot mix, over 35% savings on life cycle cost basis according to TERI report. Bitcam coal mix road at Satana, Maharashtra executed in 2016 with proven 6-year surface life. Bitcam coal mix road at Mohania, Bihar executed in 2014 with proven 8-year surface life as of May 2022.
That is a short video.
Everyone in 18%.
कॉन्शियस चॉइस खिलाफ लड़ाई को हर दिन बिलियन स्टेप्स आगे ले जाएगी।
So we are a clean tech venture, very proud to be from Assam. We are India's leading company in cold mix technology, and after a lot of failures, so we just don't want to talk about success stories, but also a lot of failures that we have encountered. We deal in the cold mix binder, all the bitumen products. We are India's first venture to be identified by the Department of Science and Technology, Government of India, and funded by them. We have BIS license on all the plants. All our manufacturing units are from Denmark. We are under the India-Denmark Green Strategic Partnership, and 2 locations currently, one in Durgapur near Calcutta, one in Guwahati to cater to the northeast. And this technology, we have laid more than 8,500 kilometers across India, almost touching every state. What is Bitcam plant cold mix? It's a tried, tested, and proven product used to lay 8,500 kilometers. We are meeting and exceeding the IRC SP 100 2014 specifications. It's 50% higher life, which is also validated in the TERI report. It's 100% pollution free. The faster progress is up to 200% and even up to 300% at times, depending upon the site mobilization. And while the cold mix initial cost is 10 to 15% higher item to item from hot mix, the surface life is increasing by almost 50%. Hence, the NPV of the road is much lower compared to the regular hot mix. These are some milestones. Please visit us in the stall. We can discuss more on this. A small proposal to the NRIDA and the ministry. We have to contribute to the Honorable PM's clarion call of reducing 1 billion ton carbon emission by 2030. This technology is well tested, tried, proven. As per the new technology initiative guideline, the vision document, we are sure it can also be implemented beyond 25%. These are some glimpses. Thankful to Government of Assam to always allow us to do the trials in Assam. 2013, we did the first SDBC there. Karnataka, Telangana, Chamba in Himachal Pradesh, Jammu, Dev Prayag Uttarakhand, Raipur Chhattisgarh, Udupi Karnataka. Sir, with your permission, I would like to invite retired Chief Engineer Sir, Mr. Ingole, who was the man behind this road in Satana, Maharashtra, and Mr. Ramesh Sirsat, so that audience can hear live from them their experience on the cold mix technology. This is the geotagged photograph of the road in May 2022. Sir, please, if you can kindly come and share your experience. We have some time. Ramesh ji, please come.
Good afternoon, everyone. I had the opportunity to meet Mr. Raju Agrawal sometimes in 2013, and I was working as an executive engineer at that time and thought that this is a very good technology and we should try in my jurisdiction. So I invited them, and under the Pradhan Mantri Gram Sadak Yojana, when I was working in that time, we chose a road in Satana in Nasik district. And I am happy to share with you that the performance of the road, even after 8 years of its construction, is superb. And many of you can, if you can visit that road, you can see it for first hand. There was a lot of, the project cost was enhanced only by 2% if you remove the other elements. And Mr. Ramesh Sirsat, he is the contractor who was very instrumental in doing all the necessary things in that particular road. He may share his experience, please. Thank you. Thank you so much.
नमस्कार। मैंने ये जो बिटकेम का प्रोजेक्ट है कोल्ड मिक्स टेक्नोलॉजी का, मेरे ख्याल से महाराष्ट्र में पहला प्रोजेक्ट किया, क्योंकि कॉन्ट्रैक्टर आजकल ऐसा R&D में कोई इंटरेस्ट नहीं लेता, क्योंकि R&D में कुछ बात ऐसी होती है कि ये काम फेल होने के चांसेस ज़्यादा रहते हैं, ऐसा लोगों को लगता है। लेकिन मैं शुरू से जब से बिजनेस चालू किया तब से मुझे क्रिएशन का थोड़ा आदत अच्छा है, इसीलिए कोई भी R&D का प्रोजेक्ट है तो साहब लोग मुझे इंसिस्ट करते हैं कि आपको ही करना पड़ेगा, क्योंकि इंगोले साहब ने जब बोला कि ये कोल्ड मिक्स टेक्नोलॉजी, तभी मैंने बोल दिया था कि ये सक्सेस होगा। सर बोले कि मैं हूँ, आप करो। दूसरा प्रोजेक्ट नितिन मनावत साहब भी है, वहाँ का जो सॉइल स्टेबलाइजेशन है वो भी मैंने ही किया था। आज तो मुझे बहुत खुशी हो रही है कि कितना बड़ा प्लेटफॉर्म पे मुझे सम्मान दिया। थोड़ा बोलने का आदत नहीं है, फिर भी सम्मान दिया तो मैं हैप्पी हूँ। दूसरा एक बिटकेम का एक मुझे जो बात कहने की है, 8 साल होने के बाद भी रोड एज इट इज है, यानी कि 5 साल DLP के बाद डिपार्टमेंट उसके SR या दूसरा पैसा देके काम करते, तो 3 साल जो डिपार्टमेंट ने पैसा नहीं दिया फिर भी रोड अच्छा है, तो कम से कम डिपार्टमेंट का 35 लाख रुपया ये सिस्टम ने बचा लिया, ऐसा मुझे गर्व से कहना पड़ता है। इसलिए मैं इंगोले साहब और राजू साहब का आभारी हूँ कि ऐसे काम अगर महाराष्ट्र इंडिया में करेंगे तो शासन का भी फायदा होगा और आपकी भी सिस्टम का भी डेवलपमेंट होगा, ये मुझे कहना है। थैंक यू।
Mr. Agrawal, we are really running short of time. Kindly close in 30 seconds.
Sure, sir. So this is from Mohania, Bihar. Again, 2014 model road made under the supervision, under the guidance of NRIDA. And so the geotagged photographs are there, latest photographs. So these are the success stories which we are displaying in our exhibition stall. Please visit us. We can discuss there. So we are a fan of the model that was launched by NRIDA, the Technology Management Agreement. We feel the contractors are in a culture of hot mix for last maybe 50 years. We feel that next few years, we still need, even for the mainstream technologies, the TMA model with the empaneled technologies. So these are the few TMAs we had done. We request you to review this. So these are the industry challenges we were facing. We thought to highlight. Very interesting. So failures during implementation, largely, sir, because there is no technology management agreement being done for mainstream technologies, the contractor focuses on procurement of lowest cost material. And so the technical services are generally compromised. So the second is empanelment of credible technology providers. Third is a target setting for 100% mainstream of cold mix technology and easy financial support to convert ongoing hot mix works to cold mix works. Because of the inadequate, the minimum 15% new technology is inadequate at a commercial level. Thank you, sir. Thank you.
Thank you, Mr. Agrawal. I have a few suggestions. You know, this B2B interaction and B2C interactions can be had during lunch time. And the floor intervention, I'll prefer that it is done at the end of the all the presentations. So next would be, I will invite Mr. Peter Maurer from Aman India Private Limited. Is he here, Mr. Maurer?
Hello, everybody. Can you hear me?
Yes, we can, Mr. Maurer. Please proceed.
Thank you very much for the possibility to show our innovation, what we have in terms of plant technology. Let me start with the short agenda. I would like to introduce Aman India to the audience, then to talk about the green technology for rural roads with waste plastic. The next is to use cellulose fiber also for the hot mix plants and the green technology wrap. So, Aman is a global company. We have about 3,000 employees, 7 manufacturing facilities around the globe, and one of them is in India. Here you can see our factory in India, where we are producing hot mix asphalt plants, we are producing rollers, we are producing pavers. We have all our India, we have our sales and service offices so that we can serve the customer perfectly all over India. And here, just a quick overview what we are producing. So we have actually for every field the right plant, the right paver for you, even cold mixing plants we have in our portfolio. For us, very important is that we can use and introduce the green technology, especially that everybody knows in India we have an issue with waste plastic, so we have quite a lot of waste plastic. What we can do, if we are going and see how many million tons of bitumen are used, actually for the asphalt mixing plant, it's about 5 million tons. So the government allows now to add about 8% of waste plastic into the mix, additional to the bitumen. This means in total we can reuse waste plastic up to nearly 500,000 tons. So, and I think this will be a very good step to solve one problem and give also the asphalt mixing a better stabilization even. So, where we can add this waste plastic additional now. So we can go actually to the drum mix plant, to the old conventional drum mix plant who are stationed all over India. We can use it in the modern Konterfrau drum mix plant. We have a backhouse filter in the back. So there we have much less pollution than to the parallel flow drums. And we have, of course, by the asphalt batch plants. How this works now? So if you see here, this is a standard drum mix plant, old-fashioned, with just a simple filter system in the back, as you can see. So, but also here, we can add the system. What is important? That we have a good granulate from shredded plastic. And important is that is the melting point from this shredded plastic is below 180 degrees. Otherwise, we will not get a proper mix. So for this, we need actually single-use plastic. What is not good is multi-layer plastic. So here we are in need to get the correct plastic waste. This needs a separation and a preparation of the right plastic. If we have this, we can introduce the plastic here, as you can see on the, I hope you can see, with the laser pointer here, we are bringing the material in here to the mixing chamber and not from the back where the aggregates come. With this solution, we are sure that we are not burning any waste plastic, because if we would burn the plastic or we have too much heat in this area, so the plastic get burned and give horrible fumes, horrible environmental impact. So it's very important if you are using plastic that you're adding the plastic in the right area. If we go now to a more modern counterflow drum mix plant, where you see here the backhouse filter, that you have not this problematic that you have seen before by the other presentation, a lot of heavy smoke and dust coming out. So here with this system, you have a perfect filtration, and so you have no harm of the environment. And also here, we can add the shredded plastic in the same way. So with this system also we are guaranteeing that if you are adding it into the mixing zone, that you are not have any burning of this material. And in the same way, like we are adding the waste plastic, we can also add fiber granulates and so on, what gives the asphalt additional strength. So you can actually then produce PMB asphalt without any problem. And split mastics and so on. And if we go further, so if we go now to a modern asphalt batch plant, we have a lot of advancements or innovations compared to the drum mix plants. So here also with the complete filter system, where you see here in the back, and here fully controlled material where you are screening again so that you have a perfect mix. So then we are adding as well the same system, and we can add the waste plastic. With our system is always the material, we know exactly how much material it's in which batch is in, so the thing is fully controlled, and you get also a fully documentation how we have worked on this recipe. So you have always the proof what was done. This is not only by the batch plant, this is as well also for the continuous plants, for the normal parallel flow or the counterflow. If you see this now in real life, Here you see the scale up here, and here you see the hopper where you are feeding the material, and then we are bringing the material up to the top and then here into the mixer. And again, I really would like to stress that it's important that the granulate is properly. It makes no sense if you have the melting point from the granulate by 250 or 260 degrees, because then the granulate will not melt and you will have a problem in your final mix. And last but not least, what is also very important, that you are always reusing your wrap material where you have. And this looks then like this here. So here you are feeding your recycling material, and then the material goes up directly in here to the mixer, and then you are adding this 25% of recycling material. So then you have a very big flexibility to reuse your material plus waste plastic, so you can really do something good for the environment. Ladies and gentlemen, I think this was my 8 minutes. I would thank you for the attention. Thank you. Bye-bye.
Thank you, Mr. Mara. Thanks a lot. That was very enlightening. Now, I invite Dr. Mahadev Datta from National Jute Board, Kolkata. Dr. Datta, please.
Thank you, sir. This National Jute Board is a government organization under the administrative control of Ministry of Textiles, and with the support of NRIDA, I think jute and jute board is quite known to you. So I will not speak much about jute board. These are the few slides I have, because my in front of me there is a tick, 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 so it's putting me. So why basically jute? What is the purpose of using jute geotextiles? I'll be talking about this. Then the basic functions. Then we have the standards and guidelines. Then some case studies. We have a stall 41, stall number 41. So any queries or there are other case studies are also displayed at stall number 41. You are most welcome there. And then we have done some performance evaluation. There is a slide. And then we are, as a technology provider, what kind of support services we are providing to the agencies, user agencies, and then list of GHG using organizations. We have the few slides. So let me start with a very good news that we are now, when talking about a reduction of carbon emission, and we are talking about the global warming. We are all affected with the global warming. The good news is that jute, per hectare of jute cultivation, it absorbs nearly 15 tons of carbon dioxide from the atmosphere. It emits nearly 11 tons of oxygen it gives to the atmosphere. And in the process, in the mechanical processing from the raw jute to till the fabric, you can see in the picture, there are of course carbon emission, but finally it is considered a carbon sequestered material. And it is agro-renewable. Year-on-year basis, we are growing jute. Earlier, it was we are cultivating nearly 8 lakh hectares in India. It was reduced to 6 lakh hectares, and now again it is increased to nearly 7 lakh hectares of jute. And we are producing on an average 1.6 million metric ton of raw jute in India, and we are having some 100 jute mills across India who are having a capacity of 100 tons per day. Employing some 3,500 workers in their factories. You can see already this oven JGT, non-oven JGT, and oven JGT, we are having the BIS standards. I'll come in the later side. Now, these are the 4 basic functions we are JGT serves. One is the separation. We have seen the presentation of the coir also. The similar kind of coir is also a natural product. Jute is a natural product. So basically, as a separator, what it happens that it doesn't allow the intermixing of the sub-base soils with the subgrade, and it is acting as initial reinforcement. Basically, it absorbs the stress when it laid on the subgrade. Then, because of the hygroscopic nature of jute, it absorbs moisture of the subgrade soil, and because of its permittivity and transitivity effect, it it disperses the water across the surface of the JGT. And because of the low elongation at break, it is giving a membrane effect while installed on the road. Now, this is a basic schematic diagram of the how we are laying JGT on the road. Other than road, this jute is extensively used for the slope stabilization. Basically, here we use the open weave jute geotextiles, where when it is subjected to rainfall and the moist condition, the threads swell up, and it gives a mini check dam effect basically. So during the in the direction of the runoff, the materials are arrested there at the threads, but at the same time the water falls down. So and over a period of time, with this moist condition of the material as well as the availability of soil, so it expedites the growth of vegetations quickly. So once the vegetation growth is there, so it will have the natural anchoring, and the slope and soil erosion is stabilized. This is the schematic design for the JGT laying on the road construction. So these are the multiple layers are overlapped side by side. These are the standards and guidelines we have already. We have the BIS standards specifications for the road construction. Also, this Railway Design and Standard Organization, they have also published the guidelines, and they have also included in their unified schedule of rates in all the Indian railways. And of course, from the IRC in 2019, this IRC guidelines for the rural road construction SP 126 was published, and it is already included in PWD in the schedule of rates of PWD. West Bengal's SRDA and Irrigation Water Department of Government of West Bengal, PWD Government of Assam, Meghalaya, and we have also done some projects with BRO, so it is included in their SOR also. And all the 17 divisions of Indian Railways, it is included in the USSOR. These are some of the case studies we have given here. So this is from Kangsa to Bati in West Bengal. We can see the pre-work, and then we have installed the 724 GSM JGT on the road. And after the severe value was 2.6%, and after construction of the road, after 2.5 years, when you tested, it is increased to 7.42. Then this is another case study, and few other case studies are displayed in our stall. So this is again another case study in West Bengal, and it was done in September 2021. NIDA team with, I think, Dr. Pradhan was there in the team. They have inspected the road condition. Then this is another use of JGT. This is for arresting crack and potholes of rural road under PMGSY. This is Dr. Pateria, I think he initiated this project under his guidance. We have done it in UP, and you can see after laying of the JGT on the surface, and then after this premix carpeting, we can see the condition of the road after 3 years. These are some of the pictures of the slope protection and soil erosion, controlling soil erosion. We have done in the hill slope also, and we have done in the railway embankment sites also. These are the performance evaluation study we have conducted in 2 countries, India and Bangladesh. And here you can see this was the international project funded by Common Fund of Commodities. And before construction of the road, the severe value was 2.8, and after 47 months, this Indian Institute of Engineering and Science and Technology, IIST, evaluated the condition of the road, and they found the severe value has increased to 11.39. Similarly, there are other also, in everywhere it is increased by 5 times, 4 times after a certain period of time. Now, this is the Bangladesh part. Here we have done this control as well as this with JGT. Now, on the same road, on the same at some portion we have used JGT, where the severe value was 3, and without JGT also the severe value of course was 3. And then after 50 months of this traffic load, the CVR value where the JGT was installed, it was increased to 13.57, whereas it was without JGT, it was around 9.64. So the efficacy of use of JGT has been established in many places. We are from the support service, we are giving from the two more slides, sir. Support service we are giving from NJB National Jute Board. We have a technical team, civil engineer as well as textile and jute technologists. So we are helping the agencies for the customization of JGT. This we are providing technical support guidance in selection of right type of JGT, and also we are conducting several awareness workshops to promote JGT. These are the list of JGT using organizations. So far, nearly 900 projects we have installed successfully across the India. Thank you so much, sir.
Thank you, Dr. Datta. Now, I would invite Shri Arun Rajan and Shri Satish Nadkarni from Tiki Tar and Shell India Private Limited.
Good afternoon to everyone present here, ladies and gentlemen. My name is Arun, and I'll be giving you a brief of new technology that we have developed at TikiDan. Now, TikiDan is actually a shorter version of our company's name. Our company's name is actually Tiki Tar Industries and Danosa. Tiki Tar Industries is an Indian company, and we have a joint venture with Danosa, which is a Spanish giant in waterproofing and construction chemicals. Now, we've joined hands together, and we have a very big network all across the globe. And today, what I'm going to explain to you is our product, which is called Stress Seal. Now, this product is an innovative product that we have introduced into the Indian infrastructure market in lieu of using SAM-SAMI. Now, a stress-absorbing interlayer system, which is the conventional method, has its limitations. The application of SAM-SAMI, for that matter, whenever you have to lay geotextile on top of the roads and then sandwich in between binders and bitumen, it is a very difficult method that is being used. Now, what we have come up with is a prefabricated solution for one of the main issues that we face with roads, which is called reflective cracking. Now, reflective cracking is aggravated by stress, water intrusion, thermally induced expansion, contraction, and over a period of time what happens is these cracks form at the base and then they propagate towards the surface, which is quite visible on roads nowadays. Now, as a solution for that, I will just explain the limitations that we have with the conventional method of using stress-absorbing membrane interlayer. Now, as you can see, it's a very difficult way of laying the geotextile. There are chances of formation of air pockets or the laying practice of paving fabric where it is actually laid side to side and there are no overlaps, or it is not a continuous system as such. So at the edges or at the joints, you can see, it's laid side by side. And it's not a continuous system. And it also does not act as a waterproofing layer. So what we decided, what we did in our research and development team, they came up with a product which is Stress Seal, and it has a selvage at the end. It comes in rolls of 1 meter by 10 meter. When you look at it, it looks like a waterproofing membrane, but it has a geotextile layer on top. Now, coming to the subject of sustainable roads. So we see this as a solution for crack mitigation and base saturation. So Tikiden Stress Seal is the name. And I'll just go through a brief of the composition. It's a 5-layer engineered advanced polymeric composite paving membrane. Now the top side is laminated onto a tough geotextile, and it is sandwiched between select modified bitumen on both sides. And as you can see, there is again a heavy hybrid reinforcement at the core, which also acts as a waterproofing barrier. And this is a prefabricated product. There is no, the only way you need to apply it is to heat it on the top surface and then lay it on top of the roads. And then you can do the BC on top of it. So what I said before, the selvage which we have already in these prefabricated rolls acts as a continuity in the system. So it goes all the way from one end to the other end, and then you have a perfect waterproofing layer as well. Now, since MORTH, we have, since MORTH and IRC have promoted new innovative products, and they've been more than receptive, and they've accepted our technology based on the solution that we have provided. We have been empaneled in MORTH, and we have had the IRC accreditation since June 2014. We are trying to get into more and more projects. There is a bit of challenge that we face because conventional methods which are being used, people, I'm not complaining, but everybody still likes the conventional way of doing things, but change is inevitable. So we need to accept new technologies, and we see this as a new solution that can, ease the time of application, and it is cost effective than the conventional method. So these are the things that we put forward, and it's easier for application or for the contractors in that way to use the product. So some technical parameters, like I said, the top surfacing comes with the polyester geotextile. We have a softening point of greater than 150 degrees, which, when it comes to laying of the BC, acts as a layer which will not get destroyed. And we have a tensile strength. This is of the hybrid core, which is in the center of the membrane. Now, the tensile strength, as you can see, is high, 800 in longitudinal and 600 in transversal. Elongation is 40%, greater than 40%, but we have kept it at that particular range. Water absorption is also less, and one of the main things that we have done with our product is make a polymer modified compound which does not have any deterioration at low temperatures as well. Because in India we've seen temperatures which go to minus as well, but up to 0 degrees this product will perform very well. And it's got excellent dimensional stability. We have done all the tests in our NABL approved lab, which is based out of Halol, Baroda. Now, just to show you a brief of how stress seal application is done. As you know, the surface has to be clean. The prime coat, which is a water-based primer, has to be applied. And then you just need to heat the top surfacing, which is a PE film, and then lay it. And as you can see, the geotextile layer comes on top. And then it is very easy. You just need to lay the bitumen concrete. BC can be done on top of this. No tack coat is required. Again, just a brief to show you how stress seal acts as a retarding layer, or stress seal prevents the reflective cracking that happens, which propagates from the bottom of the system. Now, how stress seal is more advantageous? It's got excellent crack building capacity. It retards reflective cracking. It's user-friendly, no fumes or any hazards in that manner. Easier application at remote sites, stress-absorbing, obviously, and reduce execution time and money saving. These are some of our references we have done in Jammu, Udhampur. We have done NH1A with AFCONS, and the second one is Vivekanand Bridge, Kolkata. We have a few international references as well from our counterpart, Danosa. So finally, as a conclusion, can StressSeal replace conventional SAM-SAMI techniques? So our answer is yes, and we have proven that through one or two projects at the moment, but we are looking to get into more projects day by day. And the second thing is, can StressSeal sustain flow and temperature compactness of the BC? Now that's the most common question that comes up, because the BC temperature goes up to 150 to 170. Now the geotextile layer on top acts as a barrier, and like I said before, the compound that we use, especially polymer modified one, has a restriction or a softening point of more than 150. So this is the system. Thank you very much for your time.
Thank you very much, sir.
Thank you.
Now I invite Shri Nitin Manawat from VV Auto Test Systems Private Limited. Mr. Manawat, please.
Good afternoon, Goel Sahab. Good afternoon to Indoria ji and Joshi ji on the dais, and all the distinguished guests in the hall. I would be presenting the technology providers and implementers' perspective for capacity building. And we have so much of work to do in FDR. I would first present what we have done so far, as to give you a background as to from where I'm coming from. We are displaying our technology in booth number 18 in the exhibition hall, so we can have more discussions there. So the product which we are using in India and demonstrating in India is Base Seal. It comes from US. It has 35 years of history. So we have been doing FDR, soil stabilization, for last 35 years. We have treated soils and sands. Now the picture which you're seeing is of Sahara Desert in Africa. We have done a similar work in Guwahati, in Amingaon, where we used the Brahmaputra sand in 2016. The FDRs using Base Seal has been implemented in almost all the continents. Now we are also getting into rammed earth housing, and it is becoming very popular. Just to give you an idea as to where the stabilization can take its shape. Now we are looking forward to serve PMGSY. I would like to thank PWD in Maharashtra, because they have been throwing challenges at us, and we have always been performing better than the expectation. This first project which I would like to show it to you is that of Ghoti Shirdi Road. If you have been ever to Shirdi from Mumbai and you take a right turn from Ghoti, in 2019, it was a pothole-ridden highway, and we were asked if we can fix it during monsoons. So one thing which I would like to emphasize is that we do stabilization and do FDRs during monsoons as well. And that means that we save almost 3 to 4 months per year of a 5-year working tenure for any government. This has a 70 MSA traffic. We recycled the existing crust, and what you see on the right side is the base which served for the traffic for 3 months. So we did this in August, September, October, November. The PQC started in November, December time frame. So it is 300 mm of stabilization and 30 centimeters of PQC. And there was no DLC in GSB or DLC. Directly PQC was applied on stabilized base. The next I would like to showcase is Ahmednagar bypass. It's a route for Bangalore-Delhi traffic, and it takes around 6,000 trucks per day. With that, the traffic for the design traffic was 250 MSA. This road used to get damaged every single year after relaying. As you can see on the right side, in the first picture, there is black cotton soil fields all on both sides. And we reclaimed this in January 2020, again using the FDR technology, using the recycler machine which you have seen displayed in the exhibition area, using the 20-ton pad foot, similar to what is shown there, it is 15 tons, and the cement spread truck. So I'm not showing those videos here. Over the stabilized base, here the crust thickness was 400 mm. 400 mm of stabilized base in one go. The machine can do 500 mm. And then 50 mm of DBM and 40 of BC. So instead of 90 dBm, you save 40 mm and you reduce the thickness of DBM to 50 mm. This is the third one which we did last year, Mumbai-Agra National Highway. It got damaged during monsoons and heavily damaged, and it was to be attended during the monsoons itself. It's 5 kilometers. Again, we did the stabilization during monsoons, and the DBM BC was applied 3 months down the lane. Having said, when you allow the traffic to pass through, you have to do some special treatments as well on the surface. And the weather is monsoons. We are not talking about summers. In summers, the stabilized base will have rutting. You will have to keep it wet, which is a very difficult task. So in the monsoons, you can leave them. With this background, I would like to give my perspective on the capacity building. I appreciate and thank NIRDA for adoption of FDR on large scale and organizing this event. I also thank IRC to have the standards in place because prior to that, it's a new item. We will have to have a rate analysis, but all that is now sorted. But there are 3 standards to refer to. So I would like to say, soil stabilization, FDR, CTB, CTSB, they're no longer a new technology. The adoption is new. In fact, we had it in IRC 37 2012 as well, and in earlier standards also. Even for the rigid pavement, it is there. So I would request that please don't be apprehensive. I showcased the national highway experience only to let you know that when we can handle 250 MSA traffic or traffic up to 250 MSA, the 2 MSA traffic of PMGSY can very well be handled. So please don't be apprehensive at all of FDR. Adopt it on a larger scale than what it is right now prescribed. The second point is the DPR consultants, the PMUs, the PWDs, REDs, RRDAs. This is all new probably because the adoption is new. So there are as many readers, those many interpretations of the codes. So my request would be to NIRDA to come out with checklist for the 4 stages. I have taken liberty to do it into 4 stages. Probably you, when you decide, can have more or less. First is the DPR. The second is the site preparation for FDR. The third is the FDR process itself. And last but not the least, more importantly, the quality checks. For the DBR and the SBD, for the FDR, I would say, please ask for the water bodies around for the drainage arrangements. They are as important as in the conventional construction. For the equipment, yes, the prescription is there for the recycler and the spreader truck. Whether we need 20 tons vibratory compactor for 250 mm or 15 ton can do is another issue which can be clarified for the ease of implementation. Flexibility in SBD, which I would request for the methodology by the technology provider. Some may need 2 cement spreader trucks, some may need 1. Some may not need PTR, some may need PTR. And a pre-bid alliance so that at the end of the day, it is not that the least cost technology has wider application. A pre-bid alliance will also allow the authorities to know which bid is coming with what technology as well. When you see it in the technical bid, rather than leaving it to the contractor and doing it in the end, you may know, you may not know, because the window of implementation is only 1 year. I will be attending that as well. Now, regarding the crack relief layer, do we need it? Because if I read IRC SP 89 Part 2 2018, it says that crack relief layer for traffic less than or more than or equal to, it is required only for the traffic more than or equal to 2 MSA. So here we are talking about 2 MSA traffic. Now, next is SAMI versus aggregate interlayer versus emulsion stabilized oblique foam bitumen layer. So in the standard checklist, probably a guidance can be published that which particular region, which particular soil types would need what type of crack relief layer if they are there. CTB gradation requirement, it's an in situ. Some people are insisting somewhere in some states that this particular gradation is required, which isn't possible. Coming to UCS, whether we need 3 MPa, because even for the national highway, 4.5 MPa is prescribed. So do we really need 4.5 MPa for rural roads? Wearing course. I would suggest and recommend that in addition to BC, please have few projects with 2-layered surface dressing aggregates. That will reduce the cost further, and probably they will perform with equal excellence. Last but not the least, sir, this is the feedback. It's a 12-month project. It's a policy decision, which may happen, may not happen, but it is very important and crucial for wider participation. Escalation clause for fuel, cement, and bitumen. The prices are skyrocketing, and that deters the participation by the larger companies. Now, for site preparation, whether it should be done in the fashion which is shown in the pictures, or do you need a recycler, is one issue. I think it can be done in drainage arrangement. When there is a 5 years DLP, probably there is, in my opinion, need not to tie the legs of contractor and ask him to run. The department will do the soil sample witnessing, and then the design mix approval, and then the trial sections, core cutting, and then only work has to start. It's only 1 year window with monsoons including. So a decision can be taken on that aspect as well. Curing of stabilized base, very must during summers, otherwise it is going to crack, so a guideline for it. Do we need a crack relief layer? I have already, but when you apply a crack relief layer, then whether it should be SS1 fabric RS1 or prime coat tack coat fabric or prime coat fabric tack coat or sticking of fabric, these are all the issues where NIDA can probably come out with a technical document to clear all the air on all this confusion. And last slide, quality. You need lab versus field mix, daily work cubes and testing by CTM, UCS of daily costed cubes, and last is the density meters versus sand replacement method, and core cutting versus reflector meter. I thank you for your patience, and thank you very much.
Thank you, Mr. Manawat. Can I invite Mr. Apurv Anand from AVS InnoInfra ANT Technology? Mr. Apurv Anand.
Respected former DG Roads, MORTH, Shri R.P. Indoria, respected Director General NRIDA, Dr. Ashish Kumar Goyal, respected Director Projects, NRIDA, Dr. I.K. Pateria, respected speakers on the dais, and respected delegates. On behalf of AVS InnoInfra, I, Apurv Anand, wish you a very good afternoon and extend to you a very warm welcome to this presentation. Very ancient roads have survived since prehistoric times. The Mekhla Ujwa road built by Narkasur leading to Ma Kamakhya temple is still used by thousands of devotees in Ambubashi Mela. Roman roads survived till medieval times. What was the reason for the durability for ancient roads? Stones, ladies and gentlemen. Yes, they were built using stones, but with the considerations for speed of movement, cost of construction, speed of construction, etc., etc., this led to evolution of modern roads. One big compromise in the modern roads was that the loss of strength and durability, there was a lot of loss of strength and durability as compared to the ancient roads. Now, would you believe me when I tell you that now it's possible to achieve the stone-like strength and durability using locally available soil? AVS InnoInfra is proud to say that this is exactly what ANT technology has achieved, and we are using this technology for the rural roads. ANT technology is a Russian technology, and ANT engineering has given full authority to AVS InnoInfra to use, sell, distribute ANT products and do all things necessary in this regard in India. ANT technology works on the principle that Mother Nature knows best. She creates the most durable assets and we learn from her. So unlike the polymer and enzyme-based stabilizers generally available in the market, the ANT stabilizer and ANT modifiers are only organic products that mimic the natural stone producing processes. They enter into oxidation reduction reactions with the molecular oxygen on the aggregate and soil particles to produce crystalline bonds that give stone-like characteristics to the aggregates and soil matrix in the mix. These crystalline bonds are way superior to the addition-based bonds. The ANT technology provides solution to complex technical issues. We, AVS InnoInfra, provide engineering support, technical consultancy, training support to the teams using ANT products. ANT stone roads is a monolithic stone slab created from a wide variety of materials such as various types of soils, stone crushing waste, weak stone materials, mining and metallurgical industry waste. Let's please see a short video which tells about the ANT stone project recently completed in the Wokha Merapani in Arunachal Pradesh. Here's the video.
Wokha Merapani Road leaves the capital of Nagaland, a mountain state in eastern India. Its length is 60 kilometers. Every day, thousands of cars pass along this road. Old and broken asphalt had significantly reduced traffic capacity, damaging cars and slowed down traffic speeds. Economic development of the state required the construction of a new modern road. It was decided to build it using ANT stone roads technology. Construction work was carried out without stopping any traffic, whilst maintaining high quality using our new technology. The first stage is the creation of a sub-base layer of the road. It requires only 4 components: soil, cement, water and ANT soil stabiliser. Waste from a local quarry was used in the construction, including soil from the surface of the mountains containing clay, sand and stones of various sizes up to 40 millimetres. The ready mix is prepared in a mobile soil mixing plant. 4% of cement is added to the soil. After that, the material enters the mixing chamber, where an aqueous solution of ANT stabiliser is doused onto it. At the same time, the stabiliser composition rate is 0.007% by weight of the soil, and the quantity of water is calculated based on the optimum moisture content during the compaction. The preparation of the aqueous solution is carried out in an additional tank, from where it is pumped into a mixing chamber with a metering pump. Note that the ANT stabiliser is environmentally friendly for humans and nature. The finished material is transported onto the road in order to create a new groundwork base. Work is carried out in lanes. First, paving the first lane with a 100-metre overlap. The paver distributes the soil mixture, taking into account required slopes and layer thicknesses required. Then the roller compacts it into the required density. The density is continuously monitored during the process. Immediately after compaction, a new section of the road can be opened to traffic. It does not require any additional care or adjustment. Then the paver moves to another lane and continues to create a sub-base layer of the road.
So the contents of this slide are mostly covered in the video which we have just seen, and so I'll just move to the next video which tells about the strength achieved in ANT stone roads.
Construction process and shortened timescales. Here you can see a stone road built a few months ago. This is a monolithic stone slab without cracks or deformations. Sledgehammer hits can fully demonstrate the strength and elasticity of the stone base. The modulus elasticity of the stone foundation significantly exceeds conventional construction procedures. This formation also allows the road to be used for decades.
एकदम कस के जितना दम है और जितना दम है मारिए अरे भाई और तेज मारिए 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 और तेज मारिए रुक जाइए हो गया बस 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 मारिए रुकिए रुकिए इसका देख लीजिए
So there are numerous advantages of using ANT stabilizer and ANT stone roads. ANT stabilizer is an ecologically safe product. ANT stone roads have high strength. The technology is very versatile. It allows rapid construction because just after compaction of the ANT stone roads, it can carry traffic. Curing is not needed. Even the cement undergoes redox reactions and not the hydration reactions. Hence the elimination for the need of curing. Detail of application and geographical spread can be seen in this slide. The cost of construction gets reduced by almost 30% due to the low cost local material, reduction in thickness, reduction in time of construction, reduction in volume of material to be handled. And so more than 5,000 kilometers of ANT stone roads have already been built. The benefits achieved in the Wokha Merapani project using ANT stone roads can be seen in the next video.
Differences in the technologies. The initial construction of the road was as follows. A sub-base layer made of an optimal sand and gravel mix with a thickness of 25 centimetres, an asphalt base layer of 5 centimetres, an asphalt surface layer of 4 centimetres. A&T Engineering's technology using the new design. A stone slab made according to the A&T Stone Roads technology with a 20 centimetre layer, a 4 centimetre thick asphalt layer. This allows for a saving of more than 25% of the road construction costs by reducing construction time, material costs, fuel and electricity, as well as labour costs. The application of the A&T Stone Road technology made it possible to build a more solid and therefore longer lasting road. The stone base can be used for decades, which means additional savings in the future. In addition, the use of A&T technology has reduced to a minimum the environmental damage to one of the most beautiful places in India.
So next we come to the AND cold recycling. AND cold recycling uses 100% of RAP, and it uses the AND organo-mineral mixture modifier. Two distinctive features of the modifier that bitumen gets rejuvenated and it regains its binder properties. And for the virgin aggregates put into the mix, new crystalline bonds are formed. The advantages are on the same lines that we have seen already. So additional features are 100% use of RAP, and that this mix can be produced either directly on the site using the recyclers, or they can be produced in mixing plants. The cost reduction is almost 50% because of drastic reduction in the use of fresh bitumen and other quantity related savings. Now these are various projects which we have already completed. So we are already working in various states: Arunachal, Nagaland, Meghalaya, Sikkim, Mizoram, West Bengal, Uttar Pradesh, Bihar, Uttarakhand, Jharkhand, Chhattisgarh, Karnataka. And it gives me a great pleasure to share that AND technology is receiving very enthusiastic response from all stakeholders. So these are some of the documents that we show as the proof of our good response that we are getting. This is the IRC accreditation letter and the authority given by AND Technologies to AVS Infra. And with that, I come to the end of my presentation. Thank you. And any further queries can be made on this email and phone number. And we are here in the stalls 12 and 13, so we'll like to interact, whoever would want to know more about it. Thank you.
Thank you, Mr. Anand. Time for a few questions from the audience. Or else, the interaction can be had during the lunch. And may I request Dr. Joshi to sum it up?
Can I ask a question to Mr. Manawat, please? Sir. Yeah, in the earlier presentation in the morning, Dr. Ambika Bahel has mentioned about a little caution about selection of the stabilizers depending on the soil types. So the product you are promoting, have you done any studies about what type of soils it is suitable for and what type of soils it is not suitable for?
You want? Yes. Please come.
Thank you for your question, sir. As far as this technology goes, which is there for the last 35 years, we encapsulate the soil particle with the stabilizer. So imagine a grain, a spherical or of any shape, and the stabilizer encapsulating the soil particle, and with the calcium oxide in the cement. So we don't use cement for the cementitious property. We can work with lime, fly ash with type C fly ash, or lime kiln dust or cement kiln dust. So the chemical and the cement, they form a gel. So the soil particle remains inside that gel. So irrespective of whether it is a red soil or black cotton soil or yellow soil or even sand, we bind them together with a base seal connecting one particle to another particle. Therefore, we are water resistant. We do not allow capillary rise. We do not allow surface water to go in. and we have been so successful. So to answer your question, except for peat in the ASHTO table, we can treat all soil types. And I request for the audience, whoever are there, because I got this opportunity to answer this question, that whichever is your most difficult and submerged roads, which you have to repair every single year, come to us. We will do it for 10 years, and you don't have to look at it again. Thank you very much.
Any other questions? Are you allowing, or we, Chairman, sir?
Yeah, if there are no questions, Mr. Joshi can sum it up.
Yeah. We had total 6 presentations, and most of the presentations were substantiated by success stories. I think it has enough potential to apply and adopt for sustainable rural road construction. I have made a lot of notes, but due to shortage of time, I will avoid it, and I'll give the detailed report to the organizers. So that's all from my side, and thank you all.
Okay. Thank you so much, sir. Thank you, Chairman, sir, and the rapporteur and all the technical presenter here. And as a token of our respect and appreciation, we would like to present you the memento for the session to all the speakers and the Chairman, sir. Kindly, NRIDA team, please. And now I'll request all to please proceed for lunch, and then please come back sharp at 3:15. The 15 hours. Please return back to another technical session so that we can start it in time. We are already running late. Thank you so much. We'll see you in the next session.
India, with all her natural and populational diversities, has been witnessing a sea change in the lives of her people during recent times. New horizons of livelihood opportunities have enabled the larger mass residing outside of the urban periphery to join the mainstream socio-economic flow. Opportunities that have been generously provided by the new lifelines of India. An intricate network of modern, all-weather roads constructed under the Pradhan Mantri Gram Sadak Yojana. PMGSY, a flagship endeavor of the Ministry of Rural Development of India, is managed and technically supported by the National Rural Infrastructure Development Agency, an organization dedicated to building capacity and enhancing quality through training. The project was launched in the year 2000 by the Government of India to work jointly with the state governments in providing all-weather road connectivity to designated areas with population sizes of 500 plus in the plain areas and 250 plus in the northeastern and Himalayan regions. The initiative is a giant step towards realizing India's full human resource potential along a journey on these new lifelines connecting the remotest parts of the country to civil amenities like schools, hospitals and agricultural markets.
इस रोड के निर्माण होने से हमारे विद्यालय में एडमिशन में बहुत ही फर्क पड़ा है।
जब से ये रोड बन गई है, हम लोग स्कूल टाइम पर पहुंचते हैं।
Since the launch of PMGSY-1 in 2000 till PMGSY-3 launched in 2019, rural infrastructure in India has been upgraded to unprecedented levels. Economic activities have increased considerably with the generation of employments in various forms, investments coming in and businesses growing in the rural sector, fueling the economy to reach new heights.
इस रोड के बनने से आज सभी यहाँ उचित विक्रेता अपने ट्रैक्टर से सामान ले जा करके अपने घरों तक आसानी से पहुँच रहे हैं।
In 2016, a special drive was undertaken for construction and upgradation of strategically important roads in the remotest locations inhabited primarily by India's indigenous people. More than 10,000 kilometers of road length has been sanctioned under this drive so far. Till the 31st of March 2022, a total length of around 7 lakh kilometers of all-weather road has been constructed, achieving the full target of the whole project. The total expenditure incurred is rupees 2.77 lakh crores. This phenomenal empowerment of rural India has attracted the attention of the world. The World Bank in its report on the impact evaluation of PMGSY states that the project has improved accessibility in hilly areas and increased access to economic opportunities.
जब से ये रोड बना है टूरिस्ट डायरेक्ट अपनी गाड़ियां लेके बिलिंग जाता है जब टूरिस्ट आता है तो हमारा बिजनेस हुआ काफी जोरों से चलता है
The benefits of the resultant positive impact on human capital formation are being equally enjoyed by all sections of the population. The Niti Aayog has stated in one of its reports in 2020 that the scheme is well aligned with India's international objectives and is contributing immensely towards the nation's sustainable development goals. The selection of target areas for building and restoring roads has been done using the most scientific method by mapping the strategic points on the Geographic Information System or GIS. This mapping has ensured that the most eligible roads are included in the program to provide a boost to India's rural economy. The routine maintenance of PMGSY roads across the country has become more streamlined since 2020 after the introduction of eMARG. It is a GIS-based enterprise and an e-governance solution to aid and assist the officials and contractors in performance-based maintenance contracts (PBMC) of roads, assessing performances and making automated payments. Earlier, these records were kept manually and were often subjected to errors. eMARG has enabled evidence-based, error-free digital record keeping. The last couple of years have seen an expenditure of rupees 1,300 crores in road maintenance under eMARG. A user-friendly app, Meri Sadak, is helping citizens provide their feedback directly to the ministry. So far, about 1.5 lakh complaints have been lodged through the app, almost 99% of which have already been resolved. So far, around 70,000 kilometers of PMGSY roads have been constructed with non-conventional and new materials. Technologies like FDR using cement and commercial chemical stabilizers like Zydex, Terrazyme, ANT, Stable Road, RoadSem and many others have been used in the process. Other novel technologies like cell-filled concrete, paneled cement concrete, use of waste materials like slag, fly ash, waste plastic and cold mix technology have introduced locally available, low-cost and recycled materials to road construction. FDR, a full-depth reclamation, stands out among all of these as a new-age construction technology. It is primarily a road restoration technique. Full-depth reclamation of an existing pavement is a rehabilitation method that involves recycling of an existing distressed bituminous surface and its underlying layers into a new base layer. Apart from mending a damaged pavement structure, FDR can be adopted for upgradation and widening of existing roads without requiring any structural overlaying of base layers, while designing for the same or higher order of traffic category. The shortened construction schedules add to the cost effectiveness of the technology. Overall, FDR has great advantages in terms of saving time, energy, minimizing material consumption, and cost reduction where pavement cost is high, transportation cost of aggregates is high, and the quality of aggregate is not good. The cell-filled concrete technology developed by IIT Kharagpur in India itself has enabled PMGSY to build and restore roads at a minimum cost and a minimum effect on the environment. The use of cold mix technology has drastically reduced the emission of greenhouse gases, and the chances of workers meeting with accidents during construction too has been significantly minimized. The use of waste plastic results in less bitumen consumption and is beneficial to our environment as it recycles plastic waste. However, the introduction of these new and green technologies under PMGSY has led to a huge drop in carbon footprint and made the whole process of road construction faster and a lot more cost-effective. With a view towards achieving an environmentally sustainable economy, PMGSY has envisaged a new technology vision. Now, a minimum 50% of the proposed roads will be constructed using these new and eco-friendly methods, and waste plastic will be used in constructing more than 70% of the total proposed road length. As for quality control, PMGSY envisages a 3-tier quality control mechanism in order to ensure the strength and durability of these new lifelines of India, while continuing on a journey of fulfilling everyone's dreams. Dreams that would no longer be deterred by difficult roads even in the remotest corners of the country. India today has also opened her arms towards the world for sharing these new and unique technologies that are being used for building rural roads and the invaluable experience gained in the process. Thanks to the Pradhan Mantri Gram Sadak Yojana. Concrete, as the technology is called, involves covering the compacted subgrade or subbase with a formwork of plastic cells made from waste plastic. The formwork ultimately gets filled with concrete or stone to act as the pavement. It is stretched and iron spikes are driven at the corners of the cells so that the frame remains stiff. Nylon ropes through the cell walls prevent the cells from collapsing while they are filled with concrete or stones. The cells are shredded out on the concrete base with the help of the frame. The coarse aggregate mixture obtained from the factory is carefully checked with sieves to confirm the right proportion of small and large stones. Then, with precise measurement of cement, coarse aggregate, fine aggregate, water and chemicals are mixed to make the concrete. Even with precise measurements, the concrete is tested thoroughly before being used for construction. Once the quality of concrete is confirmed by the tests, the cells are filled with the mixture. Each cell gets an equal feed. Further, the concrete is distributed from the bottom to the top of each cell equally with a road vibrator. A final layer of concrete is spread out and then the road is leveled manually, which adds precision and perfection to the construction. Finally comes the curing process. Agricultural waste straw along with water is poured on the road. Cell-filled concrete technology provides with the opportunity to recycle plastic, which is one of the biggest environmental hazards today. It reduces the construction cost to a considerable extent in comparison with cement concrete pavement. The consumption of aggregate is also reduced substantially compared to conventional cement concrete pavement. The high stiffness of the material reduces the overall crust, which makes road construction economical. Maintenance of these roads is easy, as in case individual cells fail, they can be easily replaced or repaired. As per the new Technology Vision 2022, it has been made mandatory to use cell-filled concrete in 100% of proposed road length in cement concrete road construction under PMGSY. As the Pradhan Mantri Gram Sadak Yojana uses cell-filled concrete in connecting remote habitations with the network of all-weather roads, we salute our institutes and wait for them to come up with more such sustainable technologies that will brighten up the lives and livelihoods of rural India. A major part of the Pradhan Mantri Gram Sadak Yojana is restoring depleted and damaged roads, for which the project has adopted several new and innovative technologies, one of which is FDR, Full Depth Reclamation of Roads. This is a cost-effective and eco-friendly technology that ensures protection, and conservation of the environment alongside reducing carbon footprint to a great extent. Full depth reclamation of the existing pavement layer offers a significantly cost-effective and sustainable rehabilitation method. Apart from rehabilitation of distressed pavement structure, FDR can be adopted for upgradation and widening of existing roads without requiring any structural overlaying of base layers while designing for the same or higher order of traffic category. The process starts with mixed design, which is carried out with a scientific and systematic approach through reputed institutes like CRRI or IITs that balances the existing and desired engineering properties, constructability, durability and economics. Once mixed design is finalized, the next step starts with gauging the level of rehabilitation required. The carriageway is marked with lime. Then comes spreading of cement and mixing of commercial chemical stabilizers like Zydex, Terrazyme, ANT, Stable Road, Roadsem and many others, which is followed by the application of the recycler or reclaimer, which is the main FDR machine for pulverization. Cube mold castings are then sampled from the pulverized road and kept aside for testing. The grader is then applied for leveling the surface. Pad foot is run for heavy compaction and the grader is run again for removing the pad foot marks. The pneumatic tire roller or PTR machine is applied for further leveling and compaction. The cube mold castings are tested for strength and durability after 7 days and then again after 28 days. After the field dry density or FDD test, curing and core cutting, the reclaimed road is open to traffic even before the surface is layered with bitumen. Overall, FDR has great advantages in terms of saving time, energy, minimizing material consumption and cost reduction where pavement cost is high, transportation cost of aggregates is high and the quality of aggregate is not good. States like Uttar Pradesh, Bihar, Tripura and West Bengal are using FDR technology, which is a cost-effective construction methodology. Several other states have proposed to adopt it in the near future. Under the New Technology Vision 2022, it has been made mandatory to use FDR where pavement cost is high, transportation cost of aggregates is high and the quality of aggregate is not good. This will lead India on a path of sustainable development towards achieving the goal of a clean and green economy. Among the various new innovative technologies adopted under PMGSY to construct and restore India's rural roads, Koya Geotextiles stands out both in terms of ecological compatibility and cost effectiveness. The coastal regions of India produce more than 55% of the world's Koya geotextile from the husk of coconuts. The industry is marked by the abundance of locally available raw materials and the active participation of women in each and every stage of production. As an agricultural product, the extensive use of Koya geotextile in road construction provides farmers with unprecedented economic opportunities. Koya geotextiles is a reinforcement technology used for the improvement of subgrades having poor strength. Koya is a biodegradable material. It has a lifespan of 5 to 6 years, within which it provides the road with enough strength and durability to sustain itself even after the Koya has degraded. The technology has various advantages. Koya geotextile helps in decreasing the pavement layer thickness for given volume of traffic, high coefficient of friction, high elongation of 30% and a high coefficient of permeability. It is also resistant to saline water. As per the new Technology Vision 2022, it has been made mandatory to use coir geotextile in rural roads. This cost-competitive, eco-friendly technology is providing rural India with not only road connectivity, but also with opportunities to boost the rural economy to new heights, thanks to Pradhan Mantri Gram Sadak Yojana. The Pradhan Mantri Gram Sadak Yojana aims at connecting the remotest corners of India to mainstream life through state-of-the-art roadways. The pavement construction activities result in significant amount of pollution due to fuel consumption. In this regard, the Government of India is looking for various measures to reduce the contribution of carbon footprint. In this direction, several green technologies have been evolved. One of them is cold mix asphalt technology, which has brought a paradigm shift in the way pavements are constructed. Cold mix technology is a field application of bituminous surfacing course using cold mix binders. The technology does not require heating of bitumen and thus saves a great amount of fuel, which is a 100% environment-friendly process. The whole process can be executed by semi-skilled local workers who have very low chances of meeting with accidents as there is no heating involved. A study has been conducted by IIT Madras along with 5 other institutes. The study shows that the life cycle assessment of cold mix asphalt results in 33% reduction of PM10 emissions as compared to the hot mix asphalt. In addition to this, 7% reduction in energy consumption was also noticed. This indicates that the cold mix asphalt can significantly reduce the carbon footprints associated with the road construction activities. About 17,000 kilometers of PMGSY roads have been constructed using cold mix technology till March 31st, 2022. According to the new Technology Vision 2022, it has been made mandatory to use cold mix in more than 25% of proposed eligible road length to be constructed under PMGSY. Along with several other new, low-cost and energy-efficient cold mix technology is leading India towards a future where every person from the remotest corners of the country is connected to the facilities of mainstream life.
Honorable Ministers, Secretaries, Additional Secretary, Honored guests, ladies and gentlemen. Thank you so much for inviting me to speak at the inaugural session of the International Conference on New Technologies and Innovation in Rural Roads. We congratulate and deeply appreciate the effort by Ministry of Rural Development and NRIDA towards making PMGSY a continued success. We deeply value our long-standing relations and partnership with you. I have been personally involved with the PMGSY since its inception in December 2000, when I was the Transport Sector Manager for South Asia region of the World Bank. I've seen the remarkable progress the program has made over the last 2 decades. The program has already achieved over 700,000 kilometers of all-weather rural roads, which is an impressive achievement, especially if you think that these roads will enable us to go around the world for 17 times. This road has also connected tens of millions of people living in over 160,000 habitations. The program has introduced many innovative approaches, for example, the use of alternative technology and material, sustainable and climate-resilient method, asset management, cost effectiveness, community engagement, and it has achieved considerable success in realizing the 15% mandate to encourage the use of new technologies in road construction, including recent effort of full depth recycling of existing pavement. The World Bank has been proud to partner with the government of India in developing and implementing PMGSY. As I mentioned, we have been involved since its inception through a series of lending operations totaling over $2 billion, working in 9 states. and through technical assistance grants of over $7 million working in all states. Working together with MORD, we have incorporated a rural core network approach to prioritize investment needs, standardized procedure for preparing engineering design, procurement, and contract management, an environmental and social management framework, particularly for low-volume roads, and an independent quality monitoring mechanism. These investments and approaches have supported the overall investment of over $38 billion by the government of India. Looking forward, there are many issues on which we can engage together. We commend the effort of MORD in launching the new technology vision with the aim of maximizing the application of new and green technologies and the use of sustainable and local material in the construction of road access and bridges. We have supported MORD and NIDA in this effort. We need to work together to take measures to incentivize the use of new technologies and material and embed them in our regular business process of the road agencies. For example, to promote the efficient use of local material, construction material, and water, and to reduce the depletion of scarce natural resources and help lower GHG emission, comprehensive studies on the availability of material and resources use efficiency for road network management could be launched from a life cycle perspective. There are global lessons that we can be happy to share with all of our partners. Roads and bridges infrastructure increasingly face the risk of loss and damage from weather-related events and natural disasters. We could work together to develop strategy for integrating the climate resilience and disaster risk management in the construction improvement of roads and bridges infrastructure, including providing all-weather connectivity and access. Mitigation and resilience enhancement measures could be included in the policy, planning, engineering design, business processes, construction, asset management, institutional structure, and associated capacity buildings. The capacity building effort could also be driven through the setting of a center of excellence for green and resilient road infrastructure and maintenance. MORD could also consider creating a technology and sustainability shell within NIDA with a dedicated budget for mainstreaming new technologies and enhancing effort to promote climate resilient and build green infrastructure. This will involve formal collaboration with the industry associations to understand the challenges faced in the industry in mainstreaming these technologies and addressing the supply side constraints. Design a performance evaluation framework and systematically assessing the performance of the new technology is also a very important consideration. As we will hear from this conference, India has many unique and successful experiences. In designing the PMGSY program 2 decades ago, we helped bring in global experience, international good practices to India. Now, in celebrating the successful experience of PMGSY over the last 2 decades, we could also like to partner with you to share your experience globally in Africa region and other parts of the world that could benefit from your experiences. In closing, while I regret that I'm unable to participate in the conference in person, I look forward to hearing about the discussion and wishing you a really successful conference. And also in the next stage of PMGSY, we stand ready to continue to partner with you in your effort. Thank you very much.
Government of India launched Pradhan Mantri Gramin Sadak Yojana or PMGSY during 2000 and 2001 with an intention of providing connectivity to unconnected habitations which would ensure accelerated growth and help eradicate poverty of the rural populace. Karnataka state has reciprocated by establishing a special purpose vehicle called Karnataka Rural Road Development Agency, KRRDA. So far has developed well over 18,000 kilometers of rural roads, including construction of several number of long-span bridges under PMGSY 1 and 2 schemes. KRRDA, with an impressive technical staff strength of around 546 and non-technical staff strength of around 405, has been successfully implementing the scheme. Unique 3-tier quality assurance mechanism as envisaged in the PMGSY guidelines, is scrupulously followed by KRRDA. With the support of 75 number of SQMs, activities like material testing, testing of workmanship during work execution, etc. are being monitored by SQC and his team. Currently, implementation of PMGSY-3 is underway, in which development of 5,612 kilometers of rural road and construction of 102 long-span bridges is contemplated.
Pradhan Mantri Gramin Sadak Yojana or PMGSY is an ambitious program to develop rural roads. In Karnataka, under this program since 2000, we have developed 18,000 kilometers of rural roads. Under PMGSY-3, Karnataka has been allocated 5,612 kilometers of rural roads to be developed. Karnataka has also been given 102 rural bridges to be constructed under this program. We expect the KRRDA to continue to do good work in developing prominent and important rural roads with good quality in the coming years.
Karnataka Rural Road Development Agency under Rural Development and Panchayat Raj Department of Government of Karnataka is responsible for implementing PMGSY schemes. The PMGSY scheme all over Karnataka is being implemented through its subordinate offices, namely the 50 subdivisions and 30 divisions, with roughly around 400 plus technical staff and 500 plus non-technical staff. The roads implemented through our agency are of high quality because of the 3-tier strict quality assurance mechanism that's being implemented as per the standards of NRIDA. At present, around 3,500 kilometers of road length are being executed. They are under various stages of construction. We have also envisaged to construct around 126 long span bridges across the rural roads. Strict quality assurance mechanism thus is being implemented in this institution. The road constructed by our department are very well known for their good quality standards and are liked by one and all across the state.
The comments of the stakeholders elaborating on the benefits realized by the assets created by KRRDA would stand testimony to the work being done by state or KRRDA.
ನನ್ನ ಹೆಸರು ಮಾದೇವಕ್ರಿ ಭಾಳ ತೊಂದ್ರೆ ಇತ್ತು ಇಲ್ಲಿ ಓಡಾಡಕ್ಕೆ ಎಲ್ಲ ಕಂಟಿ ಕಾಬಲ ಬೆಳೆದು ರೀ ನಮಗೆ ಅನುಕೂಲ ಆಗೈತೆ ರೀ ಹಾದಿ ಮಾಡಿದ ಮೇಲೆ ಒಬ್ಬೊಬ್ಬರು ಓಡಾಡಂಗಿದ್ದಿಲ್ಲ ರೀ ಹೆಣ್ಮಕ್ಳು ಹೊಲಕ್ಕೆ ಪಲ್ಕ ಏರು ಟ್ಯಾಕ್ಟ್ರಿ ಬಂಡಿ ಬರಂಗಿದ್ದಿಲ್ಲ ರೀ ಭಾಳ ಚೆನ್ನಾಗೈತೆ ರೀ ಹಾದಿ.
ನನ್ನ ಹೆಸರು ರಾಮಮೂರ್ತಿ ಗಲ್ಕೂರ್ ಅಂತೇಳಿ. ನಮ್ಮ ಮನೆ ಈ ಸೇತುವೆ ಪಕ್ಕದಲ್ಲಿ ಉಂಟು. ಈ ಹೊಳೆಯಲ್ಲಿ 1974ನೇ ಇಸ್ವಿವರೆಗೆ ಮರದ ಸೇತುವೆ ಇತ್ತು. ಅದು ಒಮ್ಮೆ ಬಳ್ಳ ಹೋಯಿತು. ಆವಾಗ ನಾವು ಶಾಲೆ ಹೋಗ್ತಿದ್ದೆವು. ನಮ್ಮ ತಂದೆಯವರು ನಮ್ಮನ್ನು ಹೆಗಲ ಮೇಲೆ ಹಿಡ್ಕೊಂಡು ಆಚೀಚೆ ಎಲ್ಲ ದಾಟಿಸ್ತಿದ್ರು. ಇದು ಉಡುಪಿಯಿಂದ ಶಿವಮೊಗ್ಗಕ್ಕೆ ಹೋಗುವ ಶಾರ್ಟ್ ಕಟ್ ದಾರಿ ಇದು. ಇದರಲ್ಲಿ ಹೆಬ್ರಿ ಬಿಟ್ಟು ಹೆಬ್ರಿಗೆ ಹೋಗದೇ ಇದ್ದರೆ ಶಿವಪುರದಿಂದ ಮುದ್ರಾಡಿ ಸೀತಾ ನದಿ ಆಗುಂಬೆ ಮೇಲೆ ಶಿವಮೊಗ್ಗಕ್ಕೆ ಹೋಗ್ತದೆ. ಹಾಗಾಗಿ ಇದನ್ನು ಡಬಲ್ ರೋಡ್ ಮಾಡುವ ನಿರೀಕ್ಷೆಯಲ್ಲಿ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಭಾರಿ ಗಟ್ಟಿ ರಸ್ತೆ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಒಳ್ಳೆ ರೀತಿಯಲ್ಲಿ.
इस जीवन में इस गांव में कभी सड़क भी आएगी ये सोचा नहीं था, पर PMGSY ने ये सपना भी पूरा कर दिया है.
जब इस गांव में रोड पहुंच गई है तो इसके आने से हमें घर पे ही रोजगार मिल गया है.
पहले जब कोई रास्ता नहीं था तो एम्बुलेंस कहाँ से आती थी. अब जब बन गए तो घर घर एम्बुलेंस आ जाती है. कोई डॉक्टर बुलाना चाहे तो भी आ जाता है.
अब रोड आने से बहुत सारी हमारे लिए सुविधाएं हैं.
हुए आज वो सपने पूरे कल थे जिनसे अनजान. हुए आज वो सपने पूरे कल थे जिनसे अनजान. आज मिली हम सबको एक नई पहचान. PMGSY सपनों की सड़क, सपनों की सड़क.
हमारी जिंदगी तो बोझा ढोने में ही गुजर गई. कोई बीमार हो, फसल बाजार ले जानी हो, 7-8 किलोमीटर रोजाना पैदल चलना पड़ता.
करते थे पहले भी हम कड़ी मेहनत और तपस्या. थी रोजगार की चिंता और शिक्षा स्वास्थ्य समस्या। सपनों की सड़क जो आई सपनों में आई जान, आज मिली हम सबको एक नई पहचान।
पीएमजीएसवाई के अंतर्गत उत्तराखंड में वर्ष 2000 से अप्रैल 2022 तक कुल 2781 स्वीकृत योजनाओं पर 7908 करोड़ की धनराशि व्यय करते हुए स्वीकृत 20,374 किलोमीटर सड़कों के लक्ष्य के सापेक्ष 18,628 किलोमीटर सड़कों का निर्माण किया गया है। पूर्व की 1,867 असंयोजित बसावटों में से 97% 12 मासी सड़कों से जुड़कर सभी सुविधाएं प्राप्त कर रही है। शेष को सितम्बर 2022 तक जोड़े जाने का लक्ष्य है।
पीएमजीएसवाई, सपनों की सड़क, सपनों की सड़क।
PMGSY, connecting rural habitations. One of the most significant characteristics of the Pradhan Mantri Gram Sadak Yojana has been the extensive use of new and unconventional materials for road construction. One such material is Terrazyme, a popular and tested modern road construction ingredient, which is being used all across the country to build PMGSY roads. Terrazyme is a liquid bioenzymatic soil stabilizer obtained from food-grade raw materials. An eco-friendly, non-toxic and biodegradable chemical. It improves CBR, modulus and UCS alongside decreasing permeability, leading to enhanced workability of the soil for road construction. The advantages of Terrazyme soil treatment are manifold. Firstly, the technology reduces the volume of stone aggregate used for road construction by 70%.
Fellow officers and your fellow participants to please call them. We are starting the session and this session is going to be very, very interesting. And I am sure after taking a very delicious meal, we are full of energy. Contrary to the belief that after the meal we will be sleeping. No, I think this time we provided you the meal which will give you the energy. We put some herbs into it, isn't it? Dr. Veera Raghavan sir? We put herbs into it, yes. IT professor is also saying. Kaul sahab is also smiling. So you will be full of energy. Yes, I would be calling the session chair. Please make yourself comfortable. Yes, yes. Okay, I'll start very, very quickly. Session chair is Shri C.P. Joshi. I think he's already on the dais. Yes, Shri C.P. Joshi ji, welcome you to the session as the session chairman. And I'll introduce a little later. And Dr. Ankit Gupta, reporter from IIT BHU. Welcome, sir. And our speakers are, one speaker is through VC, Shri Rob Geddes, consultant from Africa. And then we have our Professor Veera Raghavan from IIT Madras. Welcome you, sir. Then we have Shri Mike Pinat, Infra Africa consultant, South Africa. Welcome you to this session. And then we have on the VC Dr. Ishwandru, I'm sorry for not being able to pronounce it, from AECOM UK through VC. He will introduce himself. And then we have Shri Ian Greenwood from New Zealand, Senior Advisor, International Road Federation. Welcome you onto the session. Shri Scott Bloxham, Senior Advisor, International Road Federation, is another speaker. Welcome you, sir, to this session. So we have this session very good learnings, I am very sure, in the international experience and our own experience. I'll just allow me some 1 or 2 minutes to introduce our panelist. Sri C.P. Joshi, as you know, he has served the state of Maharashtra in the capacity of in all its capacity up to the level of chief engineer and then the secretary of the PWD for 5 years. And presently he is the secretary roads and president IRC. In his career of Maharashtra service of about 35 years, he has executed several long span and short span bridges. And he has to his credit the completion of around 11,000 kilometers of state highways and 13,500 kilometers of major district roads. He was especially assigned with the task of completion of first tranche of 150 km of rural roads sanctioned in the first year of PMGSY. So, sir, you have been the pioneer and you have been the beginner of this such a great scheme, and you must be satisfied that how this PMGSY has grown. As I was saying that now all roads in India leads to PMGSY. So, sir, this was a great statement given by our honorable guest. And now that I'll introduce rapporteur Dr. Ankit Gupta. He is from IIT BHU. He is presently Associate Professor and Ministry of Road Transport and Highways Chair of Professor in the Department of Civil Engineering, IIT BHU. He obtained his doctoral degree from IIT Roorkee. His experience is in pavement maintenance and performance modeling, mechanistic analysis and design of pavements, traffic flow modeling and safety. So during the last 15 years, he has been involved in the several academic research and professional activities. So we are going to get benefited with your vast experience. And then I'll just quickly introduce all the session speakers. First is Mr. Robert Geddes. He is based in Harare. He will be joining through VC. And he is consultant to the government agencies and international donors for the design, implementation, evaluation and audit of road improvement and maintenance program. He has provided advice to various government departments, and he has been associated with the World Bank, European Union, and many such organizations. And then our another speaker, as you all know, Professor A. Veeraraghavan, IIT Madras. He doesn't need any introduction, but I'll just customarily read one line, sir. Dr. A. Veeraraghavan is currently professor in the Department of Civil Engineering at IIT Madras. He has earned his PhD from Bangalore University, and he has got lots of publications, 100 research papers and 150 research publications in international and national conference. Welcome you, sir. And then we have Shri Mike Pinart, Infra Africa consultant. He is a chartered civil engineer with more than 45 years of postgraduate experience in various regions of the world. He is a fellow of the UK Institution of Civil Engineers, and in the last 20 years he has been involved in various aspects of low volume roads technology in African and Asian regions. You have, sir, vast experience, and definitely the audience is going to get benefited out of your talk here. And then we have Sri Iswandru from AECOM UK through VC. He is a technical director for AECOM, leading the pavement and materials research team. He is a UK chartered engineer and fellow of Chartered Institution of Highways and Transportation, and fellow of several other institutions as well. Then we have Sri Ian Greenwood from New Zealand. He is a chartered professional engineer and a fellow of engineers of New Zealand. He has been recognized with several international awards and the accolades, and his global leadership in the field of transport sector. And he has been a lead author for the World Bank guidelines on the implementation of performance-based contracting in the road sector. So we are going to get benefited with your talk on performance-based, because in NRID and in the PMGSY we are working on that performance-based a lot, and we have successfully implemented many things. We will be benefited with your experience, sir. Then we have Sri Scott Bloxham, Senior Advisor, International Road Federation. He is a chartered professional engineer with more than 25 years of experience. He is currently providing international consultancy services to clients based in the UK and the Middle East and the Pacific region, and his management services to the United Kingdom's highways market, as well as asset and network management contracts in the Middle East and Australia. Thank you, sir, and welcome you for this session. Now I'll just do a quick thing of honoring our speaker and the session chair. I'll request the NRIDA team to give them the moment of bouquet as a mark of our respect. Thank you so much. Your music, please, because it will awaken everyone with we will fill up with the full of energy, the audience. Where is the music? Music, please. Okay. So we are already awakened, and we are ready for this session, sir. I'll request session chair to now take over and please start the proceedings, and we need to take care of the timings and all that. I'll request for all to adhere to it. Thank you so much, sir.
Thank you. Ladies and gentlemen, we are coming to a very difficult session. A post-lunch session is always difficult, but the subject that is assigned to me and that we are going to deal with now is really and critically important. We always go in for very good creation, but have a dubious record of not maintaining things properly and thereby facing lots of problems. It's a reality, because maintenance funds are a bit low, short. We are always short of them. We have tried to figure out many ways, and it is now a high time that for PMGSY and the states which are conducting the CMGSY, we should come in for some legislation just like CRF, so that the financial management of or the asset management of PMGSY roads, which is staggering 8 lakh kilometers in the whole country, will become easy. We'll listen to different lectures. I will request my colleague, Dr. Ankit Gupta, to record in brief and give the details to the organizers. The first presentation and the first lecture is a framework for road asset management from Mr. Rob Jeddes, who is consultant CDSA Africa. I request him to start.
Good afternoon, everyone. I expect you can hear me. I suppose somebody will tell me if you can't. Thank you for your... I'm just loading my presentation here, and I'm sure it can be seen by all. I'd like to thank the organizers for this opportunity to participate in this important meeting, and congratulations for organizing it. I would very much like to have attended the conference in person. I'm feeling jealous when I hear about the delicious lunch you've all just enjoyed. But at least we do have another method to communicate without always having to travel. Also, I think you're aware that in Zimbabwe we also love our cricket, and I would love to have been in India at this time of the IPL. Glad to see the Rajasthan Royals doing so well this year, even though they sadly lost last night. Anyway, we're not here to talk about cricket. We're going to talk about pyramids, and this is pyramid power. So there was a belief that ancient Egyptian pyramids and objects of similar shape can confer great benefits, and some people even claim that if you put razor blades in a small model of a pyramid, they will stay sharp forever. Well, I don't believe in that. And the pyramid I'm going to introduce you to, describe, is certainly has no magical properties, but I have found it to be a very useful tool for assessing performance of road agencies in their asset management. Basically, this pyramid promotes a holistic approach to the management of roads by considering 6 building blocks which support our goal, which is sustainable road asset preservation. The pyramid was used in this PARC document in 2016, and I'd like to acknowledge the contribution of fellow presenter Mike Pinard, who was one of the authors of this document. Basically, PARC recognized that the maintenance challenge is multi-dimensional. It's influenced by interrelated factors, and these can be viewed as a hierarchical pyramid. The point is that if we have weak building blocks in our pyramid, the structure, even though this is a stable structure, it will collapse, in particular if the weaknesses are in the foundations. And when the pyramid collapses, we found that our goal, our objective of sustainable road preservation is lying in tatters. This is what we find in so many instances in many countries. So I'm going to go through each of the building blocks quite briefly. So you can see what the key issues are. And if you do work for a road agency, you can be perhaps in your mind just answering these questions and judging in a brief kind of way your own performance in road asset management within this framework. So starting with the external and political building block, this is the foundation, the very important foundation of the pyramid. And this often concerns factors outside the direct control of the agency. It concerns government policy. It also considers stakeholders. So key questions we have to ask when we assess the strength of this building block: does the government have a rural road asset management policy? If it does, is this policy supported by senior decision makers? And then with stakeholders, does the agency carry out consultation with the road users and other stakeholders? Does the agency understand their needs and expectations? Oops, why am I not moving forward? Okay, institutional building block, the second building block. So this really concerns the organizational structure that allows us to achieve our objectives. But it also includes the important issue of level of service. Has the agency defined the basic levels of service for roads, and are these agreed by stakeholders? Can the agency recruit and retain good staff? Staff are critical, obviously, part of the organization. Does it provide training opportunities? And are our agency salaries comparable with the private sector so that we can retain our staff? I'll just talk a little bit about level of service. So level of service, and this, I'm talking about this because it's often missing. It's a description of the performance of the road network that the road agency undertakes to provide. The level of service must be easily understood by road users and stakeholders, and we need to agree a level of service for each road under control of the agency. It should be agreed and defined. And as you know, level of service might vary in rural areas. Perhaps it tends to be better than in urban areas. The one on the right is particularly low level of service, commonly found in our cities, not so much in our rural areas. The important issue is that we should not undertake to provide a level of service that we can't afford. Okay, moving on to our financial building block, and our chairman of our session has already highlighted this important building block. First question: is there a stable, adequate, and sustainable source of funding for roads? And I'm afraid in just about every road agency that I've had any contact with, the answer to that question has been no. There are other aspects that we need to consider where we often get a positive result. Do we carry out annual valuation of our road assets? Is there a budgeting process in place? And are there robust financial accounting and auditing procedures in place? But we must consider all of these aspects when we're judging our performance under the financial building block. This picture also borrowed from Mike Pinard, basically showing our hard-pressed Minister of Finance faced with demands from all the sectors, and very often the request for funding for road maintenance is consigned to the bin. We find that funding of maintenance is heavily influenced by political decisions. It's overlooked in favor of capital projects. So and we need to find alternative funding sources. And I know that in India you have a lot of toll roads, and you've found this as a useful option. Of course, tolls are not going to work on our low traffic rural roads. So moving on to the planning and management building blocks. So basically this is looking at how we manage our asset, we conduct our asset management. Does the agency have an asset management system in place? Is the network defined? Have our road and bridge and culvert inventories? Do we carry out regular condition surveys? Do we collect traffic data? Do we use this data for preparation of our annual and longer term plans? Lots of tools that are available. In a small rural road agency, we may not need any of these types of tools. Maybe we can make do with a simple spreadsheet-based system. The important point is that we should have some sort of management system in place. Okay, technical building block. We're getting towards the top of the pyramid here, and this can concern two things. Can concern design standards for roads. Are these clearly defined by the agency? Are they appropriate to local conditions and the needs of our road users? Are they affordable and are they sustainable? But the technical building block can also consider, let's say, the technical aspects of road asset management. What type of road referencing system are we using? What methodology are we using to collect our condition data? And then what assumptions are we making on things like roughness, progression, and gravel loss? And there's just some photographs of different standards of roads. These are all in the same area in Mozambique, from different bits of road appropriate to different levels of traffic. So finally, we move on to our operations building block. And this is looking at how the agency actually carries out maintenance. Does it have an appropriate balance between our in-house kind of force account operations and outsourcing? In some cases, it may be appropriate to carry out work in-house. In other cases, not. Nevertheless, can the agency outsource activities? Is it able to? Does it have systems in place and procurement systems that allow it to do that? Funding? Are the maintenance works scheduled to align with the financial year and the rains? Are we trying to carry out periodic maintenance in the monsoon? For example, are the conditions or forms of contract appropriate? And this is an important one. Does the agency carry out independent technical auditing of the works? So those are the 6 building blocks, and I hope you understand what they entail. So what we have is what we developed under a research project under RECAP, funded by UK government, was a method where we can actually assess the performance of an agency using this concept. And basically what we do is we have a set of questions for each of the 6 building blocks, which the agency can answer and come up with a score. And I've just put in some scores here. This was a typical agency. You'll see that the maximum score for each building block is 4 in this case. It doesn't have to be 4. And this agency scored particularly badly on the managerial, only getting a scoring 0.9, but quite well under external, where they scored 3. Now, what we can do, what we did do, we assessed weightings for each building block, because I think people generally feel that the building blocks have different importance and contribute differently to our asset management. So the building blocks at the bottom of the pyramid were given higher weightings. So for the external building block, the weighting was 0.29, operational 0.05. And then using those weightings, we can just easily calculate a weighted average, which we call the Road Sector Sustainability Assessment Score. In this case, the agency scored 1.8. And using some criteria, you can establish your own criteria.
Please wind up.
Yes, I'm nearly finished. Thank you. So this agency came out with 1.8, which is fair. They need to improve their performance. We can present the results on a simple diagrams. The green line there showing the results, and obviously the idea is to increase the area within the green line, which would show better performance in each building block. We can also present the results in the shape of the pyramid, and you can see quite clearly where the weaknesses are. We carried out this type of work, field work in various countries. This actually was in quite a remote district in Sierra Leone, where we were just helping the technicians and the engineers to assess their performance. And what we found using this method, changes in performance can be monitored over time. You can monitor whether we're improving or not. The government can also compare the performance of road agencies, and a particular agency, by assessing its performance, can identify specific actions where it can improve its performance. And this is my last slide. Thanks very much for your attention. I'll just close by saying that the road preservation pyramid unfortunately has no magical powers. We need strong commitment from the government and the agency and road users to achieve our goal of sustainable road asset management. And the important issue is that all 6 building blocks of the preservation pyramid must be addressed. So thank you very much for your attention.
I now request Professor Veeraraghavan to deliver his lecture.
Thank you, Chairman. So the session is on asset management. So initially I consented to talk on asset management, but later I found that there are 2 other speakers, one Mr. Scott and Dr. Greenwood, who are going to talk on asset management. Then I thought that I can talk differently about some component of the asset management, which will definitely contribute to the managing the road assets. So I have been associated with this PMGSY program ever since its inception in December 2000 for about maybe over 5 years. Then later I lost connection with the PMGSY program on a day-to-day basis, but still I've been associating one way or other with this PMGSY program. So that's how the continuity is there and that's how I am here before you. When we talk about this asset management, what is the asset we are talking about? That is something that we need to debate, discuss, and learn before we go further into this asset management. So a question that I pose is that, how is the road asset performing? So we do have in India national highways around 1,40,000 kilometers, and other roads is around 6 million kilometers. Yesterday, DG was mentioning nearly about 45 lakh kilometers are PMGS rural roads. So out of this, we have sanctioned nearly 7,74,899 kilometers, and we have constructed 7,07,159 kilometers completed. The question which I pose before you is that, how are these assets? What is the rating that you can give? Are they very good, fair, poor, very poor? What is the condition of these road assets? What length is in different categories? So we have sanctioned nearly 3,33,766 crores. We have constructed the asset. What is the value of this asset as on today? If we don't maintain this asset, what will be the value of the asset 5 years down the line and 10 years down the line? We do have a performance-based maintenance contract. This is something which I learned recently, but again I'll discuss about this performance-based maintenance contract as well as about the E-Marg, which you have been telling about. I'll tell my way of looking at the maintenance of the road asset and its importance. So the question which I pose is that, what length of PMGSY program roads of phase 1 are in different condition? I mean condition. Then the question arises at this point of time, what is this performance you are talking about? Performance is the ability of the road asset to serve its intended purpose to the traffic, mainly the road users. Are the road users happy about the condition of the road? Are they all very good? Then incidentally the question arises, what is that very good you are talking about? Is it subjective? Can I quantify this parameter? This is the first question that I have to get an answer from those concerned about this 7,07,159 kilometers of roads that have been constructed. Second, if you don't, any road for that matter, with traffic or without traffic, will start deteriorating. Maybe because of climatic conditions, because of environmental conditions, based on quality of the construction, So the second question that I pose is that, what are the maintenance needs for these different categories of payments in different conditions? Is it the routine maintenance that will adequate? No. There are different types of maintenance which you are talking about. The third question is that, if I maintain these roads, I mean, maintenance does not mean routine maintenance. There are different types of maintenance. But we have been talking about only routine maintenance. When I started digging, I wanted to, listening to the eMarg presentation in the YouTube today morning, I was looking at that. What are the parameters that you consider for the maintenance? So maintenance, what you've been talking is about the restoration of the rain cut, making up of the shoulder, maintenance of the bituminous surfacing, maintenance of drains, maintenance of the culverts, maintenance of signs, maintenance of 200-meter, hectometer stones, kilometer stones, cutting of branches, whitewashing of the parapets, repair of some sealants in the joints. These maintenance which we have been talking about is a routine maintenance. This routine maintenance is supposed to be done day in and day out. So what we are talking as a maintenance-based contract is this routine maintenance. But I am going beyond that. A payment, when we design for a 15 years period, it should serve the intended purpose in a very good condition. It should not fall below the fair condition. That's why when I say design life means initially it's very good condition. With the passage of traffic, from very good it becomes good, it becomes fair. This is what we expect the PMJSY road to have at the end of the design life, not at the end of the life. So when I talk about this, there are these payment conditions start deteriorating. The initial 40% drop in the quality occurs in 75% of the life, and the next 40% drop in the quality occurs in 15% of the life. And in this process of the life cycle of a payment will warrant a routine maintenance to be done day in and day out. It will warrant resurfacing to improve the riding quality. It will warrant a minor rehabilitation. It will warrant a major rehabilitation. It warrant a reconstruction. All these form part of the asset management. The asset has to perform. You have to do all these processes. If you don't do this, there's a penalty of the deferred maintenance. The value of the road asset deteriorates. That I'm more concerned about what is the value of these 7 lakh kilometers which are constructed 10 years down the line. But the issues here in India is that maintenance is a state subject. But again, it's a road asset, it's the country's asset. How are we going to preserve the asset, maintain the asset, and ensure that the quality of the asset is much better than what it was previous year? So when we talk about this, roads are the largest community road assets of the community. So we need an asset management which is generally a tool for systematic process of maintaining, operating, and upgrading the road asset. Maybe that many of those who are here will tell that once we create the PMJSY road, there is an increase in the traffic. With the increase in the traffic, the roads start deteriorating. So that is something that what I want the PMJSY officials, NRIDA to consider is that it's time that we quantify the condition of this PMJSY 7 lakh kilometers in different criteria. I'll come to that issue of what criteria, on what basis we can define the condition of this road. Second, we would like to know what is the change in the condition over a period of time. Third, what is the maintenance that is needed? Number 4, if I do the maintenance, there are again different types of maintenance under each of the categories which I talked about. What is the cost-effective treatment? More importantly, what is the optimal time for the maintenance of different treatments? The more and more you delay, one type of treatment will not work. For example, if I will show in a graphical form as how the time becomes important in the terms of asset management. We need an organized and flexible approach for decision making in the sense, which road to be taken? What is the treatment that is to be given? Is it cost effective? What is the extended life of this treatment? This is something that will enable me to decide whether to fund a road A or fund road B. What are the benefits? We know pretty well that in the PMJSY program, the benefits are mainly social benefits rather than economic benefits. So we need to quantify this in the terms of decision making. And more importantly, we have constructed these roads. We have followed some codal practices, ISA ASP 72. How are the assets performing? We have designed the road. Is it performing as designed? This is something that quantified data on the performance which enable us to know whether the system is performing as designed and constructed. And more importantly, when I find the PMGSY program having been associated for the last 2 decades, quality is an issue. The quality of construction matters a lot. How is the relation between the quality and the performance? What needs to be done to improve the quality? How to improve the performance is something that we need to debate. It also will enable us, asset management will also enable us to interact and justify the investment made with the politicians, with the public, also with the management. We should also be able to develop a single as well as multi-year program, maintenance program. Scheduling has to be done. So which means as the road asset starts deteriorating, which asset, what length can be maintained in the year 22-23, 23-24, 24-25. I should have a shelf of projects. This again needs the quantified condition of the road asset. Secondly, at what rate is deteriorating. Number 3, what is the maintenance treatment to be done. Number 4, what are the benefit of doing this maintenance. So we need also, when I talk about the new material technologies that we are bringing in, what are the benefit of using this technology? Is it definitely extending the life? By how many years? What is the life cycle cost of this new technology, new material? In fact, we quantified the benefit of 2 technologies, waste plastics and coal mixes. We have taken up the third on the performance of concrete roads. Again, we have constructed several thousand kilometers of concrete roads on PMGSY. How are they? Are they cracked? Are they performing well? Was the quality of the concrete good? I think this is something perhaps I'll be able to answer next year when we get the quantified data on the performance and relating to the quality of the construction. Also, should we construct more and more kilometers of rural roads? This is something that we need to debate. When I was talking to Jain, we were discussing, we have 45 lakh kilometers. Under PMGSY, we got only 7 lakh kilometers. We do not know what is the condition of these 7 lakh kilometers. What are the condition of these 38 lakh kilometers in the country? How are they? What are the maintenance needs? I think overall we need to assess the condition of the road as well as decide the maintenance treatment. So a good asset management consists of, we have to set our goals, policies. Policy sense, what should be the condition of the road by 2025, 2030? We have to set a level at this point of time. If we want to set an asset, all the roads, all the rural roads or all the PMGSY roads will be excellent, very good, or at least good, or at least fair by 2030. If so, what is the inventory as on date? Inventory of the road condition. So the condition need to be periodically assessed over a period of time so that I will be able to predict as how the condition changes with the traffic, with climate and with constraint quality and many other parameters. We need an engineering decision on the maintenance as well as rehabilitation. I talked about minor rehabilitation, major rehabilitation. And again, there are good practices, there are bad practices. So many times I find that the performance is not as expected, not because of the wrong decision, but because of the wrong choice of the treatment. There are a number of treatments available here, that's an engineering judgment. Resources are limited, budget availability is low. So that means we need an optimal maintenance decision that is to be made. And more importantly, we also want to know what the feedback. How is the asset performing after the maintenance treatment? So we need a quantified decision about the performance of the payment. That also warrants a performance prediction models. For example, when you talk about the payment has reached a condition, what is the condition? Maybe 20% crack, maybe 20 millimeter rutting. What is to be done for this road? Should I do a premix carpet? Should I do surface dressing? Should I do a micro surfacing? If so, will the rut from 20 will become 0? Will the crack become 0? Perhaps it may become 0. But will the condition remain the same next year? That is the $1 million question. So again, we need a performance prediction models for different payments of different conditions, structural as well as functional, duly considering the climate, traffic and environmental factors. We also need a data integrity. What I mean is that you can go to the exhibition, you find that the number of vendors have got different equipment available. So are we getting the same data, same number from different equipment, which again means we need to standardize the process of data collection. This also will enable me to decide what the remaining life of the payment. I think according to this, 5 minutes, 53 seconds are there. There's a life cycle cost estimate has to be made. We need to have an optimal maintenance decision, and we need to implement and get a feedback on the performance. We want to integrate the asset as well as the management. There are individual assets. I don't talk only about roads. The asset means not only roads, bridges, roadways, safety appurtenances. When you talk about kilometer stone, hectometer stone, signboards, all these come under appurtenances. We also need a systematic and integrated approach, so the asset as a whole has to be studied. Extensive data, 7 lakh kilometers, extensive data needs to be processed. Maybe that even NHAI, they claim that they have collected the data. Then what are you going to do? What are you doing with the data? Have you studied the performance? Have you assessed the maintenance needs? No. I think it's time that we also look at the asset condition and manage the asset. Funds are to be allocated across the competing projects for new construction, augmentation, upgradation of this asset. At the same time, it's time the cost-effective treatment is by pavement preservation. Major demands are for road network or all-weather road connectivity. The assets are to be maintained and preserved. So the maintenance can be a preventive maintenance and corrective maintenance. One is proactive, other is reactive. The preventive maintenance is cost-effective. Extend the life longer. You can postpone or delay the time for major maintenance. So if you delay the maintenance, the assets start deteriorating much faster. So how effective is the preventive maintenance? This needs to be quantified. So these preventive maintenance treatments, preservation treatments will extend the life, will decrease the agency cost, and this is the time that we look at the preservation treatment that need to be done for the PMGSY roads. This is what I was talking about, the decision making. A payment is excellent, very good initially, becomes good, becomes fair, becomes poor, and becomes very poor. When you do the treatment, when it is preventive maintenance in a good condition, payment in a good condition structurally, but functionally not meeting the requirements, it's time that we do a preventive maintenance. What are the choice of preventive maintenance? And if you delay the preventive maintenance from that time, when the pavement is in good condition, when it becomes to fair condition, the same preservation treatment will not work. We need a minor rehabilitation, which may be around 10 times costlier than preservation. I don't do that. I delay it further. Pavement becomes from fair to poor. Then the cost of maintenance further becomes another 10 times more. So the more and more you delay, citing that I don't have the budget, you will not be able to preserve and maintain the road asset. So time is money. In addition to this, if I do a preventive maintenance, I can extend the life of the pavement, I can delay the time for major maintenance, so it is also cost effective and also beneficial. At the same time, we are talking about this EMORG, which is not considering the quantified distress of payment. Similarly, when you talk about this performance-based maintenance contract, the traditional contracting is based on the schedule of unit prices. What we are doing in the EMORG is that I know the quantity of material that has to be consumed or constructed by the contractor. Based on the quantity that we have consumed, I make a payment to the contractor. But that is not the condition which I am talking about. When we talk about road asset, I am talking in terms of performance. Is the road very good? Is it fair? What is the maintenance treatment? When it is to be done? All these form part of the road asset. So we need to specify the performance in the maintenance contract. Performance in the terms of quantified measurable distresses. Maybe the next slide I'll show about that. The contractor will decide the timing for the maintenance. The risk of maintenance treatment is transferred from the agency to the contractor. The role of the agency becomes only a facilitator rather than like a manager. These in IRC 82, I think Dr. Pradeep also is here. We have now come out with IRC 82 guidelines. This will be published maybe in next this mid-council meeting. We have quantified low volume roads. What are the performance requirements in terms of cracking, raveling, potholes, patching, redding. In addition to that, we also quantify the roughness riding quality requirements. So in a way, when you talk about a performance-based maintenance requirement, we need to quantify these distresses, and then we have to find out what contract will work. We have to decide on the choice of applicant technology, new materials, higher risk will be the contractor. We have to improve the efficiency and effectiveness. So challenges before us are in terms of maintenance is being done by the state government, not the central government, but we need to define the quantifiable performance standards. Second, different equipment are available. We have to standardize, harmonize the equipment that will be used. We have to define what parameters we'll consider for the performance. We need to, the performance maintenance-based maintenance contract should include the pavement condition index, riding quality, maximum permissible values for rutting, cracking, number of potholes, shoulder condition, and payment to the contractor should be based linked to the quantity, quality, as well as the committed performance. So benefits to citizen is too much. Benefits, the challenges before is inventory of that 7 lakh kilometers, harmonization of the different equipment, periodical performance data collection, prediction of the performance, relating the as-built quality to the observed performance, project versus network level management. I think the quantification of the benefits of timely maintenance is what is needed. Summary, the pavement preservation, extend the life, improve the performance. So data and the performance of new materials and technologies need to be collected. Asset management framework should be set in place in NRIDA. A tool for decision making and efficient management of road asset is the need of the hour. So need for a performance-based maintenance contract, duly quantifying the performance criteria is the need of the hour. Thank you very much.
Thank you, sir. And I request Mr. Mike Pinard from South Africa to make his presentation, please. Sir, you have 15 minutes.
Thank you, Chairperson, and good afternoon, ladies and gentlemen. Can I say at the outset, it's a pleasure to be back in India. I had the good fortune of participating in a project for the World Bank under Dr. Ashok Kumar, in which we developed a guideline for the design of low-volume roads using an alternative method of design based on the DCP. And that was the subject of Phil Page-Green's plenary presentation. During the course of the project, I also had the good fortune of visiting a number of PMGSY roads and saw at first hand the great work being done on the ground. From interaction with practitioners, it was quite clear that many of them were thinking innovatively with regard to how to use local materials in the best way possible. And one could conclude from that experience that India has led the way in many respects with regard to the PMGSY program and the obvious benefits that are internationally recognized. My presentation is on international best practices in the design of low-volume roads. And this is based on extensive research work carried out in a number of African and Asian countries in the last 30 to 40 years. And that research work has challenged many of the traditional paradigms that we've adopted in the past for designing low-volume roads. So in my presentation, I'll make a brief sort of general introduction, the characteristics of low-volume roads as we see them, the design philosophy, the lessons learned from research, which is so important, as well as new approaches emanating from the outputs of that research work, and a brief summary. So what am I trying to achieve in my presentation? Essentially to engender a greater awareness of relatively recent research-based developments in LVR provision. And I think that these new approaches provide the potential for providing such roads more cost-effectively than hitherto, as I will try to explain to you in my presentation. You see 2 slides there of typical low-volume roads. These are actually from Malawi in southern Africa. And these roads have been constructed from natural gravels such as laterite, surfacings, which are almost largely non-AC. In this particular case, it's a Cape Seal. And on the left is an unpaved gravel road, which again has been constructed using natural gravels. And to date, after 4 or 5 years, not surprisingly, because they are designed on the basis of research evidence, they're performing quite well. But first of all, this conference, which is dealing with innovations and new technologies in rural roads, it does beg the question, what is a rural road? Because there are many kinds of low-volume rural roads serving different functions. And they may be primary, secondary, or tertiary access. They may be paved or unpaved. In our context, especially in Southern Africa, there's one characteristic that we agree upon, and that is that they all carry relatively low volumes of traffic. If you look at my schematic in the top right, we're talking of these tertiary access roads, whose function is to provide basic access, not mobility. And we must draw a distinction between access and mobility and the related standards attached to these different functions. At the bottom right, you can see that we're talking of the majority of the road network, as is the case in India and in most other countries. Most of the road network serving rural communities, of the order of 75%, is where there is a challenge to provide such roads as cost-effectively as possible. And that's what we're aiming for. These roads typically carry less than about 300 vehicles per day, and the design life over 10 or 15 years is, generally speaking, well less than 1 million standard axles. But we need to differentiate carefully in terms of the specific function that they provide in relation to the selection of an appropriate standard. We've all listened to some excellent presentations in the last couple of days dealing with various types of technologies. And the key question one might ask is, where do these new technologies have a niche application in the spectrum of low-volume roads? Is it the low end? Is it the upper end? If we bear in mind that the IRC SP 72 2015, which is a design catalog for low-volume roads in India, catering for traffic up to 2 million standard axles, using natural gravels, then that suggests that most of the presentations we heard of these new technologies, including full-depth rehabilitation, including coal in situ recycling, including stabilization, one would conclude that they would be more appropriate for fairly high traffic roads in excess of 2 million standard axles. Do these types of roads still exist in the PMGSY program, or have we moved away from that and we're now into state roads carrying much higher levels of traffic for which these technologies would be more appropriate? That's something I think we have to think about. We tend to use, and I've heard it at this conference, somewhat disparaging terminology when we refer to our low-volume roads. We talk of low-cost roads, marginal materials, non-standard materials, relaxed standards. Is that not conveying a negative connotation to decision makers? Imagine yourself going into a showroom to buy a car, and the salesman says, well, I've got 3 types of cars I can show you. This one can travel up to about 80, 90 kilometers an hour. It's built of marginal materials. This one can travel at 150 kilometers an hour, good quality materials. Would you buy that marginal material car, even though it is fit for purpose? If I were using a car, driving short distances at low speeds, to me, that first car with a maximum speed of 80 is more than fit for purpose. It's not marginal, it's not standard, it's fit for purpose. So I think we must dispel some of these negative connotations that we convey by using inappropriate terminology. We've said a lot about low-volume roads in terms of their importance. I won't repeat it, other than to say that in most countries, they serve a large part of the rural population, where they work and live, and that's where their livelihoods depend on the provision of reliable, all-weather, basic access. That's what we're looking for. And in the process of doing that, we're trying to use our natural gravels to the maximum extent possible before we consider more expensive options of stabilization and recycling and full depth reclamation. These are typical situations we face in many Southern African countries and in Asia. And I suspect that PMGSY has moved on from that because the first generation PMGSY roads have been exceedingly successful and they've overcome these conditions. But many other countries are still at that PMGSY 1 stage. What are the characteristics? Well, I won't spend too much time on them, other than to say, the last schematic, the bottom right, if we agree that we have to maximize utilization of our natural gravels, it's not appropriate. We have now learned in the last 20 or 30 years from research evidence that many of these standards are no longer appropriate for use in low-volume roads. And that has been proven from the back analysis and monitoring of numerous sections in a number of countries. Just very briefly, one or two differences in terms of how we approach our low-volume roads versus our high-volume roads. As I mentioned, our low-volume roads, the environment dominates pavement deterioration. Whereas on our high volumes, it's traffic. We're using stabilized materials or crushed materials that are moisture insensitive. With low volume roads, we're designing for much lower speeds than high volume roads, a different approach. Our focus on low volume roads is providing access, not mobility, and there's a significant difference there. And in the process of providing these roads, we are relying on local consultants and local contractors rather than highly experienced, in some cases, foreign consultants. So there are many differences in approach. We tend to use a lot of hot mix asphalt on high volume roads. Take Australia as an example, a country with a very modern network. 90% of the road network in Australia and New Zealand, the surfacing is a chip seal. It is not asphaltic concrete. So for every 1 kilometer of AC that's used, we can provide 2 or 3 kilometers of a properly designed chip seal. We should bear that in mind. The design philosophy simply means thinking outside of the traditional box, looking at the environment that we have to deal with, and trying to address it with appropriate solutions, horses for courses. The engineer obviously must be intimately familiar with various road environmental factors, such as the climate, type of subgrade we have, the terrain, etc., etc. So every single project is context sensitive. There is no room for blanket solutions. We must make sure that along our road, we design in relation to the dictates of the environment, and even along that, blanket solutions are not appropriate. And as Phil Page-Green mentioned, we have to make sure that we can do appropriate surveys to determine uniform sections, each of them attracting a particular design solution. What do we mean by environmentally optimized design? It's a nice term to use. Our aim is to ensure that each section of the road is provided with the most suitable pavement for the specific circumstances prevailing along that road. So it's not a blanket solution. In some cases where we have a steep environment, we may require concrete strip roads. But where the terrain is fairly flat, we could get by with a gravel road possibly, or in some cases, an appropriate surface treatment. We've learned many lessons from research that may surprise some of you. From something like over 70 sections that were back analyzed, most pavement failures are caused by the surfacing and are non-structural if they're reasonably well designed and constructed. There's almost no correlation between the measured CBR and soil indicator properties such as PI and grading. How often do we slavishly try to adhere to a CBR requirement, a PI, and a grading? There's no correlation there. A wide range of particle distributions outside the normal envelope have been successful. Drainage is the most important factor. By way of information, we've done a lot of work in terms of tracking the moisture content in our low-volume road pavements to see how they vary over time and season. And what we found, and that corroborates research work in the region, is that our moisture conditions tend to equilibrate after the pavement is designed and it's got a reasonable embankment height, it tends to equilibrate at or about OMC. It is not soaked. So our design can be based on OMC conditions rather than soak conditions, thereby expanding the window of using our natural gravels. An important lesson learned from research carried out in America, that the DN value from the DCP method is highly correlated to the fundamental shear strength parameter that you would normally measure with the repeated load triaxial test, which would be obviously too expensive to do on a low volume road. It correlates very strongly. So the DN value is a very good proxy for in situ shear strength, which is not the case with the CBR approach. What are the new approaches? Briefly, geometric design. I'm looking at the lowest spectrum of our low volume roads. Fit for purpose alignments that are not necessarily engineered. Because of those low levels of traffic, if we were to undertake a conventional engineered design, we would be involved in unnecessary earthworks that cannot be justified in relation to the benefits from a very low traffic base. And that means that the existing alignment fixes the travel speed that may be variable. This is a typical road in another Southern African country, which is not engineered, but it's fit for purpose, and where there are potentially problematic road safety issues, they can be addressed in terms of rumble strips and marking and the likes. Pavement cross-section is essential that we seal our shoulders. It's not a luxury of force of habit, looking at inadequate specs and lack of innovation that have suppressed the more widespread use of these materials. The materials evaluation framework is a very simple one. It goes through a three-stage process, and the objective is to end up with a very good appreciation of how your material strength in DN terms, which is a good proxy for shear strength, how that varies with moisture and density. And it's done in the laboratory, and it forces the engineer to think carefully in terms of how he can use these materials. It shows quite clearly the importance of maximizing your density and trying to keep your pavements as dry as possible, and the implications of not doing so. Surfacings, we said so much about surfacings, and there's so much we can do to ensure that we use cost-effective surfacings, whether they be chip seals with a life of 8, 10, 12 years, or if the aggregate strength is inadequate, we can use an otter seal that tolerates lower strengths without loss of performance. On many roads through villages, a double sand seal is very adequate for keeping the dust down. So we do have many choices. Cold-mixed asphalt is increasingly popular in many Southern African countries because it's very materials friendly, it's very equipment friendly, and it's very labor friendly. Very, very attractive option. Compaction to refusal, don't use Proctor, use modified AASHTO, and compact to refusal. Don't stop at 95 or 98%. Compact to the maximum extent possible without material degradation, because it increases the stiffness of your subgrade, reduces the thicknesses of your overlying pavement layers. Drainage, critical parameter, ensure that whenever you're designing your roads, you maintain a certain minimum height, whereby the so-called H-min, which is the difference between the invert of the drain and the crown of the road, is at least 0.75 meters on flat ground and a bit less on gradients. And that will ensure that your pavement layers equilibrate below optimum moisture content, so your designs are not soaked based on the soak condition. We haven't spoken much about unpaved roads, but the traditional approach has been to use motor graders in small local authorities. And within the space of 2 or 3 years, these motor graders have broken down and they can't be used again. Towed graders are an alternative, a proven alternative. They cost a quarter as much, they use tractor technology, and they're eminently suitable for grading our unpaved roads. Examples of using very simplistic methods, a bush drag and a tire drag for blading our gravel roads. Design risks, we must appreciate them: material quality, drainage, construction control, maintenance, and surfacing. And we haven't spoken much about overloading on our low volume roads. What are we doing about that? That is another challenge that we should be thinking about, and there's been no mention about controlling overloading on our roads. I put this up for good reason. And this is what triggered our consideration of looking at alternative design methods. At the bottom of that slide, below the black line, it's a traditional design road using typical specifications which require a soak CBR of 80, a PI less than 6, etc., etc. So the contractor had to haul materials to comply with these stringent requirements. They ran out of money, and the rest of the road was constructed by compacting the refusal using a laterite with a soak CBR of 35. After 25 years, that section of road in the same environment is in identical condition, dramatically showing the difference in cost by applying innovative technology, utilizing our gravels as much as possible. So, in summary, with another 60 seconds, moderator, there's an urgent need to improve rural access in many Asian and African countries. Attainment of this goal through application of traditional methods would be prohibitively expensive. There's now a wealth of invaluable research information that has provided practitioners with a much better understanding of the performance mechanisms of these low-volume roads. Flexibility in geometric design, low-cost improvements to drainage, adoption of an appropriate road cross-section, etc., sealing of shoulders, can make all the difference. The message is clear. The engineer needs to be more flexible in his or her approach to providing low-volume roads based on the outcome of valuable investigations and research undertaken in several Asian and African countries. Thank you very much.
Thank you, sir. I now request Dr. Ishwarandu Vidyamoto to kindly give his presentation. He has 10 minutes. He's on VC, I believe. Please connect.
Thank you. I'll try to share my screen.
Sir, we are a bit running late, so I will request you to kindly.
Yes, thank you. I hope everybody can see the screen in front of you. Thank you for the opportunity. Today, I would like to share a little bit about our experience in the UK in promoting sustainable and climate resilient road for rural roads. Just a small introduction about the works that we do. Our team has been working on introducing innovation through research and application for roads and bridges, and also for our military infrastructure. But for today, what I would like to do is to share with you a little bit more about the climate resilience and innovation in materials for roads, a little bit on the low energy construction, and then promoting sustainability by using high recycled content, and then just a few case studies. In the UK, rural road has been classified as both major and minor roads, which are located outside the urban area, typically having population of less than 10,000. So in this context, we need to cover roads which cater high traffic and roads which almost no traffic at all. So quite a vast range of traffic and loading condition for these roads. However, when we look at the proportion, most of the rural roads, they are on a small and unclassified roads, meaning they are roads which will carry a small amount of traffic. Just to give you an overview of how they look like with respect to rural roads in the UK. As you can see roads with a lot of traffic, dual carriageway or single carriageway, or very narrow country lane roads. In this context, we need to consider about the design. The design would be very different between different types of roads. We hear about the previous presenter imposing the importance of drainage. So drainage is one key element for design, and whether the road would be sealed or unsealed, that's another thing that needs to be considered in order to be able to design roads which can last long and can cater the amount of traffic and climatic conditions. So what I would like to share with you today is a little bit more about the move towards designing to be ready to cater climate resilience and sustainability on road design. These are the outcome from the recent survey on local authority roads, whereby it has been found during the last few years, in the last survey, 2021, that there has been an increase in adverse weather. Our weather is getting more hot, but getting hotter and wetter. It's more rain, and also our winter also getting colder. And the impacts from this change in weather is that there has been more damages in the road network. And the overall condition of the roads, if you look at the chart at the bottom, on the principal road, whereby the road would be well bound by either asphalt or concrete, the damage is quite small in comparison to non-principal and unclassified roads, whereby the roads tends to be largely unbound layers covered by thin bound layers or surface sealant. And there is a massive increase in claim by the public with respect to damages to their cars and to their comfort due to potholes related issue. Hence, local authorities in England and Wales recently they declare that they need to address this climate emergency in their design and maintenance of their road assets. So what they came up with, they introduced a number of innovation and shortlisted where they want to focus their effort to. One is on the use of warm mix asphalt and increase the recycled content, and using materials which can offer lower carbon footprint. So that's kind of design will help in preserving our environment and promote sustainability. And also design need to produce material which will last longer. So combination between sustainable design, green materials to be used, and as well as longer life materials. So the first approach to consider is on the low energy construction. I think most of us would already have heard about this kind of techniques. There are a number of techniques to reduce emission and energy during production of asphalt materials, for example. And we are familiar with the term hot mix asphalt, HMA, and there has been a lot of introduction and use of warm mix asphalt in our network as well. This warm mix asphalt allows the material to be produced and installed at much lower temperature than hot mix asphalt. And there is another system which is can offer much lower temperatures, like a half warm asphalt, or to the extreme of cold mix asphalt. These materials gain a lot of momentum nowadays, simply because there are many benefits that can be expected from this material. From the environment benefits, less energy to be used, less fuel to be required to heat up the materials and carry out the installation, and also safety for the worker, because there will be less emission of fumes that might compromise the health of the workers, as well as reducing the odor, the smell from asphalt. So I would like to talk a little bit about these materials in the next slides. In a broader term, there are two systems whereby we can produce warm mix asphalt. One is using the additive system, whereby we can use a specialist bitumen, or we can use chemical or organic additives, such as specialist wax to promote viscosity at lower temperature. Or we can use a foaming process, whereby we can use either foaming bars. So it's almost like producing foam mix asphalt, whereby you inject hot bitumen to meet the cold water, and the bitumen creates foam which will cover the materials. Or we use additive which can release moisture during the process of mixing. So these two quite extreme process completely different process between additive system and foaming system. However, the similarity between those two are they can reduce the temperature during production and installation. How about their performance? Their performance largely very positive. This just to give you a snapshot of their performance against how easy they are to be installed and compacted, resistant to moisture, resilient modulus or stiffness, resistant to deformation, and resistant to cracking or fatigue. As you can see there, the one in green means that the performance of this warm mix asphalt is better than hot mix asphalt control of similar material. When it shows a gray, meaning that they are quite comparable. When it shows as red or yellow or orange rather, which means their performance is lower. As you can see there, in general, depending upon which property that we would like to use in our design, the warm mix asphalt can offer a similar or better performance than the hot mix equivalent. You can have a look at the case studies and references in the paper associated with this presentation. In the UK, warm mix asphalt has been adopted as the preferred materials for use in our network. And there's a specification that is available in the UK, whereby we can produce asphalt concrete, we can produce stone mastic asphalt, or we can produce a high modulus asphalt using a warm mix asphalt techniques. And this is clause 908, which specify the requirement for the mix design, requirement for installation, and requirements for the finished products after the construction is complete. You can have a look in more details about the specification from the link that I present in this slide. What I would like to highlight from the benefits from using of warm mix asphalt here is that you can actually significantly reduce the emission on the greenhouse gas. So the CO2 emission can be much reduced if we use, for example, if we compare the use of hot mix asphalts, replace it by warm mix asphalt techniques of the same material, we can expect up to 17% reduction in emission. But if we replace that material with a better performing asphalt concrete like EME2 high modulus base material with warm mix asphalt technologies, then we can expect a substantial reduction up to 30% of emission. This is from some case studies that AECOM had carried out in one of our work. So there's massive benefits on emission. How about promoting sustainability by using higher recycled content? I think we are familiar with this context. And during my previous visits in India as well, we have seen a lot of initiatives under PMGSY, which I found very, very good and very positive in promoting the use of recycled material. What I would like to show here is we can consider the use of these recycled materials into 4 different categories. Whether we will use it as a binder modifier, we have been using crumb rubber, for example, or waste plastic or waste cooking oil, as binder modifier, or as a mixture additives, or as aggregate replacement. So we can actually use aggregates from the existing infrastructure which already reached the design life back into use as aggregate, or we can process it as artificial aggregate. But I'm not going to talk more on the technical matters. You can download some papers from this link related to some of this application. What I would like to focus a little bit more is about managing the process. If we are going to use waste-derived materials or reclaimed materials in our design, what needs to be considered? Waste materials is associated with increased risk. Usually that is what is in our mind, because being a waste materials, we don't know about the consistency of the quality. and we need to establish the track records, and we need to establish the durability of the materials. And when it comes to risk, then there is a need to have a conversation between parties, between the materials producer and the clients, and to understand about the liability and the ownership of this risk. And then we need to also refer to the environmental regulation. What would be the permitting requirement? What would be the licensing requirement when it comes to using non-standard material, like the use of waste-derived materials? And there's a lot of process that needs to be considered, from the materials elements to the regulation. So there are some reference here that can be have a look. You can look at your leisure after this event. And then I just give you a little bit on case studies. So hopefully I can do that within 3 minutes remaining from my session. So the first one is the use of reclaimed tire rubber, and in combination with reclaimed asphalt in the warm mix asphalt process. On a number of projects, large projects or local authority projects, these have been used quite successfully. A lot of tires has been saved from going to the landfill, being reintroduced back to the mix design, and also a lot of proportion of reclaimed asphalt can be incorporated back into the design, both on the small roads, on the local authority roads, on the 3 scheme that I present here, as well as the works on the major highways. So between the two, actually we can see that the materials which contain reclaimed material can actually provide a similar and comparable performance in terms of compaction level, durability, stiffness, and rotting resistance. And the other one is retread. We might have already heard about these techniques, which already in existence since 1948. It's a very old techniques, still being used in rural roads, low volume roads, and also on pedestrian sidewalks, whereby we can recycle the existing pavement and produce a brand new surface with improved properties. This is the process. It's quite simple. So basically, if an asset has experienced some damages, rotting, or cracks, we can scarify it, and then we can grade the materials using a simple process and apply emulsion. Chipping is added, and then compact together. Then another application of emulsion will be added with smaller chipping to produce textures. So it's quite a simple process, and this has been found to be cost effective for very small roads and for pedestrian pathways. And the next 2 slides is about the most recent publication from British Standard in relation to in situ and ex situ recycling. The first one is PS 9227. And this provide some guidance on the requirement for production and installation of hydraulically bound materials, whereby we want to do recycling method using hydraulic binder. It's quite detailed document. It's quite a thick document. It is worth to look at if you are considering designing recycling using hydraulically bound materials. This includes roller compacted concrete, hydraulically bound granular material, and stabilized soil. And there are some reports that produced by AECOM as well, with a study on roller compacted concrete, and a few reports from BritPave, whereby you can download from their site. Very good documents to refer to. Last but not least is the in situ and ex situ recycling by using bituminous binders. This is a very recent publication, only last year, PS 9228. In this document, you can find guidance on the use of bitumen emulsion, foam bitumen, and any use of hydraulic binder in the process, but not as much as the other one that I presented earlier. It provides you with descriptions about production and installation requirement. And also, there is a document that is worth looking at, a paper by Tom and Dawson, which provide comparison between a plant mix and in situ recycled materials, how they compare with respect to their properties, stiffness modulus, and so on. And I think that's the end of my presentation today. I hope that can be useful to everyone, and thank you for the opportunity. If there's any question, happy to have a discussion later on, or feel free to send me email at this address. Thank you.
Thank you, sir. I will now request Mr. Scott Bloxham to kindly make his presentation.
Okay.
Sir, you have 15 minutes.
Okay. Good afternoon, everybody. How are you this afternoon? Good. Still awake? For those of you with the original schedule, you may notice a reordering from my colleague Dr. Greenwood and myself. We only felt it right to restore the natural order of things, with Australia going first and New Zealand going second. So thank you. I was also going to start with a joke, but I'm going to leave that for my colleague. In all seriousness, I would like to thank you for the opportunity to join you this week in New Delhi. I've been very impressed by the level of technical and technology information that's been shared throughout these last 2 days. However, having said that, my presentation has very little technical and technology information for you to relate. It's very much about the process. However, what I would like to speak with you about this afternoon is some asset management principles and some examples from some of our experience and experience of many others in different parts of the world, including, for example, Costa Rica, Uganda, the Middle East, England, other countries through the UK, and of course Australia. I wanted to share a general discussion with you and some learnings around implementing good asset management practices for your network, regardless of national, state or local. We're going to cover the importance of establishing asset management frameworks and putting in place the right level of governance to guide your practice, looking at strategic and tactical asset management, the importance of data and how we use good data, and turning that data into information and ultimately decisions that translate to work on the ground. But let me start with a definition. The international standard ISO 55000 series has a definition of asset management, and that is the coordinated activity of an organisation to realise value from its assets. The coordinated activity to realise value from its assets. So it's not about the road or the bridge actually performing, it's about the value that it provides. Of course that's important, that it provides the functionality, but it's about the value that it brings to the organisation and to the wider community. I've listened to some impressive discussions and presentations around the PMGSY program, a number of other initiatives, and it's quite demonstrable the level of value that road assets bring. Okay? Other definitions, Asset Management Council talks about the life cycle management of physical assets to achieve the stated outputs of the enterprise. The IIMM talks about the combination of management, financial, economic, engineering and other practices applied to physical assets with the objective of providing the required level of service in the most cost-effective manner. The structure of ISO 55000 refers to understanding the context of the organisation. These principles can be applied regardless of the complexity, the size and the nature of your road asset. It talks about understanding the context of your organisation. What are the legislative requirements? What are some of the other influencing factors, codes of practice, guidelines, standard specifications, for example. It also highlights the importance of leadership, and I'm going to note a couple of examples of that throughout my presentation today. And then, of course, it refers to the plan, do, check and act cycle. We're all more familiar with that plan, do, check, act cycle, right? And the standard of the asset management standard refers to that repeatedly throughout its publication. That particular structure in your organisation for your road network, shall we? Establishing and building on some of the learnings this afternoon from my esteemed colleagues, We talked about asset management framework, and Rob provided some strong structure and the importance of structure and governance about asset management for road networks. So a definition around asset management frameworks, it includes all asset management activities normally undertaken by an authority and is flexible to accommodate the requirements of individual authorities. So again, it accommodates that flexibility. It comprises the activities and processes that are necessary to develop, document, implement and continually improve road asset management. These activities and their approach to their delivery should be clearly documented and accessible to relevant stakeholders. So it's essentially knowing what you need to do as an authority to manage those assets, understanding the outputs and the value that it needs to provide. So some example steps involved in implementing good asset management. It's across all levels of the organisation. Understand your organisational context, the context within which you have to operate. What are the limitations? You have funding constraints, you have environmental challenges, you have customer demands, you have stakeholder issues, challenges, as we all do. It's important to understand and scan and identify what some of those key restraints are. The follow-on from that is to carry out some form of asset management maturity. And that's important for two things. It provides you with an ability to identify where some of the key gaps are. What are you doing well? What can you be doing better? It also feeds into enabling you as an organisation to prioritise your activities. We can't do everything at once. How do we improve over time? And establishing a baseline is very important. It's also important to engage with key stakeholders and senior management for commitment to embedding a strong asset management culture. At an operational level, we can be delivering excellent services, we can provide great engineering decisions at an operational level. If we haven't built in that level of leadership and sponsorship, it's very difficult to maximise the benefits from that process. Develop some strategic policy. Develop some clear guidelines and strategy around how you plan to manage your network over a longer term. It starts setting the long-term picture for what you need your road network to achieve. It's very important to paint that vision of what the future looks like. Equally important is to know where you are now. And we do that through establishing existing levels of asset information. What do you have? Where is it? What sort of condition is it in? How do you store that information? What skills and competencies do you have as an organisation? What skills and competencies does your supply chain, does your market have? Very important to understand where you are. And of course, the planning process is vital. To be able to move forward and to be able to set out priorities and to implement change, we need to have key plans. We need to have relevant plans. The last point about whole-of-life approach for your main asset types, again, I've seen reinforced through the last day and 3 quarters. A lot of discussion about design components, construction techniques and maintenance techniques, and they all refer to the importance of whole-of-life. Too often, I think we've all seen examples where the importance is placed too much on design and construction and not enough consideration for maintaining and operating our network. We also need to plan to ensure stakeholders are engaged. Communication is very important if we're going to work in a different way. If we're adopting more of a preventive maintenance, for example, as our esteemed professor spoke about earlier, performance-based contracting as a delivery mechanism, we work in a different way. So it's important that we engage with our key stakeholders, and some of those may be our customers, some of those may be our consulting organisations, some of those may be our neighbours, our neighbouring road authorities. It's very important that we plan to do that. Practice, strategy and planning, asset management policies, 3 asset management planning process, very much in his discussion, and provide you with some more detailed guidance. It's important to know what you've got. It's also important to know what the future holds for your road network. How are we going to use that network? Those are key objectives of life cycle planning process. However, for today's discussion, I would just like to leave that with you. Thank you. Managing the life cycle. Typical deterioration curve, let's use a pavement for example. Important to highlight in this curve, the red represents a deterioration of pavement performance over time, let's say over 20-year life. For the first 15, 16 years, you can see it deteriorates by 40% drop in quality, but that's over 3/4 of its life. Once it commences that deterioration, there's a rapid fall-off. Our job as asset managers and road network managers is to intervene at the right time. Understand when you need to intervene and what you need to do when you need to do it. Because every dollar invested in preservation here saves 6 to 10 there. We've also talked briefly yesterday about the advantages of a road asset management system, and of course it's vital to help us make decisions, and that contains and maintains all relevant road asset data, including inventory, location. Our GIS systems are so much better today than they were even 5 years ago. How can we identify where things are and what they look like? And condition and performance are very, very important parts of that. But also a good asset management information system allows us to predict performance. It allows us to look ahead and make predictions. Some examples of road asset management information system that we work with. Again, you can see the GIS references. Another example of a system from a different part of the world, same challenges, different road network, but same challenges from an asset management system. Translating outputs from asset management information system into maintenance planning is essential. How do we take that information and plan our maintenance to the most part? The balance between planned maintenance and reactive maintenance needs to shift much more heavily towards the planned maintenance component. That's where we get efficiencies. That's where you can start to maximise the value from the performance of your road network. Just want to leave you with a couple of slides and then I'll resume my seat. Determining and implementing your organisation's asset management system and asset management practices. A couple of key points. Speed is important and achievement of plans is important, but progress is vital. The effort, the energy, the time, the cost to implement good asset management practice, it's fundamental to keep moving that forward incrementally. It doesn't just change, it needs work and it needs constant attention. Effective use of asset data and information. What do we collect? How often do we collect it? How do we collect it? When do we collect it? Why do we collect it? What do we do with it? Refer to Mike's presentation before. It's about fit for purpose. We don't go and collect ground penetrating radar in some areas where the volumes of traffic are very, very low or the level of risk is also low. So it's about fit for purpose. It's very, very important. And how do we use that data to make decisions? And how does that affect the overall performance of the network? Asset management systems are important, but embedded in those systems needs to be process. Okay? The software won't provide you with the answers. It will help you, but the important aspect to consider is the process. What process do you go through as asset managers? What's key? Legislation and policy is vital to support good asset management. And that's something that's really important to understand through governments, divisions and sectors and ministries. And I think the last slide for you today, a couple of other key learnings. Link your asset management plans to organisational objectives. Demonstrate the fact that you're managing a road network to achieve the outcome of your organisation. You don't just manage it because the surface of the road needs to be a certain level of condition or a particular function. Develop plans for implementation. Don't develop plans just to develop plans. A plan is ineffective if it's not implemented. Okay? Don't go to the bother of planning if you don't do. Remember that? Plan, do, check, act cycle. Measure performance. Last two dot points. Not just on the asset, and we've talked a lot about asset performance. We've talked a lot about measurement of IRIs and rutting, and again, very, very important. But it's not the only thing to measure. It's important that we measure our asset management practices. How effective are your asset management strategies? How effective are your works program and delivery? How effective are your maintenance treatment strategies? And the last point, I hope it's the last point, communication and engagement. It's really, really important, especially in a political environment. It is important to understand what the asset needs. And it's important to understand what the level of funding and investment is required to achieve a level of service. And you cannot do that effectively without those planning and data and information processes that we've talked about before. It's also about providing solutions and options. It's not just one thing. It might be, if we do this, then this is what's going to happen. As a proactive and a good asset managers, we seek different scenarios. We look at options. That is my last slide. Thank you very much for your attention. I have put questions, but I believe, Mr. Chairman, they will be maybe taken at the end of the session, perhaps. Thank you.
Thank you. I'll now invite Dr. Greenwood to make his presentation, please. He has 15 minutes.
Okay, so I'm Ian Greenwood from New Zealand. It's great to be back here again. I've been coming to India now for 15 years. Started up in Punjab when they did the very first OPRC contract, or performance-based contract, for the World Bank 15 years ago. Since then, through Assam, Bihar, Madhya Pradesh, Rajasthan, Kerala, I think those are the main ones. So I've had a good chance to travel many thousands of kilometres of your rural roads, those in your PMGSY programs, those outside of it, met with many road authorities, worked with the Indian Road Congress, and indeed met with MORD and Morth representatives. I wouldn't say I know India like the back of my hand. I do know I enjoy a lot of your good food, so thank you for all your hospitality that I've always enjoyed. I'd like to start by saying that there is a need to focus a lot more on what you're trying to achieve with these roads, and it's a theme that's been mentioned earlier. If you want to cross a river, you can start, such as up on the top right-hand side there, put some rocks in the river and walk across it, and you accept that when it rains, there's a bit of flooding, you can't cross. If you've got one wire rope, you can drag yourself across with your bike. A few more wire ropes and some planks, you can walk across it, or there is the grandiose version down the bottom left-hand side. Good asset management does not mean every single bridge ends up looking like the one at the bottom left-hand side. And neither should you be looking at that for your road network. And it's a little bit concerning at times when, throughout the past couple of days, the term rural road has been adopted to be rural highway. That's not what you're trying to do. You're not trying to turn every single road into a highway. And that's been a key learning all around the place. And the same applies for our RAM approach. So the way you manage a national highway is fundamentally different to the way you manage a rural road. The effort you put in, the level of data you're working with, should all reflect that. So asset management, as Scott's just said, and it always hurts me to admit that an Australian's right. I think he's been around me long enough that something's rubbed off there. Out of interest, you can always take an Australian somewhere twice. The second time is just to apologise for the first. Anyway, with the asset management, it's always about having that full process. And the process doesn't change regardless of what you're managing. So the one on the top left there is from the Institute of Asset Management out of the UK. The one on the bottom is out of the International Infrastructure Management Manual. Those processes hold true whether you've got a high volume network, a low volume network, whether you're managing roads or hospitals or schools or anything else. What changes is the effort you put in and the detail into the different stages. So you can't read it there, but one of them is asset condition. On a high volume national highway, you're going to be using your laser profilometers and your high-speed vehicles to get that detailed data. When you get to your low volume roads, you might be using a simple, is it good, fair, poor visual assessment. And so it's not saying the process changes. Think about it, what detail do I put into each step? Also, we need to actually appreciate how you're currently looking after your network. So if we look at it from a journey type approach, most people start off doing maintenance management. So that's, you have a list of all the faults on your road network. And if you talk about budgets, it's always, well, this is what I got last year, so I wouldn't mind a little bit more than that, or I might accept a little bit less. And then you do as much of that list as you possibly can until you run out of money, and performance is what you get from it. And that's akin to going and hopping in your car and going for a drive. You don't check the fuel, you don't check the car, and when the vehicle runs out of fuel, you have to accept where you are, and you may or may not like that journey or that destination. Asset management is the complete opposite. Asset management starts with a plan. You're setting out, you know where you want to go. You service your car, you put the fuel in it, you've got the hotel booked, and you go through and you go on that journey, and at the end you review and say, did I get to where I wanted to go? And if I didn't, why not? And you learn and you learn. And so one is a very proactive approach to saying, where do I want to get and how do I get there? The maintenance management is purely, I am a victim of not having enough budget. If you gave me more money, I would do more work. At no point are you asking, am I doing something of good value? Asset management systems, information systems, that's not the same as asset management. Never has been, never will be. You'll need a system, but that's about it. Some of the common mistakes we see, the comments of, first, before I can do asset management, I have to get a system and I have to collect data. That's not true. You start doing asset management to find out what data and systems you need. Or we've got a system, so I'm doing asset management. And as I just said, that's not the case. You also get some people collect data without any thought how it would be used. So I've seen one where they said, well, we've got so many poor bridges. And I said, well, what is a poor bridge? Is that it's got poor foundations and the whole bridge needs replacing? Is it poor bridge deck, so you just need a new bridge deck? Or is it just poor handrails? Fundamentally different solutions. So you need to think, how are you going to use this information? Or people do a one-off, I've collected some data, I've put it in a system, but there's no funding to actually keep that going on a sustainable basis. And often that's because it's never become part of your business process. So you've got a system, you've collected data, but over here you're still making decisions the way you're always used to. And that never actually ends up in a good position. Another problem we see is sometimes RAM is just addressed like a project. So you say, last year I built a bridge, this year I'm doing asset management, next year I'm going to widen a road, rather than treating asset management as a new way of life. So as we said, you start with the maturity assessment and you set goals to improve. And you have to decide how far and how fast and where do you improve, and making sure you do that continual improvement approach. Also, just briefly touch on this just because it's been raised a number of times. Asset management includes climate change, addressing climate change and climate resilience. That's actually in part of it. In the same way that asset management includes dealing with traffic growth. You have to deal with the assets in the environment they're in. So you can't say, I've done asset management, but separately I've still got to deal with the climate. What sort of world is your assets sitting in? There's some documents there. I was fortunate to be one of the key authors of both of those. But these systems documents or guidance teach you how to do asset management, including your climate change, how to actually deal with geohazard risks and climate risks from a high-level policy and legislative approach right the way through to identifying the hazards, on through to maintenance and operational aspects. So they're all there, free to access off the World Bank. Now this is where I really want to get to in the last couple of minutes. In 2017 or 2015, sort of 2017, Ashok and Renu in the World Bank got myself and a couple of others to produce an asset management framework for the Indian Rural Road Network. And we worked with the Indian Road Congress to actually work this through. This is there. And I guess the difference between what you'll see in many international guidance documents, if you pick them up, you might say, well, how does that relate to us? So when we wrote this document, it was written around the situation you're facing as rural road network managers. So, for instance, the abundance of investment in new build. The fact that you've got this huge network of rural roads, but it's changed fundamentally over the last 20 years. Many of you went from a predominantly unpaved road network to now a paved road network. And you've got this huge quantity of roads which have been built and which are about to come, if they haven't already started to become, due for rehabilitation. So when we wrote this framework, it was written from the ground up around the way that you actually need to do your asset management here in India. So it was written by a couple of us who actually were the authors of the International Infrastructure Management Manual. As I said, we wrote it in conjunction with the Indian Road Congress. So it deals specifically with things like where does the PMGSY program fit in, what are your financial rules, and then we piloted it in Assam and Bihar to actually make sure it worked. There's a few key principles underlying it, nice and small wording there. It's more the fact that these are similar to what the sort of words that Scott just put up. So, we're going to have transparent, evidence-based decisions. We're going to look after what we've got before we start building more. When you look after what you've got, that's normally got an economic return somewhere around about 10 to 20 times higher than building something new. You cannot do anything more valuable than look after what you have. So, but these are just the principles that this framework's all about and is based on. So what's involved with it? There's a guidance document saying this is how you do it. There's also a template for producing an asset management plan. So it's already got the tables in there, it's got all the headings and it's ready to go. There's an Excel template to actually populate some data to produce the charts that go into the asset management plan. A bit of a competency assessment. It's not to the level that we probably work to nowadays. But there's also examples that we've actually worked through all of this. In terms of things like the asset management plan, it actually sets it up in that natural hierarchy between your Government of India 5-year plans down into your state 5-year plans, and actually fills that gap between what are you trying to achieve at a state level and what are your annual work programs, and it actually aims for that market. So that's what I mean, it's been designed around the way that things here in India actually occur. In terms of making some progress for asset management here in India, you need, and this is based on international experience, you need both a push and a pull. You can't do it just by saying, I want to do it. It won't actually ever really stick. So one of our recommendations at the time, and it's still sound by now, is the Finance Commission should really be auditing how good you are at asset management. And that should be part of their process. On the pull side, asset management, doing a basic level of asset management should actually be a prerequisite to obtaining funding. Why should anyone be pushing money into someone who hasn't got any commitment to looking after it? And that really should go as far as the funding from the World Bank, the Asian Development Bank, and all the others. So things like a simple one would be that MORD would require an asset management plan to be produced every 2 years to access PMGSY funding or similar. Submit the valuation, show that you're actually looking after it. Some of you might be surprised to know that I think it was 5 years ago, we did the numbers for India. You spent billions of dollars on your road network, and at the end of the year you were worse off. The amount of money that had fallen away because you hadn't looked after your assets was greater than all the billions of dollars you put in at the top of the bucket. You are going backwards, and that's before the big wave of roads that come through from PMGSY are going to have to be renewed. You need to start looking after what you've been built. And having that 10-year plan, looking at you and saying, we know what's coming and we've got a plan to fund it. Because at the moment, you have a very high risk that, give 10 or 20 years, you've built these huge liabilities and you may not be actually able to look after them. So the first steps, conduct that maturity assessment. Prepare the asset management plan with the information you've got. Don't go on a big data collection new exercise. Say, what is it we've got? And that will then let you actually start to say, well, what do we need? What decisions do we want to make? And that will all help guide you for the future iterations. Document your current processes and practices. Once you've documented them, you can see where the gaps are. You can actually understand how you need to make progress and where you need to make improvements. And most of all, have a sustainable data collection plan and a sustainable asset management information system. So start simple. It's easy in 5 or 10 years from now to add complexity, to collect more data or at a more detailed level. It's much harder to start with a very complex system, not be able to afford the data, and then the whole process falls over. So I think I've got about 2 seconds to go before we'll get buzzed again. So that's me. Thank you.
Thank you, sir. We are running late, so if you have any questions, kindly give the cheats to the organizers. They will be answered in due course of time through email. I'll request Dr. Gupta to sum up and then close.
Hello. Yeah. So, thank you, Chairman, sir. So overall, we had 6 presentations. The area we covered was the asset management. So first, Rob discussed about the rod preservation pyramid. So that was the highlight. Professor Veera Raghavan already discussed many things, highlighted the importance of the data collection and posed many billion-dollar questions, his trademark in his presentation. So probably those are some of the questions, if you'll think about, probably we can go ahead in the road asset management side. Then the Mike discussed about the various international best practices, especially in the low volume roads, discussed about the differences between the LVR, HVR, access mobility, and the environmental and the traffic issues. Then the Ian discussed about the journey of the asset management. That was the last presentation. Scott again discussed about the ISO certification like 55001, defining and understanding the asset management. And the one VC was with Iswandaru, and he discussed the ways to promote the sustainable and the climate resilient materials for the rural roads, and discussed some 3 case studies with the WMA and the in-situ recycling. So these were just a brief idea about the 6 presentations. Yeah, so over to Chairman, sir.
Thank you. Thank you very much. Thank you, everybody.
Okay, thank you, Chairman, sir. So, few of us is holding the fort. So thank you so much, audience. You've been listening, you've been a very patient listener. And this session has gone very well. And actually, the rapporteur has already summarized the thing. But since it's an interest, this topic is an interest to me because I am heading a team in the NRID on the asset management. So I just want to say some few words because the speakers would be very happy to know that whatever asset management they have said and whatever you explained it, as we in India makes everything simplified and we execute it in a very simplest manner that it gets into the masses. And whatever you told, the financial planning, the asset management planning, the repairs planning, everything, and the evidence-based, as Professor Veera Raghavan has mentioned, and I'm happy to note that you have seen the video also on the EMARC, and we have implemented it. As you mentioned, 5 years plan, India has done away with the 5 years plan, but in the PMGSY, we have the pre-5 year and the post-5 year. So as you know, in the pre-5 year, we have already implemented all the asset management plan and all the financials are known beforehand because it is given in the contract. And the post-5 year also, the way the speakers have mentioned, we have planned it and digital solution is being developed, and the post-5 year will also be implemented, which will have inbuilt pre-5 year DLP again. So that means that with the 5 years kind of managing the roads, and we have implemented it in our own way. And tomorrow, luckily, I have a technical session. I'll request speakers and audience to see that, to listen to that session, that how we implemented these ideas given by various organizations. Thank you so much, sir. I just intervened in this because it interests me, and last 3 years we have been working on asset management. Thank you so much, sir. Now I would like to honor our speakers, esteemed guests, with our token of appreciation. I'll request NRIDA team to come forward and give the mementos to all, yes, session chairman, all the speakers. Thank you so much. And then after this, we would be taking a small break of 15 minutes. And again, we'll come for a very good technical session of 4 lectures. 15 minutes. 15 minutes. Very quickly, we'll come back so that you can go to home quickly. And then I'll request all the audience, all the participants to come back and listen to what is remaining in today's discussion. And tomorrow it's a very, very interesting technical session, and probably we'll be starting little early, 9:30. 9:30 I'll request all the guests, all the participants to reach, because 9:30 tomorrow we'll start, so we can finish it off in time. Thank you so much. Please come back. And I'll ask you again, how is the Josh? How is the Josh?
India, with all her natural and populational diversities, has been witnessing a sea change in the lives of her people during recent times. New horizons of livelihood opportunities have enabled the larger mass residing outside of the urban periphery to join the mainstream socio-economic flow. Opportunities that have been generously provided by the new lifelines of India. An intricate network of modern, all-weather roads constructed under the Pradhan Mantri Gram Sadak Yojana. PMGSY, a flagship endeavor of the Ministry of Rural Development of India, is managed and technically supported by the National Rural Infrastructure Development Agency, an organization dedicated to building capacity and enhancing quality through training. The project was launched in the year 2000 by the Government of India to work jointly with the state governments in providing all-weather road connectivity to designated areas with population sizes of 500 plus in the plain areas and 250 plus in the northeastern and Himalayan regions. The initiative is a giant step towards realizing India's full human resource potential along a journey on these new lifelines connecting the remotest parts of the country to civil amenities like schools, hospitals and agricultural markets.
इस रोड के निर्माण होने से हमारे विद्यालय में एडमिशन में बहुत ही फर्क पड़ा है।
जब से ये रोड बन गई है हम लोग स्कूल टाइम पर पहुंचते हैं।
Since the launch of PMGSY 1 in 2000 till PMGSY 3 launched in 2019, rural infrastructure in India has been upgraded to unprecedented levels. Economic activities have increased considerably with the generation of employments in various forms, investments coming in and businesses growing in the rural sector, fueling the economy to reach new heights.
इस रोड के बनने से आज सभी यहाँ उचित विक्रेता अपने ट्रैक्टर से सामान ले जा करके अपने घरों तक आसानी से पहुँच रहे हैं।
In 2016, a special drive was undertaken for construction and upgradation of strategically important roads in the remotest locations inhabited primarily by India's indigenous people. More than 10,000 kilometers of road length has been sanctioned under this drive so far. Till the 31st of March 2022, a total length of around 7 lakh kilometers of all-weather road has been constructed, achieving the full target of the whole project. The total expenditure incurred is rupees 2.77 lakh crores. This phenomenal empowerment of rural India has attracted the attention of the world. The World Bank in its report on the impact evaluation of PMGSY states that the project has improved accessibility in hilly areas and increased access to economic opportunities.
जब से ये रोड बना है टूरिस्ट डायरेक्ट अपनी गाड़ियां लेके बिलिंग जाता है जब टूरिस्ट आता है तो हमारा बिजनेस जो है काफी जोरों से चलता है
The benefits of the resultant positive impact on human capital formation are being equally enjoyed by all sections of the population. The Niti Aayog has stated in one of its reports in 2020 that the scheme is well aligned with India's international objectives and is contributing immensely towards the nation's sustainable development goals. The selection of target areas for building and restoring roads has been done using the most scientific method by mapping the strategic points on the Geographic Information System or GIS. This mapping has ensured that the most eligible roads are included in the program to provide a boost to India's rural economy. The routine maintenance of PMGSY roads across the country has become more streamlined since 2020 after the introduction of eMARG. It is a GIS-based enterprise and an e-governance solution to aid and assist the officials and contractors in maintaining performance-based maintenance contracts (PBMC) of roads, assessing performances and making automated payments. Earlier, these records were kept manually and were often subjected to errors. eMARG has enabled evidence-based, error-free digital record keeping. The last couple of years have seen an expenditure of rupees 1,300 crores in road maintenance under eMARG. A user-friendly app, Meri Sadak, is helping citizens provide their feedback directly to the ministry. So far, about 1.5 lakh complaints have been lodged through the app, almost 99% of which have already been resolved. So far, around 70,000 kilometers of PMGSY roads have been constructed with non-conventional and new materials. Technologies like FDR using cement and commercial chemical stabilizers like Zydex, Terrazyme, ANT, Stable Road, RoadSem and many others have been used in the process. Other novel technologies like cell-filled concrete, paneled cement concrete, use of waste materials like slag, fly ash, waste plastic and cold mix technology have introduced locally available, low-cost and recycled materials to road construction. FDR, a full-depth reclamation, stands out among all of these as a new-age construction technology. It is primarily a road restoration technique. Full-depth reclamation of an existing pavement is a rehabilitation method that involves recycling of an existing distressed bituminous surface and its underlying layers into a new base layer. Apart from mending a damaged pavement structure, FDR can be adopted for upgradation and widening of existing roads without requiring any structural overlaying of base layers, while designing for the same or higher order of traffic category. The shortened construction schedules add to the cost effectiveness of the technology. Overall, FDR has great advantages in terms of saving time, energy, minimizing material consumption and cost reduction where pavement cost is high, transportation cost of aggregates is high and the quality of aggregate is not good. The cell-filled concrete technology developed by IIT Kharagpur in India itself has enabled PMGSY to build and restore roads at a minimum cost and a minimum effect on the environment. The use of cold mix technology has drastically reduced the emission of greenhouse gases, and the chances of workers meeting with accidents during construction too has been significantly minimized. The use of waste plastic results in less bitumen consumption and is beneficial to our environment as it recycles plastic waste. However, the introduction of these new and green technologies under PMGSY has led to a huge drop in carbon footprint and made the whole process of road construction faster and a lot more cost effective. With a view towards achieving an environmentally sustainable economy, PMGSY has envisaged a new technology vision. Now, a minimum 50% of the proposed roads will be constructed using these new and eco-friendly methods, and waste plastic will be used in constructing more than 70% of the total proposed road length. As for quality control, PMGSY envisages a 3-tier quality control mechanism in order to ensure the strength and durability of these new lifelines of India, while continuing on a journey of fulfilling everyone's dreams. Dreams that would no longer be deterred by difficult roads even in the remotest corners of the country. India today has also opened her arms towards the world for sharing these new and unique technologies that are being used for building rural roads and the invaluable experience gained in the process. Thanks to the Pradhan Mantri Gram Sadak Yojana. IIT Kharagpur, one of India's premium technology institutes, has come up with a novel technology that has rendered a new edge to the Pradhan Mantri Gram Sadak Yojana. Cell-filled concrete, as the technology is called, involves covering the compacted subgrade or subbase with a formwork of plastic cells made from waste plastic. The formwork ultimately gets filled with concrete or stone to act as the pavement. It is stretched and iron spikes are driven at the corners of the cells so that the frame remains stiff. Nylon ropes through the cell walls prevent the cells from collapsing while they are filled with concrete or stones. The cells are shredded out on the concrete base with the help of the frame. The coarse aggregate mixture obtained from the factory is carefully checked with sieves to confirm the right proportion of small and large stones. Then, with precise measurement of cement, coarse aggregate, fine aggregate, water and chemicals are mixed to make the concrete. Even with precise measurements, the concrete is tested thoroughly before being used for construction. Once the quality of concrete is confirmed by the tests, the cells are filled with the mixture. Each cell gets an equal feed. Further, the concrete is distributed from the bottom to the top of each cell equally with a road vibrator. A final layer of concrete is spread out and then the road is leveled manually, which adds precision and perfection to the construction. Finally comes the curing process. Agricultural waste straw along with water is poured on the road. Cell-filled concrete technology provides with the opportunity to recycle plastic, which is one of the biggest environmental hazards today. It reduces the construction cost to a considerable extent in comparison with cement concrete pavement. The consumption of aggregate is also reduced substantially compared to conventional cement concrete pavement. The high stiffness of the material reduces the overall crust, which makes road construction economical. Maintenance of these roads is easy, as in case individual cells fail, they can be easily replaced or repaired. As per the new Technology Vision 2022, it has been made mandatory to use cell-filled concrete in 100% of proposed road length in cement concrete road construction under PMGSY. As the Pradhan Mantri Gram Sadak Yojana uses cell-filled concrete in connecting remote habitations with the network of all-weather roads, we salute our institutes and wait for them to come up with more such sustainable technologies that will brighten up the lives and livelihoods of rural India. A major part of the Pradhan Mantri Gram Sadak Yojana is restoring depleted and damaged roads. for which the project has adopted several new and innovative technologies, one of which is FDR, Full Depth Reclamation of Roads. This is a cost-effective and eco-friendly technology that ensures protection and conservation of the environment alongside reducing carbon footprint to a great extent. Full depth reclamation of the existing pavement layer offers a significantly cost-effective and sustainable rehabilitation method. Apart from rehabilitation of distressed pavement structure, FDR can be adopted for upgradation and widening of existing roads without requiring any structural overlaying of base layers while designing for the same or higher order of traffic category. The process starts with mixed design, which is carried out with a scientific and systematic approach through reputed institutes like CRRI or IITs that balances the existing and desired engineering properties, constructability, durability and economics. Once mixed design is finalized, the next step starts with gauging the level of rehabilitation required. The carriageway is marked with lime. Then comes spreading of cement and mixing of commercial chemical stabilizers like Zydex, Terrazyme, ANT, Stable Road, Roadsem and many others, which is followed by the application of the recycler or reclaimer, which is the main FDR machine for pulverization. Cube mold castings are then sampled from the pulverized road and kept aside for testing. The grader is then applied for leveling the surface. Pad foot is run for heavy compaction and the grader is run again for removing the pad foot marks. The pneumatic tire roller or PTR machine is applied for further leveling and compaction. The cube mold castings are tested for strength and durability after 7 days and then again after 28 days. After the field dry density or FDD test, curing and core cutting, the reclaimed road is open to traffic even before the surface is layered with bitumen. Overall, FDR has great advantages in terms of saving time, energy, minimizing material consumption and cost reduction, where pavement cost is high, transportation cost of aggregates is high, and the quality of aggregate is not good. States like Uttar Pradesh, Bihar, Tripura and West Bengal are using FDR technology, which is a cost-effective construction methodology. Several other states have proposed to adopt it in the near future. Under the New Technology Vision 2022, it has been made mandatory to use FDR where pavement cost is high, transportation cost of aggregates is high and the quality of aggregate is not good. This will lead India on a path of sustainable development towards achieving the goal of a clean and green economy. Among the various new innovative technologies adopted under PMGSY to construct and restore India's rural roads, Koya Geotextiles stands out both in terms of ecological compatibility and cost effectiveness. The coastal regions of India produce more than 55% of the world's Koya geotextile from the husk of coconuts. The industry is marked by the abundance of locally available raw materials and the active participation of women in each and every stage of production. As an agricultural product, the extensive use of Koya geotextile in road construction provides farmers with unprecedented economic opportunities. Koya Geotextiles is a reinforcement technology used for the improvement of subgrades having poor strength. Koya is a biodegradable material. It has a lifespan of 5 to 6 years, within which it provides the road with enough strength and durability to sustain itself even after the Koya has degraded. The technology has various advantages. Koya Geotextile helps in decreasing the pavement layer thickness for given volume of traffic, high coefficient of friction, high elongation of 30% and a high coefficient of permeability. It is also resistant to saline water. As per the new Technology Vision 2022, it has been made mandatory to use Koya Geotextile in rural roads. This cost-competitive, eco-friendly technology is providing rural India with not only road connectivity, but also with opportunities to boost the rural economy to new heights, thanks to Pradhan Mantri Gram Sadak Yojana. The Pradhan Mantri Gram Sadak Yojana aims at connecting the remotest corners of India to mainstream life through state-of-the-art roadways. The pavement construction activities result in significant amount of pollution due to fuel consumption. In this regard, the Government of India is looking for various measures to reduce the contribution of carbon footprint. In this direction, several green technologies have been evolved. One of them is cold mix asphalt technology, which has brought a paradigm shift in the way pavements are constructed.
It's very small session, but it's a very interesting. So I'll request you to please take your seat, and now we are going to begin this session. Those who are outside may kindly come and take your seat. The speaker of this session, there are two speakers on VC, through VC, and then Dr. Manoj Kumar Shukla ji. Yes, you are there. And Shri Alok Bhomik. Yes, you are there. Okay. So just waiting, yes, for the session chair to come. And rapporteur is Dr. UC Sahu. Sahu, sir? Yes. At 9:30, so I'll request all delegates to kindly be in the hall by 9:30 a.m. positively tomorrow, because tomorrow we are thinking that if we can close the session little early as planned. So please note down, tomorrow 9:30 a.m. the sessions will start. Okay, so now we start this session. I'll request session chair Dr. Renu Aneja ji, the team task team leader from the World Bank to kindly come onto the stage. Thank you, ma'am. So actually the best thing comes in the last. So this technical session is the best session of today. You will really realize the best thing is in the last. So please hear it patiently and you will enjoy and you will get a lot of insights and knowledge into these technical lectures. So I must say it's really interesting. So, okay, so now may I request the rapporteur of the session, Dr. UC Sahu from IIT Bhubaneswar, to kindly come and join onto the dais. And then our speakers, Dr. Manoj Kumar Shukla, may kindly come, Principal Scientist, CRRI, New Delhi. And Shri Alok Bhaumik, B&S Engineering Consultants Private Limited, kindly come and join. So, before the session begins, we would like to honor our speakers and the session chair. May I request NRIDA team to come in and offer bouquet as a mark of our respect. Thank you. Thank you. Thank you so much. So now I'll come for a small brief CV of our session chair and speakers. So Dr. Renu Aneja, she is the task team leader of the World Bank. And I know that none of us requires any further her details as her achievements. So I'll just stop at this, saying she is from the World Bank and has been very great support to this entire conference in making many things and conceptualizing it. Thank you, ma'am. And then Dr. UC Sahu, I think I have already introduced him in one of the sessions, if I remember correctly, or I'll just say. He is working as a faculty member at the School of Infrastructure, IIT Bhubaneswar. He holds a PhD degree in the area of transportation engineering from IIT Kharagpur. His interest lies in pavement analysis and design, low volume roads and sustainable road infrastructure development. Presently, he is working on transportation geotechnics, cold mix asphalt, utilization of local and waste material in road construction and recycling. So this is about Dr. UC Sahu. And Dr. Manoj Kumar Shukla, Principal Scientist, is a Senior Principal Scientist and former HOD of Flexible Pavement Division at CSIR CRRI. He has done ME from Transportation Engineering from University of Roorkee. He has R&D experience of about 25 years in the field of flexible pavement. He has served as Deputy General Manager in NHI. At present, he is a member of S2 and S9 Committee of IRC. Then Dr. Manik Burman, who would be joining us on VC through Minnesota University. Welcome, Dr. Manik Burman. He teaches infrastructure materials and pavement engineering related courses at the University of Minnesota. He received his PhD and master's degree in civil engineering from the University of Pittsburgh and IIT Kharagpur respectively, and he conducts research on pavement materials, design, maintenance and rehabilitation, and actively involved in several professional organizations. Then with us on VC will be Professor Kim J. Jenkins from University, South Africa. Professor Kim Jenkins is a faculty member at Stellenbosch University, South Africa. Pardon me for my bad pronunciation. His research area includes pavement engineering, materials engineering, including investigations, testing and designing of solutions. Bridged appropriately between these fields, he found a niche in road rehabilitation and focused on technology development in cold recycling of pavements using sustainable technologies. Then with us, Sri Alok Bhaumik, B&S Engineering Consultant Private Limited. He is the Managing Director of the firm B&S Engineering Consultants Private Limited, and he holds a postgraduate degree in structural engineering from IIT Delhi. He has more than 40 years of design consultancy experience in transportation infrastructure. He is a fellow of the Indian National Academy of Engineering. He has received several awards and citations in his professional career. So I'll just stop at this, and I'll request session chair to kindly conduct the proceedings. Thank you so much.
Good afternoon and good evening, everyone. First of all, congratulations and thank you so much for surviving the 2 days and still you are here for this last session. I must appreciate that. Considering all of you are overwhelmed already with so many presentations, so we have tried to keep this session as brief as possible, and so we will be having only 4 presenters with us, and we'll try to give them 15 to 20 minutes each of them. And 2 of them are here with us, and I have Dr. Sahu with me, who will be reporting at the end of the session, and 2 of our speakers would be joining online. So I must say, since yesterday, you've had like a series of presentations and videos talking about number of technologies, right? New materials, and some of them are old, some of them are new, and as practitioners, most of you are familiar with quite a few of them, right? And however, I think I must say that some of this is still at the research stage and not coming into our actual regular processes. The demand and the supply gap, how do you take it from the laboratories to the research institutions to actual field and establish value chains where, you should be able to proudly say that we are moving into a sustainable road construction practices, instead of the conventional ways of road construction. So without much ado, I would like to invite our first speaker, who is going to take the discussion forward on the some of the additional technologies, fit-for-purpose technologies. I'll not use the word new because some of them are not new, all of us are aware, from the specifically focusing on the sustainability perspective. So inviting our professor, Dr. Manoj Kumar Shukla from CRRI for his first presentation. Over to you. Thank you.
Thank you, Madam. Chairman of the session, reporter of the session, distinguished delegates, ladies and gentlemen, very good evening to all of you. First of all, I would like to say my sincere thanks to NRRDA and especially to Dr. Pateria Saab, who has given me the opportunity to discuss the research work being carried out in CRRI. And especially this work, cement grouted bituminous mixes for longevity of flexible pavement, is really the need of the time. As you can understand, the term cement grouted bituminous mix means this is a kind of wearing course which consists of the bituminous mixes as well as the grouting through the cementitious material. So it's a composite wearing course. We know that in the flexible pavement generally 3 types of failures are occurring: rutting failure and the fatigue. These are related to the load associated. But the other failure, which is moisture-induced damages, and it may occur any time due to the stagnation of water on the pavements. So one of the technologies, though various technologies are there, like the alternate to the flexible pavement is the cement concrete road, but it is a costly affair. So the technology which is being developed and almost being developed to reduce the moisture-induced damages is cement grouted bituminous mix for wearing course. This has got the 2 components. First is to design the open graded high wide bituminous mix. That may be a porous bituminous mix, that will be a single size surface dressing or any type of aggregate gradation to achieve the desired air voids in the bituminous mix. Then filling these air voids with the cementitious material, not the cement. So the materials which are used in CGBM is the aggregate, good quality of aggregates should be used as we use in other layers. Then bitumen, viscosity grade bitumen, VG30 or VG40 bitumen. Then the specially designed grout. That is the blend of cement, sand, fly ash, microsilica, superplasticizer, or any polymer or any additives or air entraining agents, or any commercially available the grouts are also available in the market. So depending upon the requirement, like the flowability and the strength, we can choose the type of the grout. different properties are mentioned like in other bituminous layers. Then the bituminous mixed design. So in CRRI we have carried out various gradations, but the gradation which is to be adopted is being shown here. Two gradings are being adopted for 30 mm thickness and for 40 mm thickness to achieve the air voids. And these are very close to the surface dressing grading. Then to determine the optimum binder content, like in every mixed design, the binder content is the requirement. So in normal bituminous mixes, we go for the Marshall method of mixed design, but here the objective is simply to coat the aggregates. So we have to check the drain down test, that the sufficient bitumen is there, simply to coat the particles, and excess bitumen should not be there. For that purpose, the drain down test is being followed, in which we see that in the drain down test, the binder content, excess binder content should not be more than the 0.3%. So generally it comes around 2.5 to 3%, as compared to the BC mixes where it is around 5.5%. So we have a saving of around 2 to 2.5% of bitumen. And the saving of aggregate is also there, because we have to create the air voids, high air voids, and to create the high air voids, we have to use a single size aggregate. So the saving of stone dust is also there. So two things are there in the saving terms, stone dust as well as the binder. And that voids are filled with the cementitious grout. Then to design in the laboratory, what is the compactive efforts required? Because we have to see the interconnectivity of voids also, so that the full depth grouting is ensured. For that purpose, with these two gradings, we have checked the number of blows required in the laboratory for the compaction purpose. So like in Marshall method, we have to go for 75 blows both the sides, but here 40 blows and 60 blows are sufficient for two types of gradings. So I am giving only the brief idea about this, because the time is limited. Then regarding the grout, we have to see two parameters. The flowability. Flowability depends upon the water content to be added. And if the high water content will be there, then flowability will be more, but we cannot achieve the desired strength. So we have to optimize the flowability versus the strength. Generally 16 to 80% water is added in the grout. And to ensure this, we have to prepare the sample in the laboratory to see the full depth grouting is there or not. Then the mixed design. Mixed design, we have to see the compact porous bituminous mix at target air voids for selected gradation and bitumen content. So now almost mixed design is not to be done by the field engineers. Almost the recipe is ready, and the recipe is based on the extensive laboratory work carried out at CRRI, and we have demonstrated this work through the trial sections also, that I will show you later in this presentation. Then the prepare grout at different water content to see the desired level of flowability to ensure the full depth grouting. Then for the bituminous mix design, we have to prepare the Marshall samples to check the air voids. Through the RICE apparatus, we have to check the air voids. The sufficient air voids are there or not in the open graded high void mix. Then we have to prepare the different samples for checking the strength, because this is a composite material, composite bearing course. So we have to check the properties as it is being used on flexible pavement like bituminous mixes. At the same time, we have to check some properties that are used for the cement concrete pavements also, like the compressive strength and the flexural strength in case of the CC pavement, and the Marshall stability and the ITS value in case of the flexible pavements. So these all parameters have to be checked in the laboratory. We have checked the mechanical properties of CGBM. We call it CGBM, cement grouted bituminous mix. So we have seen that the resilient modulus, which is the design parameter, we generally get with the VG40 between around 3000. But here we can get around 15,000. That is in between the bituminous and the concrete pavements. Then again the very important parameter, the moisture resistance, because this CGBM has been designed especially to overcome the issues of moisture induced damages. So this moisture induced sensitivity test determines that how much we can ensure the tensile strength ratio. That is the test to determine the moisture resistance. So in this CGBM, we can achieve up to 99%, while generally in other type of BC mixes, we achieve 80% or 85% only. Then with respect to the mechanical properties of CGBM, with respect to the cementitious properties, the compressive strength is around 5.4 MPa as compared to the BC mixes where it is around 2 MPa. Then the modulus of rupture is also high. So we can say these properties are in between the flexible and the rigid pavement. Then wheel tracking test, which show the rutting phenomena, which is mostly due to load associated. So that is almost nil in this case of CGBM. So two parameters are highly achieved, the rutting, the rut resistance as well as the moisture induced damages. Then how we have to go about the construction in the field, that is also I am going to a brief demonstration about it also. The existing bituminous surface is cleaned, emulsion or bitumen is spread over it as a track coat. Then layer of open graded high wide bituminous mixes is applied using the paver and compacted with small wheeled roller. Once the compacted bituminous surface cools down to ambient temperature, then and without opening to traffic, the requisite quantity of cementitious grout material mixed thoroughly with water using different pan mixer or other kind of mixer can be poured and spread uniformly over bituminous surface. The first trial sections we have laid with the manual process. Now the mechanized process has also been developed, so the construction will be fast. Then grout should automatically flow into the voids due to gravity and its flowability. No pressure grouting is required. Through gravity it goes inside into the high wide bituminous mixes. Then sweeping or squeezing is also required because excess this grout should not be there on the surface. That may cause slippery on the surface. With simple techniques, mechanized process can be adopted to accelerate the process of grout penetration, like some spray methods. This exercise also avoids formation of thin layer of grout over the bituminous surface. The grout surface is allowed to set for 1 day and then open for traffic. So like cement concrete pavements, we have to close the road for 28 days, but here in CGBM, we are getting the advantage of CC surface, but we don't have to close the traffic for 7 days or 28 days. Only 1 day is sufficient. But somehow some curing is also required for 3 days. We have selected 2 sections in Surat Municipal Corporation roads. So there we have laid these 2 trial sections. This is the surface before CGBM. Then this is the process that the surface was cleaned, then the tech coat was spread, and then the bituminous mix was laid. Then the grouting was done, and this is the finished surface. This is the after 2 days of the construction. Then this construction was done in 2017, June 2017. So now it is almost 5 years, and there is no sign of distress, either in the form of rutting, either in the form of cracking, or in the form of any kind of distress. So, and the traffic is almost around 200 to 300 commercial vehicles per day. And sir, recently we have visited last month in the month of September. So the surface is intact. So that we can say that it is working good for urban areas. So when it is good working for urban areas, then definitely we can implement it for the rural roads also. And I was discussing with Dr. Pateria. Then now it is the high time we have got the performance data also of the 5 years. So we can go for some sections like 500 meter or 1 kilometer sections on the rural roads also. And then sir, we have taken the CGBM course from the field also. And we have checked the properties, that how much we have anticipated and designed in the laboratory and whether we are getting in the field or not. So that we have also checked. And we have also checked the micro-CT through micro-CT images that it is a impervious. Only 2% air voids are there, and that air voids also include the voids in the aggregates also. So it is almost the impervious surface. So what we have intended, we have achieved in the field. And we have also got the resonant modulus through the field taken samples, and it is around 15,000 also at 35 degrees centigrade, but at higher temperature it will be around 10,000. And through FWD also we have checked the resilient modulus. So it is also around 9,800. So it is almost close to the values which we have designed in the laboratory. So based on all these experiments in the laboratory, then the field performance data, we have prepared some specification requirements that can be adopted by the field engineers. So we have given to IRC, and then IRC in the committee, H9 committee. We have prepared the documents also, IRC SP 125, 2009. That document has also been approved. That gives the entire procedure of the mix design, the material being used, the methodology and all. And the design parameters are also mentioned in that code. So now we have got the IRC guidelines also. So the field practitioner engineers are ready. This should, the document is ready and everybody can use it. So this is all about the technology, sir. As far as the cost is concerned, this is a tentative cost. Like for BC mixes, the cost is around 450 to 480 rupees per square meter. But the premise carpet cost is around 300 rupees per square meter. So the cost is slightly higher. But if we see the life cycle, then definitely there will not be any distress. It is expected that at least if it goes for 7-8 years, then it will serve the purpose. And this is very suitable in habitations area, especially in the urban area or habitations area of the rural roads. So briefly we can say that these are the advantages of CGBM, that impermeability and resistance against moisture-induced damages and resistance to permanent deformation. Higher flexibility and absence of joints. Like if you go for the cement concrete pavement, then we have to make the joints also. The construction procedure is lengthy, so that can be avoided. So we can get the advantages of flexible pavement, the advantages of rigid pavements, and we can eliminate the disadvantage or the limitations of the flexible pavement as well as the rigid pavements. And it has also got the high static bearing capacity and distribution of stresses. So initially we can go for the moderate traffic condition, not very high traffic condition, but we can go for the moderate traffic conditions. And we have also checked that like bituminous mixes is a viscoelastic material. So its properties depends upon the temperature and the loading. So we have checked that whether the temperature variability is there or not. So we have also ensured that yes, flexible behavior is there, but not as much as we generally achieve in case of only bituminous mixes. Because at the different temperature, the resilient modulus varies. And skid resistance, though that was the apprehension earlier about that looking the surface looks smooth. So we have checked the skid resistance also on the surface, and we have found that we can get the adequate skid resistance also on the surface. Some of the videos I have prepared. So first, how to ensure the lab grouting, whether the grouting is going inside the sample or not. So this is a Marshall sample prepared with high voids, and the cementitious grout mixed with water is being poured over it, and we can see the grout is going inside the bituminous mix. Air bubbles are coming out. And this another video is about the grouting in the field. First we have done through the manual process only. So we can also see that this grout is going inside into the pavements. Another video is to demonstrate the entire procedure. First is the dry mixing, then wet mixing of the grout with the water, then Mars flow cone test to check the flowability, then preparation of high void bituminous mix. Then grouting through the cementitious material. This is all about the working in the laboratory. Then the trial sections. These are the two roads we have identified and we have laid the trial sections. Application of tack coat, then the laying of high wide bituminous mix. This is the finished bituminous surface. Then the grouting on the high wide bituminous surface. Now we have developed the process of this grouting through the mechanized process also. So it will be fast. So this is the surface after 1 year, after 2 months. We have taken the observations, visual observation, and then we did the FWD test also to ensure that whatever we have designed, we are achieving it, sir. So this is all about my presentation, sir. Thank you very much.
Thank you, Dr. Shukla, for sharing not only the insights on the design and performance characteristics, but also showing us the construction process at the field. And as you rightly said, the technology is already proven in the urban areas, and it's high time to do the performance evaluation across the life cycle of the technology. With those words, I move on to our next presenter, Dr. Manik Burman from the University of Minnesota, and he will be joining us online through VC. Over to you. Thank you.
Hello.
Go ahead, Dr. Manik, we can hear you.
All right, thank you. Would you confirm that if slides are visible?
Yes, slides are visible. Just put it in the slide mode. Yes, perfect. Thank you.
Thank you. Thank you very much. Yeah. All right, so yeah, thanks a lot for inviting me for this really very exciting and important conference. So since time is very limited, let me directly go into the topic. So the topic of the presentation is innovations in technologies, materials, and designs for long-lasting, low-volume roads. I am Manik Burman. I am an associate professor at University of Minnesota Duluth. All right, so a little bit about me. As you can understand, I came from India, so originally from Tripura, the state in the northeast. Until now, actually, I have been in 8 different universities, either as a student or a teacher. I was in 2 different Indian universities, and fortunately, I was a STM member at one point in my life. I know a little bit about PMG SY. The picture at the bottom left corner is my current university's campus. It's really beautiful. You can see the Lake Superior, which is the largest freshwater lake in the world. So now what do you do in this place? You know, this is a very beautiful place. The fall and the summer is really very nice. We go fishing, and you know, in the winter we get a little bit of snow, huh? So, but we do a lot of fun activities too. We go for fishing in the ice too. You can see like this car at the bottom left corner that is on the middle of the lake, 5 miles inside the lake. And then the picture in the middle, you can see like we were doing some ice fishing and then doing eating and all those things. So this is a cabin. Temperature is 20 degrees Celsius inside the cabin, outside minus 37. So we catch fishes too. But that hostile climate or weather doesn't mean that friends doesn't visit. So here you can see Dr. G.D. Ransing Chung from IIT Roorkee who visited me in this place. So, well, thank you very much again for inviting me. I thought of sharing this little bit of experience, like how we live far away from India. All right. So the conference is on low volume road. A lot of my research are in the low volume road. Now, one very important fact, sometimes we just forget the difference between high volume road and low volume road. Yeah, well, as an user we know, but sometimes as a designer, practitioner, sometimes we just consider them road. Now, the low volume road here in USA, we call like when the ADT is less than 400. What Mr. Shukla was speaking, that urban road with 300 ADT, so that we consider a low volume road. Now, the low volume road, why they are different from the high volume road? You know, the low volume road, we do not see diseases like rutting, which I was hearing in multiple presentations. So low volume road have their own challenges. They do not fail generally by rutting because they don't have too much of traffic. Before the traffic induced diseases comes, they fail by environmental induced diseases. So here on the left side of the slides, you can see a block cracking, a pothole here in the cold climate, thermal cracking like in far northern India, raveling. Those are typical diseases in pavement, in asphalt pavement. Or in the high volume road, you can see rutting, fatigue, different types of fatigue cracks. So what I would say, some hard facts related to low volume road, we do not focus on their unique diseases and challenges. We do not make long lasting pavements. We give less importance to them. But as the funding will not come often, I think we need to make long lasting pavements because it's rural road again, you know, focus is less. So, and I don't think the fund comes again and again. So making the road, you know, which can give more design love to do with the smartness thing. And this is good for politicians too. Make long-lasting road and then give tell the voter, you know, if the road fails, don't give us vote. But if the road remains longer, just don't forget us. So that's good for the politicians too. Okay, so two examples of innovations we can consider. There are numerous. So when I got the request for these presentations, I was asked to make presentation on the intelligent compaction. That area actually I have worked when I was in postdoc at the University of Oklahoma. So I said yes, and then but I also added something what I'm currently doing. So one is in asphalt pavement, another is in concrete pavement. Two are very, very different things. And in this country, believe me, only handful of people work in both the areas. But I'm kind of unique here. All right, so intelligent compaction of asphalt roads. Now, why intelligent compaction is required? So now this slide, you know, it's not related to the intelligent compaction, but I'm trying to convince like why an intelligent compaction is important here. So in one of my recent research study, we went to 25 project locations in the state Minnesota. I stay in the state Minnesota. So this is a map of the state. So we went to different locations and collected field cores, as you can see in this picture. From 11 different counties, we collected cores, and then we did a volumetric analysis. And then we found out that the density was around 6%, and the pavement we considered, those were like from 5-year-olds to 30 years old. All right, excuse me, is there any problem? I got it.
Go ahead.
All right.
Go ahead, Dr. Manik.
Sure.
No problem.
Thank you. So the field airborne was 6%. Okay. Now, did we design the pavement for 6% airborne? No. Those who are familiar, with the SuperPave design. Dr. Shukla was talking about the Marshall. So here in this country, we do SuperPave mixture design. So we generally design for 3 to 4% air void. Okay, and we anticipate that with the traffic, the air void will go down to 3 to 4% in its life. But imagine in rural road, we don't get traffic. So the densifications from the traffic is not expected. So the air void really doesn't go down. Now this is SuperPave 4. Now SuperPave 5 is coming, and then those who are familiar, you know, but I'm not spending time on that. Now what happened? If you leave a lot of air voids, so it can keep water, or like in this picture you see here the snow, those melt during the spring and that get into the air void, which creates pothole. So that brings the premature diseases. So we need dense asphalt mixture. Now intelligent compaction can be a game changer. So what does intelligent compaction do? Let's understand that. So in the traditional compaction, as most of you know here in this room or online, so the rollers are used, a couple of different types of rollers are used, and then after the compaction, the next day or the following day, a crew will come, they will pull out cores, or sometimes some non-destructive test will be done to check the air void or density, whether the desert is achieved or not. So post compaction quality control, random check, but under compacted spots actually are not detected because when you pull out core, this is less than 0.1% area probably, right? So it's we really do not know. Now in the intelligent compactions, on the contrary, you can do the real-time compactions. You really can get a sense of compaction on the entire area. Now what is the smartness in here? It really doesn't need a huge lot of investment. Here you can see this is the same typical roller. Only thing is that some sophisticated tools are attached. Here we have an accelerometer, we can measure the temperature, and here on the screen, you know, either the roller operator or an assistant can see what is going on right there. So this intelligent compaction, it can provide georeferenced color-coded stricture showing the less compacted area, over compacted area, and then that gives a chance to fix the right locations, the right time. So intelligent compactions are compaction is not new. You know, several companies are there already who are selling. Now this one, the picture shows it's from Volvo. This one is actually developed or the study we did in the University of Oklahoma. Dr. Shash Kumori, who is a professor, he and his colleague developed. Unfortunately, I worked there for 2.5 years, and then this technology is implemented in Volvo's density directly equipment. These intelligent compactor can directly give you how much density you achieved. Let's say your target density is 95% or 94% of the maximum theoretical density, that can actually give that. So what is the working principle? It's the working, and we call it OUISCA, Intelligent Compaction Analyzer is the ISCA. So an accelerometer is attached on the roller axle that picks up the vibration, either amplitude and frequency that is transformed. Some mathematics goes on, which I'm not going to cover here. And then the picture at the top middle actually shows the compaction structure. This can be seen by the roller operator, and with the smart technology they can use an iPad or any other smart devices. They can just, the roller operator can just hold or have it in front of him or her. You can see here that is fixed here. So so this is an old screenshot when the technology was in the development in our university, but it is really cool right now. You can see a lot of information, so the roller speed, the compactions, a lot of other information, including the locations, the GPS. coordinates. So one simple case study, again, in the interest of the time, I didn't put a lot of details here. We had 2 layers to compact, and this is one rural road. We did in a lot of different projects, but I picked this is for rural road. You see, before we went there, this was a gravel road. It was not a paved road, but first time that it was being paved, there were 2 asphalt layer, and then we installed our intelligent compactor compaction tools with this roller, and then we performed the job. There are 2 asphalt layers. I'm not going into the chemistry or the asphalt layer properties here. I'll skip that. In the intelligent compaction process, we need to do the calibration of the machine. Means, you know, it's kind of a machine. You have to tell that, you have to teach it in the morning that so what is the density, what is the typical density, so those kind of operations is needed. Again, it's really a lot of detailed process. I'll not cover that. So what do we do generally on the very first pass? We also take some frequency and vibration reading. We do some preliminary calibration, and then we can complete the work. And then also after the work, we can come back next day, take some course, and then we adjust our preliminary calibrations to finally find out what is the density. So this is a nice, cool established process and patented. In that particular location, again, I'll just go to this next slide. Here we had 2 layer, base layer and surface layer. So if we had not had intelligent compactor, we would have ended up having 90.9% compactions. But since we had the intelligent compactor with us, we could identify several under compacted spot, and then we could correct them. Okay, so we could increase 1.3% density on that particular job. And for your information, the project was not in the intelligent compaction contract, so we just had to request, and they didn't have a lot of time for us. Okay, if it was a dedicated intelligent compaction project, I believe like we could have increased more. All right, so what is the conclusion? So ISCA can be used in real-time monitoring of compaction quality of asphalt layers. The accuracy was really good. Anyway, so I will conclude this particular case study saying that in rural road, you know, as the density will not come from the live traffic, we should be focusing on having dense layer, and intelligent compaction can be used to do that job. Well, there are certain changes we are making in this country on the mixture design. I am involved in a project where we are specifically developing mixture design procedure for low volume roads. So those are there too, but intelligent compaction can also be helpful. So with that, I will move to the next case study, which is really completely different, and these are the things that I do recently. Fiber reinforced ultra thin and thin concrete pavements. Now, why is it connected to the rural road? Ultra thin and thin concrete. So in these one, we do not provide really thick concrete pavement. I like concrete pavement, you know. So the first concrete pavement was built in America in 1891, and then you can see this picture is still the same. So in Duluth, where I stay, the first concrete pavement was in 1990, and you can see this texture. Those were for the horses. And this pavement is still available, and then I sometimes go there. It's pretty close to my home. This is the first in Minnesota state. When I googled it for India, so I found out 1914, that's the time when the concrete road came in India and Chennai. And these pictures are very close to my heart. This picture, where I grew up in my childhood in Tripura, you know, I saw a lot of concrete pavements. Those were constructed by British people, and believe me, those pavements are still there. I went to India a couple of years ago, and then I took this picture. These are pictures from my the school where I studied, and they're still there. So what I'm trying to tell, you know, once you build them, you really do not need to come back. And in rural road, if we can do that, the maintenance and all those things you can forget. And then that's what I'm trying to tell, that politicians will be very happy if they can make road for 30 years and they say, you know, give us boat until the roads slide. So, all right, thanks for the reminder. So now, you know, in old days we could afford to build very thick pavement. Now in rural road we really cannot build 9-inch, 10-inch thick or even more thick concrete pavement, right? So for rural road, 3 to 6 inch concrete we are shooting for. Now 3 to 6 inch, as they're very thin, you know, we cannot accommodate dowel bars. So what we do, we apply this kind of fibers. Now we have done a case study. It was a 4-year-long project. We tried to see like if we can really construct such thin concrete pavement and how their performance looked like. So we had really long list of objectives. That's the two important I am covering are 3 and 4-inch thin concrete pavements feasible? Do fibers mitigate some diseases? So these are the two questions I picked that I will be answering for. So we constructed a field section at Main Road. Main Road is world's largest cold weather pavement test track. That is in Minnesota. I'm heavily involved with this. So they have like 50 different test sections. You know, in cold weather, it is a kind of the traffic is light traffic. Also, there is a low volume road test track, so you can make pavement and then you can apply traffic load. You can do the accelerated testing. So we had 8 cells with fiber and without fiber at the test loop. I will accelerate here a little bit. So in that cell, in that particular research, we had several pavement sections with different doses of fiber, different thickness, slab sizes, and then we installed really cool sensors. You can see dynamic strain gauge, environmental strain gauge, thermocouple, joint opening sensors. We did falling mode deflectometer. We measured faulting, and then Minnesota Duty has a really cool van which can give you the riding quality. It has camera to measure every little small crack and potholes. Now in that project there was a pavement which was only 3 inch. There was another project which was 4 inch. So the 3 inch, it's really failed quite early. 63,000 ESOLs, equivalent single axle load, and after that you can see the pavement almost shuttered. That was constructed on a 6-inch thick base. So, but one of the beauty of the Main Road is you can really construct and you can fail. Look at the crack, what happened. So we understood 3 inches too thin. Now on the 4 inch we got less crack, but still we got a lot of cracks. 20% slab cracked, even at 145,000 ESOLs, which is far less than the design. So 3 inch, 4 inch on 6 inch base is not a good design. On the other side, we had like 5 inch slab, but 5 inch slab on 11 inch thick base. So one section which did not have any fiber, that gave 3 cracks, only 3 cracks after 4 years. And there were no cracks where we had fibers. So we really could not conclude that fiber helped or not, because only 3 cracks developed. But in the faulting we did. So what is faulting? Faulting is the elevation difference between the approach and lip slab. So you can see here, this blue line was for the plain concrete, and this was for the fiber reinforced concrete, with the highest dose was around 12 pounds per cubic yard of fiber. So that so with the increase of the fiber doses, faulting was reduced, but that needed so that says the fiber can actually contribute. So the conclusion for this is 3 inch slab is too thin for 6 inch gravel. So if in India, if you ever want to construct, don't go for that. If you have 6 inch gravel, don't go for 3 inch. You have to go for thicker one. 4 inch, I would say please don't go to, even if you use fiber, but you can go with 4 inch if you have, let's say, 8 or 9 inch of aggregate base layer. Okay, so or a good base layer with good drainage. So 5 to 6 inch pavements with strong base layer is kind of, I would say, recommend. And for the low volume road, which may see 2 million design life, let's say 20-30 years or little bit over that, so that would be a good design to. So we had several objectives to answer, but in the interest of the time I didn't include that. So with that, I would like to acknowledge all the agencies, my student staff who supported the resources that I am involved with. With that, if there are any questions I would like to take, or otherwise I will hand over to the chair of the session. Thank you very much for listening.
Thank you, Dr. Manik, and thank you for sharing the perspective both on the intelligent compaction and your ongoing research on the fiber reinforced ultra thin and thin pavements. Some of it is very, very interesting and thought-provoking, I must say. And considering the time constraints, I would hold on to questions right now, and let's move on to the next speaker. We'll take the questions after the session. So moving on to...
Thank you.
Thank you. Moving on to the next speaker, Professor Kim J. Jenkins from the Stellenbosch University, South Africa. He's also joining us through VC. Over to you, Professor Kim.
Thank you. Screen. Okay, thank you, Chair and organizers. I'm very grateful for this invitation to participate in this esteemed conference. And to be quite frank, in South Africa, where I come from is, well, close to the city, is the second capital of India, what we call, because there's a large Indian population in Durban, South Africa. So sorry not to be there in India, but I'm suffering a bit of withdrawal of the curry cuisine, but maybe for another time. And I have had good trips to India previously. So let's move on. In the interest of time, I'd like to really talk about what do we take away from the innovative technologies, both for low volume roads and high traffic roads, and talk a little bit about classification of materials and how you investigate rehabilitation projects, and then get onto some of the advances that are taking place in this technology. So let's start with the helicopter view. And as you can see over here, we've got information on the road length, the infrastructure of various countries, starting from the longest road infrastructure, which is the United States. And you can see India's coming second over there, but a big infrastructure network. And ooh, there's China might be catching you up, so you need to be careful of that. But what you see there is South Africa, we're number 10 for a relatively small country. That is quite significant. And on the right-hand side, you see the percentage of surfaced roads. So with that in mind, just taking the cumulative situation, when we talk about different road networks and the global situation, we have about 65 million kilometers of roads, of which 20 million kilometers are surfaced, and the remainder, the 45 million, are not surfaced. So there's almost a 2-to-1 ratio. And this is quite important. But if we look further, if we look at the surface pavements and the structural life, if it's been designed for 20 years, the scary thing is that every year globally, we actually need 1 million kilometers to be rehabilitated. So that's structural interventions. On the rural side, if you just consider annual gravel loss as a result of traffic, weather, climate, as you know, rainfall, etc., etc. As you will see there, with the standard sort of road width and a loss of 25 millimeter gravel per year, one needs 10 billion cubic meters to replace that every year. And what about the sources? Is this sustainable? It definitely isn't. And what can we do about it? Well, there's a need for recycling and upgrading for sure, but we need to do it in the right way. In addition to that, somebody was talking about the evaluation of existing roads and their condition. Here is a good example of what's happened over about a 30-year period. And you will see that the purple and the red parts of the bars, which are the poor and very poor condition, that's increasing. Whereas the condition of the road measured with the green and the light blue, that powder blue, those are the very good and good conditions, and that's decreasing. That's telling us, the picture that we get there is that this road is not withstanding its bearing capacity. And if you look at that little comment down at the bottom, you will see that more than 20% of America's roads are in poor condition. And that's a fact. So this is not restricted to countries with low volume roads or developing countries, etc., as opposed to the first world. This is a global issue that we need to take care of. And in addition to that, if your maintenance backlog gets to more than 2 times the annual budget, you're in big trouble, because you're not going to catch up and, let's say, plateau out those conditions that are shown there in the graph. So it's going to take quite some time to get on an even keel. What's also important is we've got to get into the detail, the materials. We look at load spreading and the resilient modulus, or loosely the stiffness of the different layers, are what spreads the load. And we need to spread the load widely enough to be able to ensure that the subgrade isn't overstressed. And I'm just going to get this highlighter, the laser pointer. So in order to avoid this overstressing of the subgrade, we need better load spreading. So the granular materials, depending on the type of pavement, cannot distribute the load well enough. And this is where we need sufficiently stiff materials to be able to spread the load, and the load over a larger area results in less stresses reaching the subgrade and better performance. So those are things we've got to consider. And there's a lot more detail related to that. In addition, what are our options if we want to have durable solutions? Well, bitumen is a durable product, so it generally keeps the moisture out if it is used cleverly and reliably. So here is just bitumen, foam bitumen, and emulsion. And these two technologies basically reduce the viscosity of the bitumen so that it can be mixed into cold aggregates. That's predominantly what they do. And bitumen emulsion, as you can see on the left-hand side, does more of a painting process, whereas the foam bitumen has these little spot welds of flexible bitumen that is used in bitumen stabilization and flexible pavements. We call it BSMs. Now, when I spoke about the unsurfaced roads and unpaved roads, there has been a change over recent years. If we look back to 1995, where we were involved with one of the very first recyclers from Germany. And here, this is recycling and upgrading a low volume road. And that's quite some time ago now. And this can also be surfaced then. It gives you a durable road. And then on the other hand, this was another venture that was, I think a few of us lost a fair bit of hair or got gray hair at that stage. And this is an implant mixer using foamed bitumen and paving that on an extremely steep 13% grade that carries a lot of traffic, because at the bottom of this hill is an asphalt producer as well as a concrete producer and a crusher. And various options were provided. The mix was stockpiled for 3 months before it was used. But hey, presto, 3 years later, and this climbing lane on the left-hand side, because we drive on the left-hand side, took 2 million standard axles up there, just as you can see here on a 19mm single seal. It's a little bit like what Mike Pinard was talking about, with an asphalt on one side and a single seal on the other side, with these steep grades. And there's some examples of the trucks that are hammering that road, still performing well. And to this day, this road is performing well. So there are elegant and efficient and economical solutions if you look for them. This is more recently, well, it's 2004. That's already about 18 years ago. And here you'll see RAP, reclaimed asphalt, put through a plant mixer. And you saw that previous plant mixer, that was a bucket of bolts. This is now something that is far more efficient and reliable. Same story, mixing with foam bitumen into the truck into the paver, and it's paved like asphalt, but there's only 2% of foam bitumen added to it and 1% of lime. And you can see this on the right-hand side, the paving. People think that, oh, we don't need to put a surfacing on. Unfortunately, you do with the reasonably high traffic. And that is because the voids are not, this is not asphalt. It's bitumen stabilized material, and it needs a waterproofing layer on top. Okay, because the voids are usually around about 10%. So just reminding ourselves, what are we talking about? In a two-dimensional matrix, we've got the cementation on the vertical axis and the flexibility, the bitumen on the horizontal axis. Obviously, with asphalt, you're going to get flexibility. With adding cement, you're going to get rigidity. The bitumen stabilized material uses about half of the percentage of bitumen, and it only needs up to 1% active filler to give you this non-continuously bound layer, which has many benefits, which I don't have time to explain at this moment. But what I'd like to emphasize is that in this plot, there's this invisible boundary between distress by rutting or distress by fatigue. Here in the rutting zone, if you don't overload your bitumen and particularly your active filler, you don't want to move into this vertical zone, then you can get performance that requires just filling of ruts or mill and fill, as opposed to fatigue cracking, which is a broken road and much more difficult to fix. So that's something we must remember. This technology of cold recycling, and particularly with bitumen stabilization, it started with, in the 90s, we were involved in it at that stage, right in the early 90s, with small amounts of asphalt. So the recycled one had less than 50% RAP. So it was dominated by granular material. Still works well. But more recently, as the reliable technology has shown its benefits, deeper and deeper packages of asphalt are being recycled, giving more than 50% of RAP and getting some domination of that, the RAP in the behavior and the improvement of the shear properties. So this is from 2000 onwards, where we're also seeing more in plant mixing as well as in situ, which was predominantly where it started. How do we select in place versus in plant? There are numerous factors that need to be accounted for. Reliability is of the material, and variability, if there's a fair amount of variability in plant, works very well. In place has less transportation costs, etc., and has got a down milling capacity as well with these recycling machines to get good gradings. So there are a lot of possibilities that one has to select, and you need to have the experience and the knowledge as how to implement it. Our carbon footprint globally is something that challenges us all. We don't want, if you plot energy consumption, the vertical axis, and the aggregate temperature that you have to heat up the mix to on the horizontal axis, we don't want to get past 100 degrees. Otherwise, we've got to dry off the moisture. If one works way down here on the left-hand side with no added heat to the mix, we're using very much energy. There's still some energy being used. And that's where we're focusing on. Where else does it help us? Well, emissions, because the COXs, the NOXs, COX, NOx, and SOx, 100% over there, and if you take that as 100% emissions over there, you look at the reduction, we're down to less than half of that, significant amount of reductions in emissions. So this is something that one really needs to take cognizance of. Again, just the use of energy, this is the big picture, a lot of different possibilities of binders, aggregates, manufacturing, transport, etc. And you will see there that the cold recycling has a very small use for the energy. Okay, so we're talking about different ways that we investigate. We've got to do this properly. We need to combine all of this information of deflection measurements, pothole, test pits, and using that information to design what's going forward. And you need very good information. Some of the advances we've got is this way of compacting in the laboratory that reflects what's happening in the field. Here we've got a roller, and this rolling at frequency and amplitude is nowhere near a drop weight hammer. However, vibrating hammer fits right in there. So we're working with those aspects. An additional one, just very quickly, is if you get your mix design right, as well as the performance over time, this is over 4 years, the stiffness, and you can see it's plateaued out, which means that you've got good support and that you're not losing stiffness over time. Very important. Another addition is actually for high-level mix designs, we do BSMs in a triaxial mold. You can see there's a tube that you inflate, that's a confining cylinder, and you can do your tests at different confinements. And I'm not going to go into this, but just to show you that the cohesion on a Moore Coulomb plot goes through the roof when you add foamed bitumen and 1% of lime or 1% of cement, giving you much higher shear properties. And that's what we need to get the performance. Because this semi-blast slide that I'm showing you here gives a deviator stress ratio, which talks about what's the stress in the layer versus the stress that has been, the failure stress that's been measured in the laboratory. And as soon as that ratio, 60% becomes the ratio, your rating is going to be much higher than if you can control it with a proper design and have a low deviator stress ratio. So, Chair and the rest of the delegates, I'd just like to highlight that there are so many different suitable projects. You've got to get out there, get the knowledge, and realize which one is appropriate, whether it's in place or in plant mixes, and whether it's in an expressway or a superhighway or a low volume road. This technology is useful all over, and you can get some idea of the lives of the road here, where you've got just over 3 million standard axles now using that road over its design life. And on the other end of the scale, you've got 150 million equivalent standard axles working on an extremely heavily trafficked Chinese road. And this was that Greek project, also very high traffic on expressways. So one has to have understanding of the materials, the strategy, the types of terrain that you're working in, and the obviously designing for the levels of traffic that are there in that particular road. So to finish off, here's a cross-section of a recycler. We need to have reliable classification of the materials, know what we're working in terms of classifications. We need bitumen and active filler for flexibility, new equipment, new types of equipment to get accurate mix designs and quality mix designs. And then finally, we just need to have that bitumen to provide the durability in flexibility as well as moisture resistance to give us performance. And with that, I'd like to say thank you very much for your attention.
Thank you, Professor Kim. And first of all, I would like to thank you particularly for bringing the big picture on the maintenance backlog and showing us the reality on the annual rehabilitation needs. And it has been an eye-opener at the global level. So I think that will give us a lot of food for thought for today. Thank you so much. And moving on to our last but not the least speaker to take you over to the bridge systems is Shri Alok Bhaumik from BS Engineering Consultant Private Limited. Over to you. Thank you.
Thank you, Madam, and good evening to you all. First of all, before I start my presentation, I must thank the organizers for inviting me to give this presentation. I must also thank the delegates. I'm very reasonably happy to see so many people at the, at 7 o'clock listening. This is the 23rd lecture today, and all high quality lectures you have been, watching and absorbing. That's commendable. So let me, without further ado, get into my presentation. The topic of my presentation, as you can see here, is modular pre-engineered bridge systems. And what I'm going to talk about is the state-of-the-art procedures or practice that is being followed all over the world. And even in India, there is a lot of emphasis now to, particularly for the rural hill roads, to have bridges which are modular, because there are distinct advantages of using modular prefabricated bridges from consideration of sustainability in specific cases. Most of us, when we talk about modular bridges, we think of Bailey Bridge, because it is Bailey Bridge which is synonymous with the term modular bridges, though it's a myth, because there are several manufacturers today all over the world who are building bridges of modular pre-engineered types, and many of them have brought in new technology and the latest technology, and they are much better than the concept of Bailey Bridge, which was initiated in 40s. So this is the broad outline content of my presentation. Without much further ado, let me start with the basic introduction. The first thing is as a definition of modular bridges. What is a modular pre-engineered bridge? So if it is a modular pre-engineered bridge, means it has to be pre-engineered. The engineering will not start after selection of the alignment. You already have a standard design in a modular form which is readily available, and they have to be used for a given span. So the design is such that it is flexible. It can be, extended to spans in a particular 10 feet module, and you can put the panels one over the other, one on the side of the other, to increase the strength depending upon the loading and depending upon the span. Second, mostly these panels should be available in stock for ready use, because mostly these modular bridges are extremely useful for emergency purpose, for temporary use where you have to do it. Suppose there is a disaster management you have to do, some bridges gets washed away and you have to restore the bridges within no time. Then this is the solution, and therefore the owner client should have readily stocked available material for ready use. They should be delivered at site in standard trucks to how to assemble. And it is generally built in a very controlled environment, because these modular bridges are not prefabricated, they are manufactured, they are not fabricated. So therefore it has to be a controlled environment, and that increases its design life significantly as compared to the bridges that we fabricate on site. Now, next question that comes to our mind is, what is the utility? So there are three distinct functions that the modular bridges perform. They can be used as temporary bridges, as I mentioned. Suppose there is a particular span which gets collapsed in a river, and you have to immediately restore the bridge, because once a particular span goes down, then the whole link is cut off. So if you want to restore the bridge link, then that particular span you can use a temporary bridge, and maybe once the temporary bridge is there and the traffic is restored, then you can build the permanent bridge later. Second is emergency bridges. There can be an emergency situation where you need a bridge. A good example I would give is, if you all recall, in 2010 Commonwealth Games, just 10 days before the Commonwealth Games, the footbridge close to the Jawaharlal Nehru Stadium during under construction collapsed. And within 5 days, only 10 days were remaining, and within 5 days, Army was called upon and they built a modular bridge there temporarily for the games. And after the games, that particular bridge was removed and the original bridge was restored. Third is the permanent bridge. Now, a general conception or myth amongst the people is that modular bridges are meant only for temporary purpose and the emergency purpose and the military purpose. But this is not so. The third generation bridges which are being built nowadays, they are also used for permanent bridges all over the world. In fact, in India, in Uttarakhand, after these 2013 floods, there was one bridge at Sonprayag which was built using this concept of modular prefabricated bridge, and that was erected in 5 weeks just before the Yatra. So you can see the importance of the bridge and the importance of having a concept where a bridge can be built in a few weeks rather than months and years. So you see, difference between a temporary bridge and a permanent bridge is its design life. When you say that this bridge is a temporary bridge, that means the bridge has to be designed. There are 3 or 4 factors only which are different. The strength of the material remains the same, but its fatigue life can be less. You can have a relaxation on the fatigue life because it has got a limited design life. Second, it can be designed for a lower value of climatic forces like earthquake and wind, because the return period for which it is supposed to be designed can be less. Otherwise, the design philosophy of permanent or temporary bridge remains the same. This is a typical example of permanent, temporary and emergency bridge. What you see on the left side is the Sonprayag bridge in Uttarakhand, which was built post 2013 floods. And what you see at the bottom is a temporary bridge. You can see that the permanent bridge is under construction, and on the side, a temporary Bailey bridge is there to take the traffic. And emergency bridge, you can see that particular one span got collapsed. What you see on the left side of that picture is the routine trussed type of bridge, which was replaced by a Bailey bridge only for one span temporarily as an emergency measure. And this is the picture of that famous footbridge at Jawaharlal Nehru, near Jawaharlal Nehru Stadium, Commonwealth Games, which I just now mentioned. Now, a bit of history about the modular bridges. The modern day prefabricated, modular bridges started in 1935 by a person called A.M. Hamilton. In 1935, he got the patent. It is not Bailey who got the patent first. It is Hamilton who got the patent first. And it is only later that the original design of Hamilton was improved upon by the British engineer Bailey. And it became such a popular hit that thereafter, most of the bridges till 70s and 80s were all of Bailey type and all over the world. Even in India, we have a stock of Bailey bridges for military purpose, for emergency purposes. So this is Sir Donald Coleman Bailey, the picture, the person who actually, though it was originated by Hamilton, but actually the progress of this concept of modular prefabricated bridge was done by Sir Donald Coleman Bailey. These are some pictures of modular bridges of olden times. Between 40s and 70s, these modular panel bridges were used essentially for emergency and military purposes, and they had certain limitations which I will explain. But thereafter, from 70s onwards, the design of modular bridges has evolved. Systems have improved, modularity has been improved to maximize the utilization. Earlier, original Bailey Bridge was only meant for single lane, and it had a limitation of the span. But today, the modular prefabricated concept can be used for a span as much as 120 meters. It can be for 2-lane, it can be for single lane, it can be for even a higher special vehicle loading or other heavy loadings as well. Then these painted bridges are replaced by galvanization to increase the service life, to reduce the maintenance cost, and to protect the environment. And multi-lane bridges are also developed with this concept of modular bridge, which was not there in the original Bailey. Let me get into the system and details of the bridge components. May I know how much time I have left with? Okay. So these are the various type of systems which are prevalent today. So earlier it was only Bailey bridge system and Callender Hamilton bridge, but today we have about many. I mean, I have just listed 7, but there are many more who are producing these bridges of modular types. So this is Callender Hamilton Bridge. The Northern Railway is in possession of this kind of bridges in the stock. Whenever there is a failure in railway bridges, they come and erect this Callender Hamilton girder bridge system. In their maintenance schedule, it is all there. The people are well trained to use this kind of Callender Hamilton girder bridge system in railways. This is a Bailey bridge system. We have many manufacturers in India like GRAC, Garden Reach, Bridge and Roof, Titagarh Vaughan Limited. They are manufacturing in India this system, Bailey bridge system. Yeah, I'll finish it in time. Then we have the next third generation Acro bridge system, which are of modern types, which can take multiple lane, which can go up to a span of 80 meters. And there are many advantages. I am not reading the text here. These slides are available to the delegates and they can read it. But this Acro bridge system is a modern modular bridge system, and what you saw in Sonprayag is an application of Acro bridge system. These are various modules in which it is available depending upon the span. Then we have this Bird MBS modular bridge solution, which can go even up to 120 meters spans. It can be of variable depth, and so it is an evolving system. Typical bridge components comprise of deck, the transoms and the true panels, which is shown. You can see the truss panels, which are the main load-bearing elements, and they are their transfer girder is a deck. The deck is supported on the transoms, which are transverse girders. So there are three essential structural elements, which is typical bridge components of Bailey Bridge. In terms of manufacturing and fabrication, as I mentioned earlier, the modular bridges are manufactured and not prefabricated. So when it is manufactured, that means it has to be a factory environment where the quality can be ensured, and it must be ensured. Then there are desirable quality control process for the manufacture. If you want to use it for permanent bridges, if you want to use it for emergency purpose for heavy loading, then the quality is absolutely important. There are three silos in which this quality control process are to be ensured. One is in the factory, one is in the engineering services. Mostly these manufacturers, once they give the product, they sell the product to the client, there has to be an after-sale service to ensure that these stocked panels are well maintained, so that actually in emergency we can use it. It should not so happen that when you take out the stock, you find that they are corroded, they are not used. So a high regime of maintenance is an absolute must for this kind of modular bridges. There has to be on-site technical support from the manufacturers during the erection, during the assembly, and even during the maintenance. So the system has to be like that. So to come to the conclusion, modular bridges play a vital role in the immediate restoration of rail or road communication and in developing connectivity to forward areas in new road construction. Modular bridges are also very useful as permanent bridges in remote areas where conventional bridging solutions are not easy due to problems of access, manpower to execute and supervise and maintain. Thank you. I thought I finished in time.
Thank you, Alokji, for sharing the utility of the modular bridges, not only for the permanent but also for temporary and emergency works. So, with this, I think I would like to take the opportunity to leave two food for thoughts for the day. And considering you've heard so many technology providers, considering you've seen so many technologies being presented here and materials being presented here, two food for thoughts for you for the day. Some of the technologies have been here for 8-10 years and they have proven their worth. However, I think the biggest challenge, in my opinion, still remains is how do you mainstream these technologies and incentivize them at a larger scale in the regular business processes so that they can be adopted in our regular road construction, not only, but also in the maintenance practices. That is something that we all have to think through, what incentive mechanisms we need to build through for mainstreaming these technologies at a larger network level scale. Another important point, is it possible, I know CRRI had taken some steps few years ago, but I think in the interest of resource efficiency and sustainable economic development, it is important to start mapping the local materials and their availability across the country, including their lead distances, and then building their specifications. That will go a long way in changing the way we design our roads and do construction and maintenance of the network. So with that, I will request Dr. Sahu to quickly sum it up for us for today.
Okay, thank you, ma'am. And thank you for smoothly conducting this session. We had 4 good presentations in this session, 3 on roads and 1 on bridges. The 3 presentations on roads basically talked about how to improve the life of the pavements. The first one on cement grouted bituminous macadam, which was detailed discussed by Dr. Manoj Shukla, where he discussed about the CRRI experiments, both lab and field experiments, how they have conducted or they have carried out the test, as well as the field implementation in Surat Municipal Corporation, and with that how they can improve the life of the pavement. So they suggested that can be used for low volume roads and to improve the life of such pavements. And whereas Dr. Manik Burman from University of Minnesota he banked on intelligent compaction methods for improving the life of pavement. At the same time, he also discussed on ultra thin and thin concrete pavements with fiber reinforcement for improving the life, and he told that for low volume roads we can go with at least 5 to 6 inches of ultra thin concrete with fibers over at least 250 to 275 millimeter of base course. So that will have good life instead of just randomly or ad hocly going for different thickness. We can it should be based on research as they have done on test tracks in University or in Minnesota Transportation Department. The third lecture was by Professor Kim Jenkins. He basically talked on bituminous stabilized materials. So BSM, use of BSM using bitumen emulsion and foamed bitumen, where he said that the unbound granular subbase and base layer can be stabilized with bitumen emulsion and or foamed bitumen suitably by adding 1% of lime or cement, and that can give you a very good base course. Over that you can put a very thin surfacing layer that can be in form of a single coat chip seal or maybe a 30 mm BC course that will improve the life of the pavement. So all the three presentations talked about improving the life of the flexible pavement, and the last presentation and the single presentation on bridges by Mr. Alok Bhomik, where he basically focused on modular pre-engineered bridges and the famously known as Bailey bridges, so which we know, and before this presentation I was also not knowing that Bailey was not the first person. It was Hamilton who was the first person who actually patented this product. So thanks for the information, sir. And really it is actually, he talked about how this kind of modular bridges will be very much useful for temporary as well as emergency cases, and also permanent, it can be used for permanent bridges. So we have been, I think in PMGSY roads, many locations, remote locations, we have been using Bailey bridges for a long time. And he told that we can now construct up to 120 meter span modular bridges. Research has increased to that extent, and then multi-lane bridges can also be constructed using modular bridges. So that's good to know, and so thank you all the presenters and thank you, ma'am. So with that I conclude.
Yeah, thank you so much, session chair and the rapporteur and the speakers, and thank you audience for your patience hearing, and you have been going through all these lectures for the whole day. Now, as a mark of our respect and the token of appreciation, we want to give our mementos to the esteemed speakers and chairperson. Thank you very much. With this, we come to the end of today's proceedings, and tomorrow we would be starting at 9:30. I would request all the participants to please be here at 9:30, and then we would be doing our session accordingly. Thank you so much. Have a good day. Thank you so much.